there, welcome to this Applied Data Science with Python course by Simplilearn. If you've ever wanted to dive into the world of data science and learn how to turn raw data into powerful insights, then you are at the right place. Whether you're a beginner or have some experience with Python, this course will take you through the key tools and techniques to help you tackle real-world data problems. And by the end, you will be comfortable using Python libraries like NumPy, Pandas, and Matplotlib. And you will have a solid understanding of the data science pipeline. So here's a sneak peek of what we're going to cover in this video. First, we'll start with the basics of Python libraries, including NumPy, Pandas, and Matplotlib, which are the backbone of any data science project. We'll also walk you through the data science pipeline, a roadmap for solving data problems. Next, we will dive deeper into Pandas, learning about series data frames and lambda functions, which are essential for working with and manipulating data. Then, we'll move on to some advanced Pandas techniques, including data inspection, column operations, and how to aggregate data. You'll also learn how to visualize data with Matplotlib and explore different chart types. After that, we'll jump into exploratory data analysis, EDA, where we will explore charts, histograms, scatter plots, and even heat maps to uncover pattern and insights. We'll also cover key statistical concepts like central tendency and aspiration, and tackle data cleaning and outlier management to prepare you for data analysis. Finally, we'll explore more advanced concepts like skewness, kurtosis, and data pre-processing. We'll also touch on probability, which is the foundation of many data science models. Also, if you're looking to kickstart your career in data science, then I highly recommend checking out the Data Scientist Masters program in collaboration with Microsoft and Simplilearn. This 11-month program offers live interactive classes led by top industry experts, giving you hands-on experience with AI-powered tools like Python, SQL, and machine learning. You'll also work on real-world projects, including a capstone project, earning Microsoft certificate along with Simplilearn Data Science certificate to showcase your skills. So whether you're a beginner or looking to upgrade your skills, this course is perfect for AI enthusiasts, students, and recent graduates. And the best part is, you will get career support to help land your dream job. Enroll today and start your journey towards becoming a certified data scientist with real-world expertise. To get started, here's a quick quiz question for you. The question is, which Python library is best for data manipulation? Your options are NumPy, Pandas, Matplotlib, or Seaborn. Let me know your answers in the comment section below. So without any further ado, let's get started.
We are going to get started with this. Now, see, let's understand the journey to data science, right? So whenever you talk about any data science project, there is a crisp DM framework that we follow. We'll be studying that later, but you are doing a data science project. So like this. So whenever you talk about any data science project, so it will be always going through these all things. I'll just let you know in short what I mean by that. So whenever you have a project from the client, the first phase is where you understand. So let's say your client is Pfizer. So you understand what are they into, what is their domain, what is their problem statement, what are the challenges that they are facing. So a business analyst comes over here and understands all these things. Then he propagates the requirement to the technical team who will be getting the data, right? Who will be getting the data and starting to analyze the data, right? Because in a data set, let's say Pfizer, right? So there will be all pharma related terms. As a data scientist, you will have to understand each and every column and correlate it with the domain knowledge, because if you don't understand that, you will not be able to solve their real life challenges. So data understanding comes. Then after the data understanding comes the data preparation. So data preparation is the phase where the data in real life will never be as clean as expected. You expect the data to be awesome, but it's going to be worst. You really have to make your hands dirty for cleaning the data. So cleaning the data, doing some visualization on the data. So this is where your libraries like NumPy, Pandas, Matplotlib, and Seaborn comes into picture, right? So we are going to see this, right? So all of this comes into your picture. And then comes your modeling. This is where your machine learning comes into your picture. So the library that you learn is scikit-learn and some other libraries, but mainly scikit-learn. If you are doing deep learning, you learn TensorFlow, and then you get into evaluation of the model. So obviously, first you analyze, clean the data, then you create multiple machine learning models because one model may not be the best. So you try to create many, just like in a class as a teacher, I'm teaching to all of you, and then I am choosing the best student. Okay, so I have to send them to some Olympiad competitions. I will choose the best student, and that is what happens in the evaluation stage. So in evaluation stage, as I told you, you select the best model. And after that best model is selected, you get into the deployment stage. And deployment means obviously you have to share it with the model. So you productionize it. So today we are here in understanding these libraries. And once you understand these libraries, then you are good to get into this flow in the machine learning part, not now. But one thing I would like to definitely say that if a data science project, if you are talking about a data science project, and if a data science project, let's say it's taking a total of 100 days to complete successfully, then I want to say that 70 to 80 days go in phase 1, 2, and 3. Then I would say 10 to 15 days go in 4 and 5. And another 10 to 15 days go in 6. So although machine learning is so important, but for actually creating models, it does not take that much time. The highest amount of time taken is over here for getting these all things aligned, right? So this is something which is very important for anyone to realize. So data preparation stage is one of the most important thing. Okay. So that's how the overall data science pipeline is. And also, at times, if you are not able to create a good model, you can also see that you may have to go back. So let's say you do this thing in a little bit hurry and you try to create a model quickly. Your model will be worse, something that, client will just not accept. So you may have to go back and do this. In fact, here also, if you do any misunderstanding, you may have to go back and understand the requirements. So it's not an easy job, friends. So that's something important to be understood by all of us. Okay. Now, we need not get into all of this. This was just to give you an idea. What is more important is getting started with the NumPy library. But, this helps you understand the overall flow. What are you learning and Why are you learning? One of the model, which is productionized, looks something like this. So what are we essentially doing over here? I have hosted this model, which is productionized using the Streamlit app. So if you say this is a tick prediction app, we will be actually dealing with this data set when I explore for you the Cvon and Matplotlib. So that data set we will be looking into at that point of time. Right now, it's not important, but this is that data set for a US restaurant where I am trying to predict what will be the tip that a customer is likely to give based on his or her total bill, how many people visited in all, the gender of the customer who paid the bill, whether he smokes or not, the day on which he visited the restaurant, and whether he visited for lunch or dinner. So you can actually play around with this. Let's say I go to the restaurant and my total bill is $15. It's a US data set, $15. And I went with my wife. So total two people. I was the one who paid the bill. I do not smoke. I went on Saturday and I went for dinner. So if these are the parameters, I'm likely to give a tip of $2.45. And in the same way, you can play around. Let's say Darshan went for a lunchtime, then $2.55. If Darshan smokes, or if the customer smokes rather than saying that, then this is the one. If I went ahead and let's say this is not me, this is some female, then the tip given is this. And if it is a male, then the tip given is this. So male gives relatively long, a higher tip is what we understand. And smoker is giving 2.36, non-smoker gives relatively higher tip. So these are the things that we understand. You can also take a moment and try playing around with this because this is deployed on the cloud. So one can try that out. Now this deployment part, which I showed you, that comes at the end of machine learning or somewhere at the end of deep learning. Furthermore ahead. How does the data look like in this case? It's a CSV file. It looks something like this. This is how the data looks like, where this is the dependent variable which I'm trying to predict on the basis of other factors. Yes. So we'll be working on this data set as well later on. So now let's get started with NumPy, right? So getting started with NumPy. Um, oh, so what is exactly NumPy? Well, NumPy is the backbone of machine learning and data science in Python. It is one of the most important libraries in Python for numerical computing. See, you need to understand num in NumPy means numerical and pi means Python, right? And NumPy Why NumPy? I know lists. Why NumPy? I know the topic list, then why do I need a NumPy array? Because NumPy is super duper ultra fast. So NumPy is almost 10 to 15 times faster than list. That is what you need in data science, right? So NumPy supports large multidimensional arrays along with the collection of the mathematical functions. Next, it is very powerful for doing this, and it is super fast and efficient as it is implemented in C. Now, C, talking about Python, yes. So if just if I go back and if I say I want to write a function to check if a not check function to find factorial of a number. That's how you write it. And then while testing, you test it like this. Right? This is a recursive function to find factorial of a number. That's how you write it in this. So when you are giving a call to this factorial function, then control goes over here and some logic is applied to do the things. Okay. So the function, right? If you see over here, this function is in Python language. However, NumPy is implemented in C and Fortran. And that is why it is till today, one of the fastest language is C only. C, C++ are the fastest language. So whenever I am going to call some NumPy function, then the body of that function is written in C, mixed language programming. It is called as Python. I'll show you. Uh, can you show the body of any NumPy function as it is written in C language? You can see over here. I think I did not give it properly. So, see, whenever you are giving a call, right? So, how does Python use the and how is it implemented in the backend? Because whenever I'm saying sum, it will find out the sum of the array. So, in NumPy, finding the sum is this as simple as that. But in the backend, the code looks like this. And in return, when array sum is called, there is a Python code which is getting executed. Right? So that is I want to say, right? So that is what is called as Python code. Python and C together, you call it as Python, and it looks something like this. We are least bothered about it, but I am explaining you how they have created all of this. Huh? How they have created all of this. This is not important. This is not important, but internally, whenever I'm giving any call, this is how it is happening. Okay. So that is why I said NumPy is super fast. Do we say the operations of NumPy are vectorized in nature? Vectorized. Vectorized means the body is written in C and C++. Okay. Now, One last thing. Is that the only difference between a NumPy array and a list? No. Also, one more thing. NumPy creates arrays, and arrays are collection of items of the same type. Very, very important. List can have items of any data type, but array compulsorily of the same type. Now, how much is NumPy important? Well, too much important. Uh, just to show you, I'm just randomly opening few of the deep learning case studies. Right? I'm just randomly opening few of the deep learning case studies and one machine learning case study as well. So if you see over here in this deep learning case study of image classification, I'm importing the NumPy. And what all functions of NumPy have I considered using over here? You see np.newAccess, np.arange. Then I say np.where, np.random, right? So I may not be able to explain you what are we doing over here, but I just wanted to show you that it is getting used. NP is what I have imported NumPy as. Similarly, over here as well, you see np.expandims, np.arange, np.where, np.random. Similarly, np.round, right? Then flatten function, that's also of NumPy. np.mean, okay. np.log. So this is just to make np.array. This is just to make you understand that, see, boss, this is required. This is just to make you understand that it is required. And you know what? See, when till 12th standard in the examinations, they never allowed us means we, the engineers, to use a calculator in the exam. But in the engineering, when we took admission, all of a sudden using calculators was allowed. So at that time, why didn't they expect me to do all the calculations by step? Why was a calculator allowed? Because calculator was mandatory at that time. When I was on 12th standard, I was in 12th standard, 10th standard, or anywhere below that, right? First, second standard, right up to 12th standard. Well, I was doing all the simple math. But now I am doing advanced math. So I am already assumed to be a pro over here. So when you are doing the advanced mathematics, if you need something, you use that, go up and continue coding the advanced level. So at that time, NumPy is like this, assume this entire thing to be like NumPy. The basics are over here. So whenever you do any machine learning stuff, you need not implement all these small things. For that, you can say, NumPy, could you please solve my issue? And it will do the needful for you. Right? As simple as that. So coming back, that was just to make you understand the practical significance of this topic. Okay. Okay, so now let us get into NumPy. Let us start with NumPy. So first thing is we will have to import the NumPy library. That's just import NumPy. So import NumPy as NP. Now, is it mandatory that you import it as NP? No, it is. It is a de facto standard to label it as NP, but it is not mandatory. So, but most of the people, or rather than saying most, almost everyone labels it as NP only. In fact, if you go to Google and look into any of the documentation as well, you will see that NumPy library only in picture. So import NumPy as NP. And then I would like to print the version of NumPy that comes as np dot double underscore version double underscore. Double underscore, sir. It's 2 times. And done. Now, if you go to Colab, maybe your version is different, but that does not matter, right? You just need not worry about it, whatever be the thing. Now, let us create a one-dimensional NumPy array. So first thing is syntax. np dot array, you have to give the data and the d type. You have to give the data and you have to give the d type, where data can be array-like object and d type will be this, and also d type is optional. If not provided, NumPy will infer it by itself. So if it is optional, I would like to, first of all, play around with it. So I say, I want to create a NumPy array. So I'm using the array function np dot array, and you can pass in a list or a tuple or a set, and it will create a NumPy array for you. But as I told you during the basics of Python, that whenever you do this, always 95% to 98% of the times you will be using list only. So I'll be using a list. So let's say if I say 1, 3, 5, 2, 8, these are the things. So I will print that array and also print the data type of that array. So print the data type of that array. Then after that, you see this. Now, how is a NumPy ideally array is created? So NumPy array, look at this figure. 1, 3, 5, 2, 8. 1, 3, 5, 2, and 8. This is exactly same like list. Yes. 0, 1, 2, 3, 4. In fact, -1, -2, -3, -4, and -5 as well. As you all can see, this is a 1D array consisting of total 5 items. Yes. So let's get into this. So here we have got this creation of an array, and the data type is NumPy's ND array. Okay, n-dimensional array, because it can be 2D, 3D, ND, etc. Now, after this creation of this, I want to show you how I can do indexing on this array, because I see the indexes over here. So indexing, well, it is exactly same as list. So I don't want to invest a lot of time. ARR of 0 will be 1. ARR of 4 will be 8. -1 would be 8. -3 would be 5, and so on. So ARR of 0 would be 1, ARR of 1 would be 3, ARR of -1 would be 8, and -2 would be 2. And when I run it, you can actually see it. In the same way, slicing is also same as list. So if I say 0 colon 2, then the starting index is equal to 0 and ending index is 3 minus 1, which is considered as 2. So whatever you studied in list, everything is applicable over here. Okay. Then after this, uh, I come to the creation part. Okay, so this is what we created. I also want to tell you that overall the D type is what I never gave, right? So this was the D type, but I didn't give it. That was the syntax. We'll take it over here so that the code becomes clean. So here I have 1, 3, 5, 2, 8, and I didn't supply the D type, but I can print the D type. So I can say print the name of the array is ARR. So I can say ARR dot D type. So what will it give? Int 64. If you are using a very old system, it might show int 32 as well. It shows 64 or 32. We are least bothered. It is integer. Rest all things we never require. It's just saying over here that whenever I say int 64, inside this 64 is nothing but the bit integer. If you understand this technical thing well and good, else it is just not important. If I supply over here one of the value as 2.5, then I said NumPy needs all the values of the same data type. However, here you can see it is a float. So it's a clear case of error. NumPy says what I'll do is convert everything to float because float is a higher data type. Float is a higher data. So it converts everything to float. Okay. Then I can actually create a NumPy array with the same thing and I can use the D type parameter. So D type, if I say float, then you can see it is of float type, right? And I can also say float 64 by the way, but not required, right? That's what I said, right? You write float or you don't mention it. It will automatically figure out. So you never mention it. That's always good. Better you don't mention it. Then if I say integer, obviously all the values are integer. So what is the point in mentioning? But imagine if there is a value like this. Now, if you say data is equal to integer, it will actually do typecasting on 5.22. So 5.22 became 5 because you forcefully asked it to get converted to this. Okay, that's one thing. Okay, so this was our 1D array. I want to say that was the 1D array. Now I am planning to create a 2D array, something like this, 2 rows, 4 columns, having the values. It can be anything. This is the row 0, row 1, column 0, column 1, column 2, column 3. Let's call it as ARR only. You know, how do you define it? Every row is a list. And this entire thing, you have to put it in a bigger list. Every row is a list. And this entire thing, you have to put it into a bigger list. So here, I say, let us create a 2D array. So I will see over here how I create. For 1D array, I use one square bracket. For 2D array, there will be two square brackets. If you recall, this is how the figure was. Now there are two square brackets. That's my row 0. That's my row 1. Each has to be given in the form of a list. So it's built on the top of list only. So I can say ARR is equal to np.array square bracket close it. So outer list created, this outer bring bracket. Inside this, another list 10, 20, 30, 40, 50, 60, 70, 80. That's what we said. Now see how conveniently I have created it out. Figure and same, everything same. See 1D array, single square bracket, sorry, single square bracket. 2D arrays, two square bracket. It is not mandatory that you write it like this, one below other. You can also write everything on a single line, but this adds readability. So what I mean to say is, it is completely okay if I write it like this. It's just that it is not that readable while creation. So I don't prefer it. I prefer this. You don't end up doing mistakes while the array is getting created. 10, 20, 30, 40, 50, 60, 70, 80. It's a NumPy array. How do I know there are 2 rows and 4 columns? There is a shape attribute. So if you remember that I can print arr.dtype, and that gives me it's in 64. And if I say arr.shape, that will tell me how many number of rows and columns are there. So I want to tell you that dtype and shape are attributes of the array, and they are not the methods. So the method that we have seen is the array, np.array. But dtype, do we have a round bracket after it? Like np.array has a round bracket, or here shape? No, these are attributes. There are hardly 5 to 7 attributes. So there is nothing challenge as such in remembering them. Very, very few attributes are there. So right now, don't ask me what all are the other attributes. Anyways, we'll be studying them in detail. So right now, you just need not worry about it. I was saying, it showed me that there are 2 rows and 4 columns. But, can I write the same code here in the 1D array? It's also called as ARR. So it will once again declare ARR as 1D array. And if I give shape, then what happens? See here, when they created the function, the return type is a tuple. The return type is a tuple. So here also it will return a tuple only. 5 comma, indicating that there are 5 items in the array. There are 5 items in the array, or 5 values in the array. This is how you create a 2D array. And here, if I want to access number 20, it is at row 0, column 1. So indexing, print ARR row 0, column 1, 20. I can also write the same thing as ARR of 0, comma 1. Both are same, huh? Both are same. You can see both of them are giving the same output. Whichever you find easy, you can write it down. Okay. Now, negative indexing is also there, but you need not do it, right? It's also there, but it's not required. How much ever is required, we can definitely look into it. So, in the same way, other things we'll do it later. Let's not get into the complicated part of slicing right now. I now want to do one thing, and that is I am planning to create one single array. Here. Let's assume this to be it can be any values. I'm just randomly assuming it. This was 1D array. This was 2D array. Now I aim to create a 3D array. Now the 3D array is not a true 3D array. So something like a three-dimensional object. No, nothing like that. It's called as a 3D array, but it's not three-dimensional. So you know how I say that this entire thing is one array where this is the 0th array and the lower is the first array. Inside the 0th array, this is row 0, row 1, column 0, column 1, column 2. Inside the first array, this is row 0, row 1, column 0, column 1, and column 2. And the way I define it is something like this. First of all, every array is a list. So this is an array. I'll just mark it like this. So that's one. That's one. And you cover it by an outer one separated by comma. Done. That's one. That's one. And you cover it by an outer one separated by a comma. Done. And that's separated by a comma. That is how it becomes a 3D array. See, 1D array, 1 square bracket, 2D array, 2 square brackets, 3D array, 3 square brackets. Let's check it out whether that's really the case. So I say ARR is equal to, okay, it actually heard me. You see over here. Now I can write everything on a single line as I told you, but I am not writing it. And let's check it out. First of all, the way I have declared it's exactly same like this string brackets. Print ARR has printed it exactly same like my figure. Inside this figure, when I say print array, entire thing came. Type of it, it is a NumPy ND array. Shape, you know, what is the shape trying to say? It says that we have two arrays, each of two rows and three columns. Perfect, that's perfect. It says I have two arrays, each of 2 cross 3. You can see that this is 2 cross 3, this is 2 cross 3. And when I want to access 60 is in the 0th array, row 1, column 2, 0, 1, 2. That gives me 60. Or I can write 0, 1, 2. 102 is it 90? 102. 1 is this, 0 is this, and 2 is this, 90. That's correct. So that is how you create a 3D array. Just pasting this as an image for your future reference. So that becomes little convenient for everyone to figure out. Okay. So that is how you create it. Now I want to say that I said when you look at 1D, now anything more about 3D, we'll check it out later, right? Right now it's not required. Right now this much is more than sufficient. This was the 1D array. I said that here by any chance, if I put a float value and I print it and I check the D type of it. I print the type and I also check the D type of it. Then it is everything converted to float. Because between integer and float, float seems to have been given a higher precedence. Therefore, everything became float. If I put a Boolean value like true and a false, they are not allowed because array has to be collection of the values of the same data type. But if I put it, then true gets converted to 1.0 and float to 0.0. No problem. You know what I am planning? I want to also show you some other functions, right? So I want to add over here some basic functions of NumPy, precisely the arithmetic operations, or not arithmetic operations, arithmetic functions. So I want to find the sum of these values. How do I find out? Well, print np dot sum of this. So sum of these values would be given over here. In fact, before I do this, let us do it on a basic array without a float. Without a float. Let's say, let's keep it simple as well. I think that would be 1, or let's say 10, 20, 30, 40, 50. Right? So let's see it. So 10, 20, 30, 40, 50 is the 1D array which is created. I just say I want to check the D type. Everything is int, so it is int, and the output is 150. That's good. Let us try other functions. So I have the minimum, I have the maximum, I have the average, which is mean, I have the median, I have the standard deviation, I have the variance. Many functions are there. So I can say np dot minimum of the array, which is 10, maximum, which is 150, 50, mean, which is the average, median, which is the center value after you take all of you are aware what is the median? After sorting the values, the one which comes at the center. Right? Yes, after sorting the values, whatever comes at the center is nothing but the median. So, and then you have the standard deviation and variance. Uh, so we'll be learning this standard deviation and variance when we get into the statistics part, but in very simple words, standard deviation is how much you are deviating from the mean. For example, if I say for me to go from my home to office, it takes 1 hour because the distance is 25 kilometers. However, if there is no traffic, I'm lucky, I end up reaching in 45 minutes, 15 minutes earlier. And if there is heavy traffic, I end up reaching in 1 hour, 15 minutes. So the average time taken is 1 hour, average, which is the mean. And the standard deviation is 15 minutes. So I take mean plus or minus one standard deviation to reach my office. So it can be 1 hour minus 15 minutes, which is 45 minutes, to 1 hour plus 15 minutes, which is this. So that is the range which I take to reach my office. So this can help me to take a decision. If I have to go to my office and if I have a meeting, let's say with the manager, then I will end up considering this time. So if I have a meeting, I'll prefer to leave 1 hour 15 minutes early because I cannot be late. And if it's a regular day and I can take that risk, I can assume 1 hour or 45 minutes to reach the office. So accordingly, I can take that decision as well. Okay. So that is nothing but the standard deviation. So what am I doing over here is just take out this as well. And yeah, you have it over here. So standard deviation and variance. So standard deviation is nothing but the square root of variance. So 200 and square root of this is 14.14. Okay. You also have the product. What will the product do? 10 into 20 into 30 into 40 into 50. You also have the cumulative sum. What is cumulative sum doing? Well, cumulative sum is saying what is 10 plus 20? Here, yeah. So first it takes 10. 10 plus 20 is 30. Then this 30 plus 30 is 60. 60 plus 40 is 100. 100 plus 50 is 150. So this is happening with respect to the plus. If I use comprod, then it will be like, let's take this 10 down. What is 10 into 20? 200. What is 200 into 30? 6,000. What is 600 into 40? 24,000. 24,000 into 50. Yes, and so on. Okay. Difference. Now, what is this difference doing? So, as you can see, difference. It is finding the difference between consecutive values. 20 minus 10, 10. 30 minus 20, 10, and so on. NP dot non-zero. Now, I don't know actually what is this function. It's suggested, but it's never required in my career ever. NP dot non-zero. And what is it saying? So I don't know. It suggested me. So what will I do? Let's say I don't know, but it is suggesting me something. So copy this. Go to Google. And first thing what I want to show you is the NumPy official documentation, which is available on numpy.org website. It says this version is released. I can click on that. Okay, this is what is the one. I can learn NumPy quick start tutorial and a lot of functions, lot of help available over here to learn. This is shape, size, all these things. I'm gonna first of all come and just put in that documentation link here. Second thing, np.non-zero, I don't understand it. So I'll just search np.non-zero. And I'll also open up this Geek for Geek link and this link because you never know. Sometimes you don't understand from the documentation. Nowadays, I prefer using ChatGPT for getting these answers, but I'm showing you approaches. So this will return me the indices of the elements that are non-zero. Okay. So there is a example as well. So indices of the elements which are non-zero. 0, comma 1. Where is this? See, easy. 0, 1. This is row 0, row 1, row 2, column 0, column 1, column 2. So 0 and 1 is 8. 0 and 1. 1 and 0. 1 and 0 is 7. 2 and 0, minus 5. And 2 and 2 should be the last one. That is what it's the return. Simple. So in this way, if you get stuck up somewhere, there are a lot of resources available as help, nothing to worry about. Anyways, so I can just execute that, and none of the values are 0, so obviously it will not give me a 0 anyway. Okay. After that, sort. It's already sorted, so can't do anything. Arg sort. Now, what is this arg sort? Well, that's little difficult to say at the moment, but I'll explain it. See, right now, the minimum value in this array if you see, I'm talking about this argument. What is the minimum value? 10. What is the argument of that? 0. Argmax. What is the maximum value? 50. What is the argument of that? 4. Then arg sort is sorting as per the argument. So I'll do one thing. For this arg sort, I will say okay, it's not sorted now. I say entry dot argmin would be 20. Sorry, minus 30, which is at index 2. Argmax and arg sort. I'll just tell this now. Here and here. This is the smallest value. It is at index 2. Argument. Highest value is 101, which is at index 1. Sorry, index 0. And if I have to sort it in the ascending order, the ascending order will be minus 30, 20, 40, 50, 101. Argument minus 30 is 2, 20 is 1, 40 is 3, then 4, and then 0. Same thing, no? That's arg sort. What will be the argument if the array is sorted? What will be the arguments which will be coming if the array is sorted? So I'll only take the common functions now. So we saw that these work. Okay, we saw that these work. Now here, when I am taking one item float, do this still work? They work. Okay, they work. The value which I changed is this became 2.2. That's fine. Well, I convert this, sorry, add a Boolean value. You see over here, Boolean values true and false become 1 and 0, and the D type is still float only. So float is having higher precedence as compared to integer. The Boolean, I'll do one thing. Now, let me add true and false. So we know that nothing happens. It will be float only. But what if I add a string like darshan? Do you see what happened? Why is, okay, I wrote it in the same thing or what? Oh. Right. So we have this and I added darshan. So see, everything becomes string. Oh, that means float value did not convert everything to float. That also became string, which indicates that the highest precedence is string. String has the highest precedence. Okay, fine. That's understood. And if I uncomment this from cell number 10 onwards, you get this. It says that here only, right? On line number 10, it says I cannot find the total. Obviously, how do you find out the total of these string values? They are not integer. Everything is converted to string, and NumPy calls it as Unicode 32. And that is important. If you recollect, what did I say? NumPy is mainly used for what is the full form of NumPy? What is the full form of num? So it is only used for numerical calculations. You cannot do string calculation. So it is very stupid if you try out any of the numerical computations, right? So over here, U stands for Unicode. Unicode is nothing but a string representation format. If you are not aware of that, Unicode number system, this is how it was U11. This is how it represents everything. So everything is represented by something, right? As per Unicode 11 format. So that's okay. That is done now. Then I say images. Abraham Lincoln. Whenever you represent images, images are represented something like this. Images are represented something like this. So as a human, this is how you see image, but a machine sees it like this. Combined, it looks like this. As per a machine, number 0 means black. Number 255 is white. So you see over here, these are pure black and they are 0, 0. Or if you see over here, third last row, 255. Then what happens? Because all these values are between, all the values are between 0 to 255. what will happen if I perform the operation of dividing by 255? So what will happen when 0 is divided by 255? 0. What will happen when 255 is divided by 255? 1. Now answer one question. Do you all agree that any number between 0 to 255 when divided by 255 will compulsorily be in the range 0 to 1? Do you all agree that any number between 0 to 255 when divided by 255 will compulsorily be in the range 0 to 1? Yes. This is what is called as normalization. That will be helpful in machine learning and deep learning, but this is called as normalization. And why did I all of a sudden go out of the topic and started explaining this weird thing is because it has some significance now. So, like, because it has some significance, I thought of explaining this to you. The next function which I want to talk about is np.zeros. np.zeros. It says that if you give me 5, print it. I am going to create an array of 5 values, all zeros. If you give me 12, a NumPy array of 12 values, all 0. You can also have the D-type facility to be chosen. So if you say D-type integer, instead of all the float values like here, it will choose as integer. Okay. Now, it says that, Darshan, if you give me 3, 5, then I'll be creating a matrix of 3 rows and 5 columns, all zeros. And this 3, 5 can even be supplied as a tuple. It's not common, but you can supply it. So both of these are ultimately going to create a NumPy array only. If you want, I'll just print the type of array. It's a NumPy ND array. And here as well, it's a NumPy ND array. It's not that because a list is given or a tuple is given, something else is getting created. It's absolutely the same. Okay. So here as well, I have the facility to give D type. It will create a NumPy array of 3 rows and 5 columns. As you see over here, it will create a NumPy array of 3 rows and 5 columns. Okay. That is what we see. Then, what I wanted to say, yes. Just like this 0, you also have ones function, which will create an array of ones. And just like this ones, you also have twos functions, threes, fours, fives, by the way, which is wrong. I'm kidding. You don't have twos, threes, fours, fives. You only have zeros and ones. All the functions of NumPy are added for some purpose. They are not added for time pass. These functions are not added for time pass. They are added for some reason. As I showed you, whenever images which are usually in this range are normalized, they become in this range. And that's why only zeros and ones exist. Twos, threes, fours doesn't exist because sometimes in image processing, what happens is, let's say you are working on some, let's say Instagram, right? You upload some image to Instagram. This is, let's say, the image that you upload to Instagram, and you are trying to apply some filter on it. So Instagram will be creating a copy of this image. How is a copy created? The pixel values cannot be copied directly. First, you create a dummy matrix of all zeros, and then one by one, as and when you are applying, let's say, blur filter. So what will happen with that pixel? That operation will be replaced over here. So that 0 will be changed. What happens with this pixel? That new pixel value is saved over here. So by creating a copy, it can be a matrix of all zeros of the same dimension that you create, or could be one. And that is why these functions exist. As I told you, all of them exist for some reason, right? So these functions are mainly useful while the deep learning stuff. That was the zeros and the ones function. Now, can someone explain me in simple words what is an identity matrix? What are the properties of identity matrix? Okay, identity matrix is here, and in identity matrix as well, of course, you have that D type. D type is almost there everywhere. So you see over here, you have the D type. And there is a I function as well, which also creates an identity matrix. I can show you. NP dot I of 3. Now you will be like, but how is this different? Because if I copy this and if I go over here, then it's absolutely same. Why? Then what is the difference between the identity and the I function? Well, here we have the K. Here we have the K. I'll do one thing. So I'll create a identity matrix of 5 cross 5. Okay. So this is how it looks like. So let us create it, and 5 cross 5. So oh, row 0, 1, 2, 3, 4. Column 0, 1, 2, 3, 4. By the way, that's K. K can take any of these values. How? Well, copying this, there is a parameter which is called as K. If I take K is equal to 0, if I take K is equal to 0, no change in the output because K is 0. Same like this figure. But when I say K as 1, now see what happens. The diagonal, the diagonal is here. Of course, it's not a perfect identity matrix, and I am not calling it as identity matrix either. Okay. When K is equal to 2, see it shifted here. So from here, 1, 1, 1, 1, 1 started. When K is equal to 3, it shifted here. And when K is equal to 4, it shifted here. And when K is equal to 5, all zeros. And when K is equal to 6, all zeros. But, we don't need it that often, but it just goes in complement with this. So see, all these functions exist for some reason, but this is very, very rarely required, the I function. It's not required only. I mean, it is applicable for positive values only. I don't know. I never tried it, to be very, very honest. And there is no need to try as well. But let's say if I say K is equal to -1, does it start from back or not? I don't know. But okay, it is -1 means it is taking the column wise, row wise. I never tried it. First time you asked me and I'm trying it out. Yes, I think. But not required, to be very honest. This is very, very rarely required, right? So don't worry about it. I just wanted to teach you identity function because I function goes complementary to that I showed you, but it's not required. Okay, so don't worry about it at all. But I'm sure Sanket and Sandeep, you got the answers to your question. Am I correct? Cool. Now, see, we have seen so many functions inside our NumPy. I don't even remember what all functions we studied. Let's say sum function, min function, sort function, argmin function. You studied the argmax, I, on and on, so many functions. And I say that we all studied this inside the module. In fact, there are some other functions as well, which I would like to talk about, like a rand function, rand int function, rand end function, all of these rand stands for random. And because these functions are more or less achieving generation of some random numbers, they are also dumped into a module which is called as random. And the best part is they are a sub-module inside NumPy. So if you have to call, let's say the rand function, then you say np dot random dot rand. That is how you call this function. I just wanted to show you that, okay, this is how it is done. So I will just get these things for you. Now, we don't have to look into all of these functions, but you saw in the deep learning notebook that random module is little used, not too much, but little used. One of the perfect application of random module is it can be used for generating OTPs, right? Every time you're doing some transaction, some OTP has to be generated, which has to be purely random, not following any pattern, and that should go on to the user and then it must tally. So how do I use it? Well, np dot random dot rand of 5. So it will generate random numbers between 0 to 1, 5 random numbers. Every time I'm running, it is generating 5 random numbers between 0 to 1. Then you have randn. It will generate the numbers between -1 to 1. See, every time I'm running, you have randint. You specify the values and it will generate the numbers in between them, low and high. So between 1 and 10, generate 5 numbers. It will always be between 1 and 10. Look into the last line output. Between 1 and 10, 5 numbers will be generated. And many are there. So random model is responsible for generating any value between 0 and 1. Yes, very similar to the above one. I do agree. And so on. We need not look into all, but yes. So in deep learning as well, when you have a set of misclassifications, and if you want to randomly plot one of the misclassified image, that random model turns to be of very heavy help. Okay. Another thing, something very common in the machine learning, like I showed you some time back, code is not important right now, right? In machine learning, let's say when you have a data set, you always have to separate what you have to predict from what are used to predict it. Like the pink values are used to predict the values in the yellow box. So you have to separate. So now what am I going to consider is an similar analogy where I have values 11, 22, 33, 44, 55, 66. So I want to tell you that usually, like here the tips column is the second column, but usually the column to be predicted is the last one, and the ones which are used for predicting it are here. So what I want to do is I want to separate it out, this blue part into X and this pink part into Y. And before that, I would like to write down some naming convention. This is row 0, 1, and 2. Column 0, column 1, column 2. I can also call it as -1th column, -2 column, and -3 column. Same row also can be called as -1, -2, -3. Let us create a data set. So I say np dot array. Perfect. This saves so much of my time. Now, how I do it is going to be very, very interesting. See, I say in my X array, which rows I want and which columns I want. So I say I want all the rows. That is from row 0 to row 2. So I want it from 0 to 2. So I will write 0 colon 3. And columns, I say I want all columns from C0 to C1, for which I will write 0 colon 2. Then only it will take column 0 and 1. Okay. I can also write this as just colon, because by default, if I don't give the starting and the ending index, then it takes everything. And I can also write this as I want it to start from 0 and go up to -1. So when I say colon -1, it's by default 0. And when you say -1, that means it will go from 0 to -1, -1, which is 0 to -2. Column 0 to column -2. That part. Hey. And as far as Y is concerned, I would say I want all the rows of column -1. So these are my rows. And this is my column, single column, which are single column. I didn't write colon -1. Colon means start from 0. I am directly saying -1. That means clearly I'm saying I want only -1th column. Let us check it out once. So X is equal to array. You can see over here. Right? That's X and that's Y. Have a close look at it. It's not difficult. It's just different. I will also, first of all, like to add this image so that this doesn't go, and then you just quickly keep on observing this. I repeat, my X is all the rows. That means row 0 till this. So I can say 0:3 because row 0 to row 3, which is going to take 0, 1, 2. And column is 0 to 1. So I cannot write 0 to 1. If I write 1, then it will go up to 0 only. So I will say 0 to 2. So it will go from 0 to column 1, column 0 to column 1. And this 0 to 3 can be conveniently just written as colon only because 0 can be skipped and I can only write 3. 0 is optional because by default it is 0. And here also 0 that can be written as just colon 2. I can write it as colon 2, right? And 2 is nothing but minus 1. Na? 2 is nothing but minus 1. So I can also write it as minus 1. And that's what I wrote. Colon minus 1. And here, when I say colon, I mean to say I want 0 to 3, which is as good as saying everything. And here specifically, I can write I want column 2. Or I can just write 0:3 and I want the minus 1 column. So ultimately it's one and the same. So now that we are done with this, the next function, which is again very popularly used in machine learning, deep learning, and almost everywhere, that's going to be your arrange function. So first of all, if you recall the range function, where I used to say for I in a range of 5, print I, that used to print 0, 1, 2, 3, 4. NumPy says I also have a same function called as arrange. Absolutely same function called as arrange. So arrange will work same like range function, but the difference is arrange would be storing these values into a NumPy array. So here I say np.arrange of 5. And if I let's say save it into a variable like arr, then you can see over here it has this. And I can also print the type. You can see the 0, 1, 2, 3, 4. It's a NumPy array. This 0, 1, 2, 3, 4, it's a NumPy array. In fact, even if I say np.arrange of 12, 0 to 11, np.arrange of 1 to 12, it goes from 1 to 11. If I say 1 to 12 at a step size of 2, it goes like this, exactly same like arrange. The difference is it will create a NumPy array. That is how this is going to be different. The most important thing over here is the output will always be a NumPy array. The next thing which I want to talk about is if I say np.arrange of 12, there is one more function called as reshape. This reshape says I will reshape this array reshape says you have the values 0 to 11, right? Using np.arrange. Further using reshape, I will reshape this into 3 rows, 4 columns. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. Also, for this thing to work, 3 into 4 must be equal to 12. If and only if the multiplication of this turns out to be 12, this is possible, else it's an error. Let's try out the various scenarios. I can say 4, 3, and it works 4 or 3 columns. I can say 6, 2, 6 rows, 2 columns. I can say 2, 6 works I can say 1 into 12 is also 12, right? So obviously now the thing is, what is the difference? Because np.arange and np.arange, and both of these are giving an output. That's the first output. That's the second output. Can you tell me what is the difference in the two? Or they are the same? What do you think? Of course, they look the same. What do you say? Very nice. Very nice. Correct. This is one-dimensional array, single square bracket, and this is two-dimensional array. Super. Very good. Very good. 1D array and the 2D array. That is absolutely fine. Okay. Now this reshape. I said whatever you put over here must, the multiplication must be equal to 12. So 3 into 2 is 6, into 2 is 12. 3 into 2 into 2 is also 12. It does create a three-dimensional array. You can see it has created three arrays, each of size 2 cross 2. So if the multiplication is equal to this, it works. In the same way, if you want, you can create here 2 comma 2 comma 3, 3 to the 6, 6 to the 12. See over here, two arrays of two rows, three columns. And now you see over here, this is four-dimensional array, four brackets. You never require it. At least I never required it ever, ever, ever. But this is just for your conceptual understanding that, okay, a 4D array is also possible. Okay. So next thing after this is if you have a NumPy, this is I can call it as advanced slicing. Assume that I have a NumPy array and the values are 0, 1, 2, 3, 4, 5, 6, 7, 8. Now in this NumPy array, if I say print ARR of control X, let's put it here only. Print ARR of this is giving the output as this. Okay. See, these are the rows and the column indexes which are selected. Row 0, column 1, 1. Row 1, column 0, 6, 3. Row 2, column 0, 6. Done. Now this is done. Now we will never use such kind of advanced indexing, but this is one way of doing the indexing. It is not mandatory that you have to use it. I never use it in real life, but if required, it can be used. As simple as that. Okay. The next is I want to talk about the concept of broadcasting. This is again a very important concept, broadcasting. And broadcasting is a powerful mechanism that allows the NumPy to work with arrays of different shapes when performing the arithmetic operation. What I mean by that, we will understand it in the code, but this is required in machine learning and deep learning for handling matrix operations when the arrays are of different dimensions. You have a smaller array and you want to multiply it with a bigger array, or the vice versa. These operations can be done over here. So let's understand it with the help of a very basic example. If I say np dot a range of 15 and reshape it to 3 rows and 5 columns. If I say ARR plus 5, maths teacher is gonna give a tight slap on my face, saying that Darshan, you don't know a single value cannot be added to an array. Two arrays can be added, but a single number cannot be added to an array. But NumPy says, don't worry, I can do that. It says, what do you want to add? I say, I want to add the number 5. The dimension of this is 3 cross 5. No worries, I will broadcast this 5. So this has become 3. Now it is 3 cross 2, 3 cross 3, 3 cross 4, 3 cross 5 done. Now I'll perform the addition. And there you see the result. So what has happened over here is exactly what we call as broadcasting. Just give me a moment. Now we say that's broadcasting. And in the same way, ARR minus 2 also works. ARR multiplied by 2 also works. So every value will be multiplied. You can just check out ARR and you can see every number is multiplied by 2. Now, if I have an array np dot a range of 15 and reshaping it to 5 comma 3, and I have another array np dot a range of 5 and reshaping it to 5 comma 1, and I say, now let's understand this. That's an important thing. So you are saying that array 1 and array 2 is to be added. This is array 1, this is of 5 cross 3. You want this to be added with this array 2, which is 5 cross 1, which is 0, 1, 2, 3, 4. Is that possible? No, because it needs 5 cross 3. It will broadcast this. Broadcasted one time, broadcasted one more time. This also become 5 cross 3. Corresponding values will be added, like you can see. This 0 and this 0 are added. Answer is 0. Or let's say, for example, this 13 and this 4 are added. This 14 and this 4 are added. And you can verify few of the answers, and that's how you got it. So reshaping, that doesn't mean any reshape will happen. First you understand this, then I'll tell you the other part. See, anything cannot be reshaped. For example, this works, but if I have instead of 5 comma 1, 1 comma 5, then see it doesn't work. Because 1 comma 5 means you are saying that to this you want to add this. Even if you broadcast it, so this is 1 comma 5. Even if you broadcast it, let's say 1, 2, 3, 4, 5 times, it becomes 5 comma 5, right? So this is 5 comma 3. After broadcasting this 1 comma 5, it becomes 5 comma 5. Still the dimensions are not same. So will you extend the dimensions of this? No, it's not possible. So everything will not work. Only feasible operations will work, and they are useful in tensor multiplications in deep learning. So anything cannot be multiplied with anything. That's an important thing which I wanted you all to know. Okay. The next is I want to go ahead with linear algebra. So linear algebra is the integral part of machine learning. And let me tell you that your NumPy was initially developed for linear algebra and matrix operations only. However, slowly and steadily it translated to the machine learning part. So how do I get started with this? Well, let's do something which is called as matrix multiplication. So how do you consider multiplication of the two matrices? Let's say you have np dot array 1, 2, 3, 4, 5, 6. You have another array. This. First of all, what is the order for matrix multiplication? Well, a matrix A of order m cross p can get multiplied with p cross n to give the order m cross n, right? So the columns of first matrix and the rows of second matrix must match. And the way I can perform matrix multiplication is dot product printing C, or there is another way to perform matrix multiplication, and both of these are valid. And the third one also, you can see all of them are giving the same result. Either you use the dot function and supply the arrays, or you use at the rate in between the two, or you use the matmul. All of them are giving absolutely same output. You can check it out. Okay. Then, oh, remind me one thing. I have to show you the speed of the NumPy array that I forgot. Then after that, I say transpose. If you want to find the transpose of the array, let's say I have a NumPy array and I'm printing this. That's the quick way I can find out the transpose of the array, right? You can see what is transpose basically. 1, 2, 3, 1, 2, 3. Rows become columns, another row become another column. Same happens over here. So a dot t, that's a quick way. That's not a NumPy function. NumPy function is np dot. There is one more function which is a dot transpose. Again, this is not a NumPy function. Wherever you see np dot, only that is a NumPy function. So though many, these many are there, you can see the output of this, and this are the same. But of course, you need to understand this is the only NumPy function. NumPy offers function to do this. Then the next thing which I want to do is solve linear equation. So if I say, consider the following system of equations. I say 7x plus 5y minus 3z is equal to 16. Then I say 3x minus 5y plus 2z is equal to minus 8. And then I say 5x plus 3y minus 7z is equal to 0. Find the values of x, y, and z. We have done this thing in school days multiple times. So we have done this thing in school multiple times. So Control A, Control C, Chat GPT, and I go over here and I ask it to solve it. So 1, 3, 2. These are the outputs. Okay. How will NumPy solve it? NumPy says that what you can do is these all values. You save it into an array. Let's say A. And you know how will I save it? As a two-dimensional array. These all values, you save it into another array called as B. And then you just say not np.solve. And NumPy has a submodule, linear algebra, where you solve A and B, and it will give you the answer. So I say A is equal to this, B is equal to this, and I say np.solve. And you can see I'm getting the output over here as expected. So how are these values set up? Well, if you observe, 7, 5 minus 3, first list. 3 minus 5, 2, second list. 5, 3 minus 7, third list. They are stored as a 2D array. 16 minus 8, 0, 1D array. And then NumPy linear algebra solve and you get it. End of the story. Let's go ahead. Let us get into, do you remember something which is called as a determinant of a matrix you might have studied during the school days? Yes. If someone has forgotten the mathematics of how the determinant of a matrix is calculated, then I cannot teach you that right now, but I can give you the link to study it. So if I have to calculate the determinant of this matrix, it is always the 3 into 6 minus 8 into 4 minus 14. Talking about determinant of a matrix, and I say A is equal to np.array. And the way I find the determinant is simply NumPy's linear algebra modules det function. Another way is determinant of A dot transpose, but I won't recommend that. I'm not even sharing that. That's the determinant. And then the next is inverse of a matrix. In the same way, you might have studied inverse of a matrix. If you do not recollect it, this is where you can study. It's very nicely explained. Just as an example, I can show you. So if you have this matrix, ABCD, and you want to find the inverse of it, then it is 1 upon AD minus BC, that is 1 upon the determinant of this matrix. And then this diagonal elements A and D are swapped, and the off diagonal elements are multiplied by -1. And that is the determinant. That's the inverse. So I say, so let's say you are having a NumPy array and you directly use the linear algebra's inverse function to do it straightforward. Do you know what is the trace of a matrix? Do you know what is the trace of the matrix? You're expecting, what is the trace of a matrix? Yes, very good. It's the sum of the diagonal elements. That's perfect. Trace of the matrix is nothing but sum of the diagonal elements. So I create an array and I say np.trace. So 1 plus 4 is 5. I have the trace ready. I have the trace ready. So that is nothing but the trace of a matrix. Then now the next one are the few important functions which I would like to say. So I say the next functions which are left out as per me. We're almost done. Just few functions which are left out. The first one is the line space function. Now, what is this line space function? So line space function will be generating all the values in uniformly. For example, if I say np.linespace, you know what will it do? Between 0 to 1, it will be generating 5 numbers, all equally spaced. See, 2.5 minus 0, 0.25 minus 0, 0.25. 0.5 minus 0.25, 0.25. This minus this, 0.25. This minus this, 0.25. If I say that generates 7 numbers, 0.16 minus 0, 0.16. 0.33 minus 0.16, 0.16. 1 minus 0.83, again 0.16 only. Okay, so that is what is the linspace function. The next function which is used is the empty function. So here, so what does the empty function do? Very, very simple. If I am saying empty 2, 3, what is it doing? Well, it will be creating a NumPy array without initializing the entry. So array will be containing any arbitrary uninitialized values. Right? So that is the main idea behind it. Now you will be thinking, where is this even required? Well, see, empty function is required in high performance computing and the large scale machine learning pipeline. Because when empty will be useful when you will need to fill the array afterwards, avoiding redundant zeroing. So those all are the places where empty function is useful. In deep learning also, this is useful when you Uh, Quickly, you want to allocate the memory during the mini batch gradient descent technique. Difficult to say right now, but yeah, I mean, that's what I can say. The next thing is the flatten function. So what does the flatten function do? It will flatten the array. It is very popularly used in image processing. If you look, I say array is 1, 2, 3. For it's a 2D array, you know how it is visualized. You visualize it usually like this. But when I flatten it, see this is 2D, and after flattening, it looks 1D. That is the difference. Then hmm, then you have np dot ravel. So ravel is also going to be flattening the 1D array whenever possible. That means it will always avoid copying the data unless necessary. So here, with respect to the Python example, you will see that this also does the same thing. You have the array and it is flattening it only. But the difference is, unlike flatten, it will always return a copy. So Ravel will return a view if possible, making it more memory efficient. Then very simple functions, but they are used in machine learning. The next is swap access. So what does swap access do? Let me show you. Have a look at this first. I have this array, one array of 2 rows and 2 columns. Original shape, one array of 2 rows and 2 columns. I am saying I want to swap the access of this arrays and 0, comma 2. You can see I got two arrays, each of this comma this will do one thing. Let us print the swapped array as well. So you see it just changed the dimension, and I'll also print the original array. 1, 2, 3, 4 was printed as 1, 3, 2, 4. Now, is that really very helpful? Well, no, very, very rarely used. In fact, I don't remember me using it anytime in my work in last 6 years at least. So you can just consider it as an additional one. That's not really very, very important. The next one, which is important, is the horizontal stack and vertical stack. These are required. So let us start with the edge stack function. So what does this edge stack function do? I'll give you a very, very simple example. Let's say I have this array or let me say see, I have these two arrays, as you can see, and horizontal stack has taken 1, 2, and 3 for horizontally. And similarly, if I go ahead with V stack, It has taken 1, 2, 3, 4 vertically. See, it converted these two arrays into two-dimensional arrays. Each of this. No, there is a difference. No? Flatten and this. Although working wise they are same, but horizontal stack can take up any number of values and stack it. Flatten takes a 2D and converts to 1D. But it can take this H stack can take any number of arrays and convert it into one flattened list. Flatten will only take one array and convert it into this. Right? Yes. So horizontal stack and vertical stack. These are the ones. After that, I guess I think we are done. One thing which I showed you in the deep learning that I didn't cover, rest all things are good. And the last function to be discussed is the where function. So what is this where function? It will be used in deep learning, as I told you. So what does it do? Well, look into this code. 10, 20, 30, 40, 50 is the array. I say np dot where the value is greater than 25. It tells the indexes. These are the indexes 2 and 3 where the number is greater than 25. Or if I create two arrays and I say condition x greater than 2. So here in this case, over here, in this case, condition x comma y. So you can see all the values in x greater. I'll show you what is condition, right? Let's print condition, then you will understand it. X greater than 2. So these are the values which are greater than 2, 3 and 4. It gave true and true. So 3 and 4, right? So index this. So now false, false, true, true. So in this, it will be mapping. 10 is false, 20 is false, 30 and 40 are true. Therefore, when I say np dot where condition x, right, which is this, and y, and I am looking for the result. So I'm looking for the condition x is greater than this. So x greater than this has given me what? X greater than this has given me the 3 and 4. And that is what is here. And y has come as it is. But again, more than this, the first application is more helpful. This can actually little confuse you. This is more easy and more helpful. This completes the NumPy module. Now, out of these functions, which are the most common ones that we'll be using in, day out, there are too many for this. You are finding these functions too many. But according to me, these are the only functions that you'll be requiring it in a long run. And if you internally look into NumPy is a module which you can spend an entire month to read. Over here, you see over here, NumPy can be used for quantum computing. We did not cover this part, statistical computing. Neither we did cover this part. It is used for signal processing, image processing, and so many domains. Surprisingly, geoscience, geographic processing, and so on. So we don't need all of this. Bioinformatics, Bayesian theorem, etc., etc., etc. Right? So you don't need so much of these things is what you need to understand. pandas. Right. So that is the agenda for our today's session. Let's get started. And we are getting started with the topic of pandas. So pandas is an important library for data manipulation. That means you can change the data, manipulate the data. We say data wrangling, which means cleaning the data, and analysis. It provides, or I can say, the functions of pandas are as intuitive and easy to use as the data structure it provides. Pandas is built on the top of NumPy, right? So it will work seamlessly. And one of the most widely used library anywhere in the data science field. Okay. Now it is used in each of these fields. That's okay. More importantly, it is helpful in machine learning and deep learning. Now I come on to the data structures of pandas. So pandas provides two main data structures. The first one is going to be a series. And what is series? Series is one-dimensional array. Yeah, we can say array. Very similar to an array only. Series is one-dimensional and there is also an access label. As you can see, it is very similar to a list or a dictionary. Okay, and how to do that, we will see it later. And data frame is a tabular one. So this is how it is. You can read about it later. But the most important thing is the data frame only. The most important thing is the data frame. Okay. Now, so many things, all of these operations can be done on data frame. Now, as and when we go ahead, we will be anyways implementing this operation. So let's not unnecessary invest a lot of time on it. Okay, but all of these operations which are suggested are perfect. Now, if I explain it to you right now, there will be a lot of questions because it recommended. I just took it. All the information was good, but let's do it in action only. So now series. And I like to look into the syntax for creating a series. pd.series index is equal to index. So data is the data that I want to save and index is the index. Now, if you not provide, it is integer by default and it returns a series. Now, obviously, it's better I explain. But before that, we have to import pandas. Do not focus a lot on the content which is generated and you try to read it. Whatever I explain, focus on that. So this will be printing the version of pandas after importing pandas. If you are having a different version, then also it's okay. Okay, so this is one. So this kind of recommendations that I'm getting over here, which can be helpful for you when you study. Let's get into the process of creating a series. So first and foremost, I'll keep it very simple. Let us say I am having a dictionary. So I have a population dictionary where I have California's population, population of Texas, randomly taking the values, Florida's population, New York's population, Pennsylvania population, Illinois population and finish. I am printing it and I am also printing the type. So it has to be a dictionary, right? In fact, I need not even write this. I will just keep it simple. I printed the dictionary and I printed the type of it. Simple, a very, very simple dictionary and the type of it. Now, if I say, over here that population is equal to PD dot series, and here I am giving the population dictionary. So what am I doing? I am passing the dictionary to the series. We know dictionary is a key value pair, California population, Texas population. If I do this, let's see how it looks like. So this is how a series looks like. Later on, it will be required. So better make a note of it. So the keys of the dictionary are the keys in the series, and the values are the values in the series. At the bottom, you see it also prints the T type. Okay. Then, so always a series will look like this, huh? Always a series will be looking like this. And the data type is pandas.core.series.series. As simple as that. Okay. Now let us get into the process of creating a very basic series. So I was talking about this as the syntax. Okay, I'll only take up this. Now, what I say over here is S is equal to PD dot series, and let's say I give the numbers as 2, 6, 4, 8, 10. I did not give any index, and I say print the series and print the type of it. So you can see the default indexes are being given. You can see the default indexes are being given. Here, what to be understand is if you just provide a list, it creates a series. In the same way, you even provide a tuple, it will end up creating a series. But don't provide tuple, please. Don't provide it. You can even provide a set, but you will not provide it. That's number one. Okay, so here what do we see? Because index is not provided, default indexes are 0, 1, 2. In dictionary, when I supply dictionary, the keys became over here. Okay, that's the very first thing. Now here, you know how is this series saved? Exactly like list. Your indexing is also exactly like list, but I am not talking about indexing at all. So if I say S of 0, because it's a series, S of 0 should be 2. It is. So now we saw that how I can conveniently create a series. But in the series, I can even pass in the index. So if you see carefully in the series, I have passed in the index. And now comes a little bit confusion. That's why I didn't discuss. Now I should write S of A or S of 0. To solve that thing, I said we will be discussing this topic in detail, right? Maybe S of A works, but there are some other caveats to it. We will discuss it later. Okay. You saw over here that I can do it. if I say S is equal to 2, just a single value, and printing S and printing the type of S. You can see over here, a single item is also assigned S. If I say S is equal to just a single number, I did not pass a list, just a single number, then also it converts it. If I say S is equal to single number, and then I pass an index, it works. That is also obvious. If I say S is equal to single number, but I am supplying A, B, C, D, E, that's a clear case of error. Am I correct or not? This is absolutely a clear case of error. Yes or no? What do you think? Quite obvious, right? Because one value and you are giving multiple things. But that does not happen. Let me just make you recollect. Do you remember yesterday in NumPy, we looked at the concept of broadcasting, with the help of which there was some NumPy array which was two-dimensional, and I added number 5 to it, and the number 5 was added to each and every value of the matrix. Do you recollect? Yes. Because Pandas is built on the top of NumPy, here also, it doesn't let us down. It doesn't let us down. It broadcasts the value as many times as the number of indexes. Okay. So that's just, I wanted you all to know that 95% of the times you will use data frame only. Series will be only required this much, this much. But whatever is required, at least we should know. So I'm covering all those things for you. Else series are very, 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 very less required. Okay. If I say I am creating a series by passing in a dictionary, maybe something like this. Two colon A, then 1 colon B, and 3 colon C. Let's say that's it. So we know that, keys and values, whatever are being there, they will be coming down. Oh, what happened? Yeah, round brackets close. This is something which I'm not finding any interesting. But, in the same here, after this, if I'm giving the index, and if I specify the index as 1, 2, 3, because here while defining, I gave 2, 1, 3, but if I specify the index as 1, 2, 3, does it work? Does it give an error? Well, it will work, and it will give more priority to the index order given, and therefore it becomes as 1, 2, 3. Important point to be highlighted. You can understand the difference between this and this. Okay. Does indexes needs to be specifically written? It depends on your application, Sandeep. You may need to write it, you may not need to write it. But ideally, in a real-time project, you will never create a series by yourself. Neither will you create a data frame by yourself. So practically, the answer to your question is no. We never create a series only. Forget about indexes. We never create series. Also arranging the values along with the indexes. That's correct, Anivesh. Showing in the ascending order. No, not ascending order. Showing it in the order which I specify in the index. So what I mean over here, if instead of this, if I just say 2 comma 3, so it will only select 2 and 3. So it will select 2A and 3C. So it is selecting whatever I'm asking it, right? Yes. Whatever I ask, it will select in that order. There's no ascending or descending order to it. That's it. Now, let us take a step ahead. Now I go on to data frames. Series are all one-dimensional, data frames are two-dimensional. So, syntax is this. It's coming suggesting good. Okay. Now, I remember before that I having a population series created. Yeah, you remember this, right? So this was the series that we created. Now I want to tell you that a list is used for building a series. A series is used for building a data frame. List, series, data frame. So I am planning to take up this series of population and directly pass it over here. So I say Z is equal to PD dot data frame and I only pass the data. Only pass the data. And then I'll show you how the Z looks like. Yes. So it is converted to the data frame. In fact, just like yesterday, I can actually print the shape of the data frame by saying print Z dot shape. You see over here, it says that there are 6 rows and 1 column, which means it is two-dimensional in nature. Here, let's say here we had the series and I want to print the shape of the series. And if I say population dot shape, this is 6 comma 1, one dimensional. One dimensional. Observe over here, this is one dimensional and this is two dimensional. Now we will be creating a data frame. Now again, as I told sometime earlier, you will never be creating a data frame from the scratch. In real life, you will be reading the data given by the client. You will not be creating it, but in our session, we learn how to create it as well. Maybe for working with some toy data sets, you need it. So I say, let us create a student data frame and I'll copy the syntax. So I am in the process of creating a student data frame. So here we say now, first of all, you just have a look at the output, what we created. That will give you a perfect clarity on what we are trying to build. Okay. And how is it created? Let's focus on that. So you see, I have a simple dictionary. It's a simple dictionary, key value pair, key value pair. Keys are the names of the columns and the values are list. So whatever are the values, that are the contents of the columns. Now I want you to follow this. This dictionary when passed into the data frame, it creates a data frame. I always advise people to print the data frame directly as I showed in line number 11 as compared to what I showed over here in the print statement. See, the formatting is way more different and this looks much better. Now have a look at the code. It's really very simple. Perfect. It's better that you don't write print. It's always better. I mean, I always advise. Obviously, this looks good, right? It's better not to write it. And when it is, I'll show you. Now, that should not come up with any demands, but see here, it looks more better in the white mode, but it hurts the eyes. Right? So, yes, this is what we have. Right? So, without print only is always good. So that is how you can quickly create in a data frame. Okay, now that you understand how one can create in a data frame, I can also create it the raw way. So what will I do is, I'm going to import NumPy and I am creating a data frame, pd.dataframe. I need to give the following things: data, numpy.random.random. So it will be responsible for creating what? A 5-row, 3-column matrix. If you don't recollect it, let me show you separately. It will create a NumPy array of 5 rows, 3 columns, right? I'm running it again and again. You can see it's creating a NumPy array of 5 rows, 3 columns with the random values. Okay. Ran it so many times. From 25, I went till 69. So I ran it more than uh, almost 35 times. So then the second parameter, if you recall the syntax, right? That was the syntax. So the next parameter is index. I can say index is equal to how many are there? Index. 1, 2, 3, 5 rows are there. So I can assign 5 numbers over here. And how many columns are there? 3 columns are there. So let me assign this. And I'll print the data frame. You can see over here. Every time you run it, it will be different values. Now, in this data frame, if I want to print the shape of the data frame, I will say print the shape of the data frame. And that says 5 rows and 3 columns. If I want to print all the column names, because here in this case, there are only 3 columns. In real life, you may have 1,000 columns, 20 columns, 100 columns, 200 columns. So when I want to print the columns of the data frame, just like dot shape, I use dot columns and that will print all the column names. Now, some of you may be like, Darshan, what is this index of this? Why is it printing like this? Don't worry at all. It is Pandas style of printing. And for some reason, if you are not happy, though it's not recommended, better be happy. But if you are not happy for some reason, then what you can do is you can definitely typecast it to a list. But not required. This output is only what I strongly recommend. No one changes it. No one. If you want, you can change it, but no one changes it. So you are unnecessarily investing energy in the unnecessary steps. So you need not, as simple as that. But if required, it can be typecasted. Next. So this is for listing all the column names. If I want to print all the indexes, now in real life, you will never print the indexes because here there are only 5 indexes. In real life, there will be minimum 1000 rows, minimum 1000 rows. So what is the use of printing it? But if you want to do that, you have the index, which you see over here, how it comes. Right? You can see how it comes. Then, if you want to print all the values, see, these are the values, right? These all. If you want to print all the values, then you use the values. Now, let me tell you, this output that you get will be a NumPy array. When the contents of the data frame are printed, what you see is a NumPy array. I'll print that also for you. Print the type of df.values. So you can see it's a NumPy array, and this is how it gets printed. And there is no need to typecast it to a list, but I just typecasted it. It looks like this, but not required. I'll better remove this code. Right? Now, I want to talk over here that this shape or columns, index, and values, all of these are attributes of the data frame. They are not methods. See, what is a method? Did I write over here index open bracket, close bracket? No, that will not work. They are attributes. Did I write over here shape open bracket, close bracket? No. So these all are attributes of the data frame. These are all attributes of the data frame. And you might be curious on knowing how many attributes are there. I told you yesterday as well. Very less. 7 to 8 attributes are there. Now it's like almost you studied most of them. Most of them are done. I think one more is required, which is D types that we'll study in some time, and that should be end of the story. Okay. Now, in real life, we will never be creating the data frames from the scratch. I was very, very clear on that. So how do we actually end up working on this? That is where we need to understand the things. So I want to show you the data set which I am downloading is available on my GitHub repository at this address. I am saving it first of all. So if you see, I saved this data set, I downloaded it, and this is the data set. Okay, I downloaded it. How did I download? When you click on that link, it will open this thing in the browser. Something like that will be open in the browser. You can check it out. Exactly like this, it will show in the browser. Right click on this and you have the option save as, and you save it as simple as that. Save as a CSV file, you are done. Okay. This is just to tell you that, hey, this is what I am doing now. I want to read this. This is a CSV file. Now, there are many types of files that which can be read. Right now, I'm focusing on CSV file. That's going to be the most common. So the link to download the data is this, right? This is the link to download the data. Now, how do I read the CSV file? Same, I say df is equal to Pandas has a function read. Now, if you see when I type REA, even in Google Colab, it will show you suggestions. So what all files can you read? You can read a CSV file, Excel file, feather file. Now, I have never used a feather file, FWF file, but if required, it's not a great thing to read it. You directly have the functions. You can read a JSON file, HTML file, Parquet file, pickle file, etc., 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 etc. So I say I'm gonna read a CSV file. If you write Excel over here and if you're reading a CSV file, obviously expect an error. So read the CSV file. And then what is the name? It is always advisable that this file, you save it in the same folder where your notebook is there. Else, you will have to write the complete path. Complete path in the sense, you will have to write C colon slash slash colon users colon slash 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 till student records dot csv, right? So you'll have to copy that path here because you're putting it in the same folder. That's not a problem. And I'm done. Now I say, is the data frame red? It is red. It is red. Okay. So that's one thing. Have a close look at the code. Okay. Now, after this, I'll just delete this. Then, if I copy this code and come down, right? If you are having an access to the internet, then you can directly give in the GitHub URL as well to read it, and it will read it seamlessly. You should have access to the internet. See, both of this code, here it's there, reading from the local system, and here it is reading over here, right? So it can read it from the internet, as simple as that. But if you are reading it maybe on from some Google Drive or so, then the processes may be different. So ideally 99% of the time you will end up reading from the very popular sources and understand. Our session Pandas. What is Pandas for? Am I here to teach you how Pandas is used for reading each and every type of file? The answer is no. Our session is about understanding how to use Pandas. Reading is one-time affair. Reading is one-time affair. The code for reading a data can be found anywhere on the internet. If I say, let me go on to ChatGPT, and if I say that you are a Pandas expert, get me the syntax and the code to read the file from the most popular sources like, and more, whatever you think is relevant, right? So maybe I'll take one more SQL, I'll take, and there you go. Reading is just one-time affair. Reading is not going to make you an expert in Pandas. What is going to make you an expert is the later part of this. How do you do analysis, cleaning, etc., etc. We have a separate session on data cleaning. So today we are not getting into too much of that, but just remember. So df.read CSV, and you have that basic. CSV sometimes have delimiter other than comma. There are also files called as tab separated value, TSV. So over there, the delimiter is not comma, the delimiter is \t. So you can use this. Sometimes encoding issues come. So encoding is one of the common thing. Usually it's not required right now when you start with the EDA machine learning. At that time, sometimes this is required. Read Excel. Excel in CSV, there are no sheets, one single file, but in Excel, there can be multiple sheets. So you have to supply the sheet name. Then JSON, read JSON. So wherever is your JSON, you can just use this function and give that name of the file over here, right? So orient function is also there in JSON for the JSON in string format. Parquet file is mainly used in the data, what do you call it, in the distributed computing because it is very fast and saved in purely columnar fashion. But anyways, it cannot be directly open to see the content, but it is saved in a compressed form. When you have used data, CSVs are not preferred, Parquets are preferred. So that's how you read it, straightforward. For connecting to the SQL, you need to use extra module, import SQLite. And you have to connect to your database whenever you study that at that time. And then you use the standard command of SQL to get it connected. For connecting or reading a HTML page, you have the read HTML, right? I hope that gives you more clarity on that, right? So here, you can also read the clipboard data, whatever you have it on your clipboard. ORC file is again used in something like Parquet only. Feather file, I never used it. It's a fast binary format, but at least I never used it. Pickle file is the format in which machine learning models are saved. So that can be read like this. XML file. And reading from the zip file. This is usually required when you start with the, what do you call, deep learning, when the data sets are very big and you have lot of images to be read. So we usually compress it in the form of a zip file, right? And then after that, reading from S3, Azure or Blob, right? So this is all reading from the buckets. Just like supplying your GitHub URL, you are doing the same thing over here. Now, never ever in my life so far, I have ever read any data from the Google Drive. So in Google Drive, you have some data set. It's not that you click on share this data set and you get the public URL. It will not read it from there. So I have never tried it. And see, as I told you, right, if I have to ever read, no, in none of our consultancy use cases, you will ever read it from the Google Drive. No one puts it publicly on the drive. But if you want to read it, Google Colab is very nice for reading the data from Google Drive. I'll show you that also. But mainly, uh, we never have it, right? In practical life, you will never have it. So, but let's say, how can I read from my Google Drive to my local PS Code Jupyter notebook? Though it's not relevant, it's like not required, but since you are learning it for the first time, you may have all these type of concerns. What will happen here? What will happen there? Manually download. That's the easiest way. Second is there are some external packages like GDown or PyDrive, which can be done. So it's a third party package. So if I am not there to help you, I think it's not a big thing, right? It says install this package, you install it, and then your link is there. Let's say this is the link. So you'll be giving the file ID which comes in the URL, the link over here, and it will download. And after downloading, it is again reading using the CSV file. So that is how it is. If it's one time or occasional, prefer the manual download option. As simple as that. Now, if you are having a GitHub URL, right, then there is absolutely no need to worry. If you are having a file on the GitHub, then you can directly read it on Google Colab. It's all set. Right? It's all set. Absolutely nothing to worry because it is reading from the internet, and anyways, Colab requires internet. So that is just out of question. This is sorted. Second, the second thing over here is if I have to read it from the file, not from GitHub, then you have the option over here. Here, file section. I click on this. and you have the option over here to upload. You may end up asking this to me once again. So I'm telling it right now only so that I need not repeat it. You click on this. Then you click on this to upload. And now I am actually uploading the file. How? By getting into our regular folder. The student records.csv file is getting uploaded and it is temporary upload. You can see the message, warning message, read it. What am I trying to say from this is, if I go to the runtime, because if I close it, see, if I close this file directly, if I close this file, then this runtime which is there, it will be automatically disconnected after some time. And if I disconnect it right now, you see, it says all the local variables and files will be lost. So if I disconnect it, it's all gone. So it's temporarily uploaded. Let me reconnect. Now, after reconnecting, it doesn't come again. You have to upload it. Click on this and then you upload it. You should always wait for the upload to complete. Don't try to read before the uploading is done, specifically in case of bigger files. So that's one thing. Then how do you read it? Well, let me first copy this code. I come down. Entire code is same if you observe carefully. Entire code is same. I'll just click on this three dots and copy the path. I repeat, I click on this three dots and copy the path. Control V. And PD is not defined. Oh, I restarted the kernel, right? See, now it came. Right? It came. Achha, I want to tell you that even if you don't click on this three dots and copy the path, even if you don't do that. So let's say if I am taking the same code as I took, absolutely same code, you can see that absolutely same code. If I directly give the name of the file without giving that slash content, earlier I gave this complete path, but the default path is slash content only. So even if I do it like that, it works. That is the third thing. The default path is always slash content, so it need not be compulsorily given. Easy. And the last thing, let's say I go to see, there is one more. Let's say there is an superstore.csv file. I'm reading. You can directly read it the same way. But what will I do is I'll first download it. While you're downloading, please do not click on any text. It will select that text and ask you to copy. You don't want to do that, right? So click on this empty portion and you have the option save as. And I'm saving it. Okay. Now, what we do is I'm going to my folder. And then I'm uploading that superstore.csv file. In fact, I uploaded both the files. Now I want to, let's say, read this file. How can I read it? Well, there are some things that you have to understand over here. So where is this file? Well, it's in a lengthy path. I like to show you that. This file I have saved into the folder day2. which is ideally inside our this folder, which is ideally inside our this folder, which is ideally inside Simplilearn folder. So overall, friends, my drive path is very complicated. In my drive, in my drive, I have created a temporary delete folder. Inside that, there is a Simplilearn folder. Inside that, there is a folder. Inside that, this is our folder. And inside that, this is our folder. And inside that, I have the file. Why am I telling you that is now I want to read that file. One way is, as I told you, I can directly read it. I can say ss is equal to pd.read csv, and you have the file read directly from GitHub, right? Directly from GitHub, you can see that. Okay. It is a big file, 10,000 rows and 31 columns. In fact, all the columns are not even displayed, neither are all the rows displayed. But I want to now read it. And let's say the size of the file is big. So you know what can I do? I have this option, mount the drive. So whenever your file is, let's say 800 MB, 900 MB, then uploading this file would be taking a lot of time. If you already have that file in one of the drive folder, if you already have that file, then it's better that you click on this. It is saying mount drive. When I click, some code will appear in the notebook. Connect to drive. I say yes. It says mounting the drive. No code has appeared. It used to appear earlier, but no code appeared. Earlier, a code used to appear and I had to run it. They automated it. That's good. And then I have my Google Drive mounted over here. I click on this drop down. I click on my drive. Then I look for temporary delete folder. Then I look for the Simplilearn folder alphabetically towards the end. Then I look at this IITK because I gave a very complicated path. Then if you give a simple path, then you may not have to do so many things. And inside that, I see these things. I want to read which data set. Superstore, click on this three dots and copy the path. That's it. So first you have to do the mounting. And after mounting, you go to that path and copy the path. Then after that, I can actually say ss1 is equal to pd.read csv, and this path, which it will be pasted by that path. Very lengthy path in my case, but in your case, it may not be such a lengthy path, and I read it. So every time you will have to mount your drive for reading the data. Every time you will have to mount your drive. And your path will be different than mine path. So these are the different ways you can think of reading the things in Colab. Right? So sometimes you will also see the files are zipped. Right? So files are zipped. So these are, another scenarios where you have to unzip the file and read it. But yeah, essentially, these are the ways you do it. Reading of the files and everything is done. And this is my data frame so far. So now we understand the various ways of reading the file and all these things are done. Now, if this is the data frame, I'll read one more data frame, which is the superstore. And let me get the superstore in the Excel file mode. So I'm downloading it so that I can show it to you here only. superstore.xls. SS is equal to pd dot read excel. The name of the file is this. Excuse me. And I just say SS. And as expected, Pandas require 3.1 or newer version of PyXL to read this file. Sheet name PyXL. I don't want to go open PyXL. It can be read using the Pandas as well. Maybe I have to upgrade my Pandas version. So I say pip install Pandas upgrade, printing the version. It's this only. So this is the latest one specifically. So, but it can be read in Excel as well. Maybe the version is older. That's the reason. But that's not a problem. So you all can see that this works. Maybe my version of Pandas is little old. Let me see what version it supports. Well, it's actually dancing up and down. I don't know why. I click here. 2.2.2. But anyways, it was giving some trouble, but you have it over here, right? So this is how you can read an Excel file. And there are many other third-party libraries. You can use OpenPyXL, and there are many, many more libraries other than OpenPyXL, which can be used for reading the Excel file. But we are here to only understand Pandas and runtime. Sorry, for saving it, runtime, disconnect. So the code successfully works. That's completely fine today if it didn't work on my system, but I'm sure everyone followed how you can read a CSV file as well. I hope it's clear to everyone. Let's go ahead. And Pandas is like the heart, very, very important. So if you follow it, that's awesome. So now we have our data frame here. Now, what is this data frame? See, this data frame is about a student. There is a student called as Henry. His overall grade is A. He is obedient. He scored 90 marks in the research score subject, 85 marks in the project score subject. Based on that, will the university recommend him some kind of grant or maybe some admission fee discount, scholarship, etc.? Answer is yes. David, on the other hand, overall grade F, not obedient, bad marks, 10 out of 100, 17 out of 100. Recommendation, no. In this way, I have a toy data set. You know why am I considering this toy data set? The only reason is I also have the superstore data set, right? So I do have this superstore data set from where I can read this. The reason I have chosen going ahead with this toy data set is because it will help me understand. For example, if I ask you a question, can you tell me in this data set, which is having 9,994 rows, what all are the unique values in the category column? Can anyone tell me by looking at this, what all are the unique values? No, because you don't see all the 10,000 values. Right. On the other hand, I tell you that, can you tell me what all are the unique values in the recommend column? Can you say in this case, because this data set only consists of 8 rows? It only consists of 8 rows. Yes. So the only intention behind choosing a small data set while understanding the library is we are able to cross check our results. Whatever code I write, it will work on this data frame or it will work on a data frame of any number of rows. The reason for choosing a small data frame is understanding. Okay, don't forget that. The only reason for choosing a small data frame is understanding. Else, absolutely, there is no reason. So, here. So we have all of these things in place, and I was saying we have this data frame as well. Now, in this data frame, if I want to print the shape of the data frame, I will say df.shape. Done. 8 rows, 6 columns. In the same way, if I want to print all the columns of the data frame, I will say df.columns. That is what I will write. In the same way, as I told you, if I want to print the values of the data frame, I will say df.values, which is this NumPy array. If I say I want to print the index of the data frame, I will say df.index. We have already seen that, right? It goes from 0 to 8. This time it's not A, B, C, D, E. If you recall, it's going from 0 to 8. So it is saying that starting from 0, going to 8 minus 1 with a step size of 1. Okay. If they are A, B, C, D or anything else, then it will be displayed properly one by one. Okay. Now, the thing is, if I have to select one single column from the data frame, then I would like to propose you two ways. The first one is using the column name as an attribute, where the syntax is df.column name. Let's say I want to select the recommend column. I want to select the recommend column. So I will write df.recommend. I'll write df.recommend. And you see the recommend column is selected. Very, very easy. Selecting a column of the data frame, because to do some operation, you need to select that. So df.recommend is for selecting one column of the data frame. And overall, if I look into this, the type of df is a data frame. Okay. And data frame is two-dimensional in nature. You know what? What will be the type of this? It will be a series. Type of this will be a series. Listen to me very carefully. This entire thing is a data frame. Every column in the data frame is a series. So that's one series, second, third, fourth, fifth, sixth. So this data frame is a collection of 6 series. Data frame is a collection of 6 series. Okay. Now, this is the first way, and I would like to say that it is not recommended. Now you'll be like, it's so easy, why is it not recommended? No problem. I will like to go on to the second way. The second way is using the column name as the key. Now that may look a little bit complicated, but this is the best way. That's like this. df square bracket, and in double quotes, you write the column name. So you want to select the recommend column, you will write it like this and not like this. And this is what is recommended. Output will be same. You can see the output is the same. Even if I look into the type of this, it will be a series only. But why is this recommended? The reason this approach of selecting is recommended as compared to the other approaches is because, see here, in this data frame, if the name of the column to be selected is not recommend, but if it is research score, then df dot research score. I get this. But imagine the name of the research score column is not like this, but it is research space score. Then it will give an error. I can show you that. I know that df dot columns gives me all the column names. I say df dot columns is equal to paste it. And I say, please make this research score as research space score, overall grade like this for better column readability. And see, everything has changed. So this is kind of like changing the column names. And I was able to put in spaces. I can replace it by anything, but I just inserted spaces. Now, in this case, if I say df square bracket research score, because it is contained in the single quotes, it works, right? So it can be research score can be in double quotes or research score can be in single quotes. That's not a problem. But if I say df dot research score, it can fail. If I say df dot research score, it can fail. Maybe, I'll just comment it out. That's a clear case of syntax error. Therefore, I say it's not recommended. Maybe if you write something like this, it was expected to work, but that also doesn't work. That is the reason I said that the first way, which is square brackets, double quotes, is the ideal way to select. I use any one of these ways. I mean, I can use this one as well. I mean to say I can use this one as well, or I can use this one as well. I recommend you also, but just be aware that when there is a space, the first one doesn't work. Okay. So that is for selecting one single column from the data frame. Okay. What if I want to select more than one column from the data frame? So what all are the column names? Well, the names of the columns were obtained like this, right? So let's say I want to select the columns name, overall grade, and I want to select, let's say, recommend column. Okay, these are the three columns which I aim to select. So these are the names of the columns. So what will I do? I will select I'll create a list, columns to select. I have created a list, which is, these are the columns I wish to select. And then in the data frame, I will put the columns to select. And there you have it. In the data frame, I put columns to select, and there you have it. Look into this code. And because this columns to select is taken from here, then now I'm thinking that what if I actually cut this and just remove this? And here only, whatever I did cut, I paste it. Essentially, I did the same thing. These two are the same. I just replaced line number two's content directly inside this, if you see. Directly, I replaced it inside this. So what do we understand? For selecting one column, you are going to use single square bracket. And for selecting anything more than one column, you will be using two square brackets. This is what we understand, right? One column or more than one column. And That is how you select it after this. Next, we say over here. That's my data frame. Now, if the data frame is SS, it's consisting of these many rows and these many columns. Right. Now, here, obviously, it's taking a lot of space on my screen. So what I want to say is, if I want to print the first 5 rows of the data frame, I use the head function of the data frame. So ss dot head, and you can see it only prints the first 5 rows. And inside this, if you supply a number like 2, it will read only the first 2 rows. Inside this, if you supply a number like 7, it will read the first 7 rows. Can you supply 8,000? Will it print all the 8,000 rows? No. Max to max number which I have tried from hit and trial is 60. But don't do that. So, see, this data frame is basically for understanding how the data looks like. It's like, how are you recognized at the airport? You show your passport size photo. This is me. That is the only purpose of this head function. It just shows how the data frame looks like. And if you have to look at the last 5 rows of the data frame, then it is the tail function. Last 5 rows. And in tail also, if you give a number like 3, it will show you the last 3 rows. Then this is what we understand. Now, with respect to the ss dot head only, if you see carefully, I'm not able to see all the columns of the data frame because there are total 31 columns. Now, this comes with a very simple code to be added. So if you want to display all the columns of the data frame, then you will have to set the pandas display options. And I say over here, pd dot set option display dot max column comma none. None means maximum columns display. If you write over here 7, it will only display maximum 7 column, but you will always write none only. And now if I say ss dot head of 3, you see all the column names. You see a scroll bar as well. So category, city, country, customer ID, customer name, and so on and so forth. This is how the content of the data frame looks like. This is how the content of the data frame looks like. Okay. Now after this, getting back to my data frame df. Now, we understood how to select one column. If I want to look into the data types of all the columns, then I have the attribute called as d types. If I just say df.dtypes, every column's data type is printed. So research score and project score are integer. Depending on the data, it can be float also. If it is 90 point something, then all other columns are string, but Pandas calls string as either an object or category. So don't be worried about it. It is nothing but of the string data type or the categorical data type. Okay, so that's one thing which I wanted to show you over here. So this is all done. Then after that, if you want to print the information about the data frame, you have the info function. And this is interesting because if you look carefully, the output of D types is again printed here. So what all you see over here, it says that, hey, it is a Pandas core data frame. Second, it says there are 8 rows going from 0 to 7. Third, it says there are 6 columns. Next, it says these are the names of the columns, data types of the columns. In every column, how many non-null values are there? Like in name column, it says 8 non-null values are there because in our data frame DF, we know that there is nothing missing. Are there any non-null values? No. If there are any non-null values, they will be saved as NaN, not a number. But we can see the entire data frame. So you don't see any non-null values. It says that there are 2 columns of integer data type in this data frame and 4 of the object data type. The total memory usage is 516 bytes. And if I try the same thing with my superstore data frame, see, total 9994 are there. But in the order ID, it's clear that there are missing values. That's why it's saying 800, right? In the same way, going forward, you can look for other things as well. So we understand clearly the data types are there. The size obtained is 2.4 MB plus float data types 2 and this is what we understand from this. So this is over and then DF. Info, this. Yes. If I want to find out what all are the unique values in the recommend column, I can say I want to find all the unique values in the, let's say, recommend column. So I'll use the unique function and df dot recommend dot unique. That's it. So I know it's only yes and no. And it says that, and the output is a NumPy array, by the way. Oh, but you don't be worried about it. And if I want to find the count of unique values in the recommend column, I use n unique function. So there are only 2 unique values, right? Yes and no. So the count is 2. Yes, no. Unique values. You get that. So in the superstore data set, I remember there was a category column. What all were the unique categories over there? Office supplies, furniture, and technology. And if I use the n unique over there, because it was a big data set, there are 3 unique categories. And if I want to print the count of unique values in each column of the data frame, or let's say, I'll be very simple. Here, this recommend column is giving me, when I say df.recommend.unique, what is it giving me? It is telling me what all are the unique values, yes and no. Instead of this unique, if I say value counts, so value counts will be counting the unique values in the recommend column. Have a look at the output. And that's what will be returned. That's what will be returned. Whatever you said, it returned that. Perfect. 5 and 3. That's what it returned. And there is a parameter inside this recommend value counts, which is called as normalize. And the default value of normalize is false. I want to tell you that normalize equal to false is the default value. So if I run it, you don't see any change. You do not see any change with respect to these two codes. 5.3 is the output here, and here also is 5.3. But if I write normalize as true, then it gives me the percentage. You know what is it giving? I'll tell you. How many times no is there? 5. 5 times no is there. Out of total 8 records, so 5 upon 8 is 62.5. Percentage wise, 62.5% of the times that column contains no, and 37.5% times it contains yes. So this is what it is returning me. And if you want it truly in the percentage scale of 1 to 100, then you can definitely take the same code and multiply it by 100. So instead of 0.625, you get 62.5 and so on. Very easy and very convenient. Very easy and very convenient. Right. So this can be helpful in this category column as well. So in this category, if I apply the value counts, out of 9,994 records, I know that most of them are office supplies and the least are from the category technology. So it's very easy to identify at a scale, right? Now in this data frame, if I want to find the missing values, I have the function is null. So it will tell me where all missing values are there. Wherever you see a true, missing value is there. You see anywhere true? I don't see. I don't see. Even I don't see. But if I do the same thing on the superstore, I will go mad because there are 10,000 rows and 31 columns. I don't have time to keep on looking for true this way. I don't have that much time. So what will I do? I will apply the sum function ahead of this. So sum function will be telling how many times in this category column true is there, how many times in this category city column true is there, how many times in this region column true is there, every column total. That's nice. So order ID column has 9194 missing values. Returned also has this. Now it's very difficult for me to keep on searching. So what am I planning to do is this entire thing, can I sort it in the descending order? And I can do that using the function called as sort values, whose ascending is by default true. So I say descending. So what happens is it is going to sort this earlier printed value using the sort values function. Ascending is by default true. So I'm writing descending, which is nothing but ascending is equal to false. And now, because I know that I got the first zero over here, and because this entire thing is in the descending order, I need not even look below because everything is already in the descending order. And that is what is the idea over here. Hence the thing. See now over here, I want to say some important thing. Listen to this very carefully. Now, here in this case, see these are 0, 1, 2, 3, 4, and these are the ones. Internally, it also maintains numbers. And so these are the internally maintained numbers for every row and every column. If you want to refer to those, you have to refer to ilog. And if you have to refer to the external ones, which means the ones which are shown over here and here, you will have to go for log. What I mean by that is, let's keep our target very simple. So my target is to get everything from Henry to Marvin. So this is what is my target. How can I do it? I say df dot ILOC. df dot ILOC. I have to give the rows to be selected and the columns to be selected because I'm using the implicit location. Okay, ILOC means implicit location. So which rows I want to be selected? Well, the rows which I want to be selected are row number 0 to row number 4. I'm referring to the ones which are here. All right. I want row number 0 to 4, which means my starting index will be 0 and my ending index will be 5, which means it will go till 5 minus 1. And which all columns I want to select? Column and I want to select 0, 1, and 2. So I want to select column 0 to 2, which means my starting index would be 0 and ending index would be 3. That is how 0 to 2 will be selected, and here 0 to 5 will be selected, which will take up to 4. Let me try it out. df dot ILOC, row number 0 to 5 minus 1, column number 0 to 3 minus 1. It should give me Henry till Marvin, Y till N. Does it? It does. Did you all follow the ILOC, which are nothing but the implicitly given numbers, which are in the yellow ink? Which are in the yellow ink? Yes. In this way, you can select anything. You can select anything. One operation is sufficient. You can select literally anything, but it has to be consecutive. You cannot say that, can I select one row and then third row and then fifth row? No, that all things are not. That is also possible, but right now we are not getting into it. Okay, this is clear. Now, I'll go ahead. Once again, print my data frame. I say df dot lock rows and columns. Which rows I want to select? Now refer to the white one, 0 to 4. So rows I want to select 0 to 4. And the columns which I want to select are what? Right from name to obedient. So start would be name and end index would be obedient. Let me explain you. It has fetched the same thing first of all. Something interesting. The interesting part is in lock, for which I am actually using the pink ink. In lock, the start index had to be 0 and the end index had to be 4. And while giving that, I actually gave the same. I didn't give 5. Earlier, I gave 5. And here the start must be name and the end must be obedient. Exactly that is what I gave. I didn't give obedient plus 1 or something. That is the difference, right? The difference is in ILOC, the start index is start index, but end index is considered ideally as end index minus 1, whereas in lock, start index is start index and end index is also end index. Why? Obviously, you cannot say obedient plus 1 or research score minus 1. That all things, how can you do research score minus 1? That's not allowed. So in lock, start index is start index, end index is end index. This is one of the very important observation. This is one of the very, very, very important observation. Have a close understanding of this concept. What is start index and what is end index in each of these scenarios? So now I got this. I am going ahead. Now here in this data frame, not data frame, I'll go to the population. You remember population was a series that we created at the start. Here, this one, we created a dictionary, and from the dictionary, we created a series. I'm talking about this, right? This. Now, inside this population also, these are the indexes. So here I can say population dot iloc. So if I have to select California, California ideally is at index 0. You see, I'm getting the data for California, right? And if I got to do the same thing and I want to write over here California, then I will have to use lock. Gets the same information, right? So this is internally 0, 1, 2, 3, 4, 5. This is what it is internally. Okay. In the same way, if I want to select the data from California to Florida, so California is at index 0, Texas is at index 1, Florida is at index 2. So that means I will have to write population dot ilog, and California is at index 0 and Florida is at index 2. So that will select the entire highlighted portion. So this if I want this as the output, then I will write population dot ilog. It has to be 3. Absolutely correct. Yes. And if this is the code for ilog to get me the following output. Lock is about using the externally given indexes, which is California, Texas, and Florida. Now we get into some interesting operations. So what I say over here is, so we have a list of students. We have a list of students. Now, what am I planning is to create their report card. First thing, I am planning that I will like to find out the total of this and create a new column over here, which is called as total, in the sense 90 plus 85 should come here, 85 plus 51 should come here, 10 plus 17 should come here, 75 plus 17 should come here, 20 plus 30 should come here, so on and so forth. How do I do it? Very simple. Research score and project score has to be total. So I write research score like this, and I add it with the project score. Does that give the total? Yes. Did you notice over here, the beautiful part of Pandas is no for loop is required for doing the operations across every row. For loop nahi chahiye. It's not required. It can still manage it. There is a for loop which is running internally, because of which it is actually totaling. Are you all following it? Internally for loop. So it's all basic code is ready. You just have to do the addition and your job is done. Are you clear so far? How did this addition come without a for loop? Very, very important to know. Internally, there is a for loop. When I learned pandas for the very first time, like an idiot, I used to actually write a for loop to find the total, because I was very much habituated to using C language, C++ language. It took me almost a month to understand that all of these are advanced level coding and I need not think of writing the things from the scratch. So I had a very bad experience when I learned pandas for the very first time. It took me almost 3 months to be very comfortable with it. I mean, just playing around with everything. It took me 3 months. So, but one thing is remaining. This is okay. But I want this to be saved in a new column. So I say, what is the new column that I want to create? Total. So df of total is equal to this. I'm done. It will automatically create a new column. Best, best. That is the best part of it. You don't have to worry a lot about it. It will automatically create a new column. How convenient and easy it is. You need not even write a code to create a new column. Huh. If you say that I want to create a new column and insert it in between these two, then the things are different. Then the things are different. There is a function which is called as insert for inserting it at a particular index. But by default, it is automatically inserted at the end. So let's say you want to create, I'm just doing a dummy column, dummy. Okay. So I want to insert a column. Let's say internally we know, right? This is 0, 1, 2, 3, 4, 5, 6. Let's say in between name and overall grade, I want to create a column called as dummy, which will just have one single value, 1, 1, 1, 1, 1, just like that, just to show you that I want to insert a column dummy in between this. And I don't know how to do it. Let's say I don't know how to do it. I am making you ready to solve any problem by yourself. If I am not there, how do you survive? Go to Google and search for insert pandas. Or let's say you don't know that also, right? So I say insert column in a data frame. Hi, you don't know what to Google, you don't know the name of the function, nothing. Insert column in a data frame. Pandas says I have a method. So this gives me some idea that, okay, I can do it this way. Geek for Geek is also giving me some help. I'm opening it. W3 School is also giving me some help. Let me look into the first help. Insert. Insert a column at a... Okay, I got it. Insert a column at a specified location. And what it says, first you tell me at what index you want to insert. So that's one thing. Second, it says, tell me the name of the column that you want to insert. Third, tell me the value of the column that you want to insert. And do you want to allow the duplicates? You have over here true or false that can be given. Okay, I understood it. In fact, there is one example also given over here. Okay, that's one thing. Let's say I'm just typing, putting this. Then this Geek for Geek is also there to help us out. So it says that if you have a data frame like this and you want to add a column with static value to the pandas data frame, what have they added? Let me see. What was there? Age, name, and address. Age, name, address. Okay, they added it at the end. Okay, that's okay. Then insert. See here. That's good. This is a good resource. W3 always is awesome. It says, they say you have a data frame. I tried it. This is a data frame, name, age, and qualified. And okay, name and age are only there. Qualified is not there. Let us print the data frame again. And let's run it. You can see name and qualified were there, and now it is name qualified age. It says you have a data frame like this. I say I want to insert at index location 1, the new column called as age. Okay, so this is 0th column, this is the first column. At first column, that means this column will be shifted and the values will be 50, 40, 30, and that is how you insert, right? You can also insert it on the basis of some condition, but I think that we can take it later. And now that we have it, I don't wish to execute it because we already have it. So I will better comment out this code. You can run it at any point of time. The reason I'm commenting it out because the name of the data frame is df. If I execute this code, then my original data frame is also called as df. That would be lost. So I will have to change the variable name. But anyways, I did show you the output. So I don't think so I need to execute it. You should be able to automatically figure this out. Okay. So that's my data frame so far. Over here, I want to have one more column over here, which will be called as percentage. So how is the percentage computed for Henry? So on and so forth, computed for everyone. So the way I do it is df of percentage is equal to df of total divided by 200 into 100, exactly like this, because total value divided by 200 into 100, you need not write 175, 136, you just give the column name and it is good to do its job. You can see this. So what I want to do is I want to find the topper in the class. So I will consider sorting this data frame in the descending order of percentage, right? A very realistic operation to sort it in the descending order. So I say that I want to sort the data frame in the descending order of percentage column. So the function that I will be using will be the sort values, and you have to sort it by which column. It has a parameter by. So I will supply that I want to sort it by the percentage column, and ascending is equal to true is by default. If I say ascending is equal to false, it will be doing it in the descending order. So this is how I do it. Okay, now pay attention. The sorting happens but does not happen also. I'll tell you what I mean. df dot sort values by percentage column, ascending is equal to false. And you see that it's all in the ascending order, a descending order, all perfect. Let me print the data frame once again for you. Is it really sorted? Answer is no. It's sorted, but then when I printed it again, it is not sorted. Okay, so I was saying we actually sorted the things, and after sorting, we saw that the sorting result is not saved because when I printed it, I don't see this, right? And therefore, we see that the changes are not getting saved. So what will I do? Well, I'll tell you what went wrong. Here, when you said sort it, it actually sorts. It actually sorts in the descending order, but it is not saving it. So you will have to write df is equal to df dot sort. So what will happen is after sorting, whatever is this result, it will be saving it into df. Okay, that's one way of doing. That is one way of doing. After sorting, you can save it. Data scientists use this second way, in place equal to true. Both of these way are equally correct. It is not that one way is efficient over other. I'll tell you what is happening. In this case, You sort it on the left hand side, and whatever is the result of the sorting, you ask it to save it to the data frame. And in the second way, or both of them are same, equally efficient, you are sorting it, and I say that, hey, whatever sorting you are doing, do it in the same data frame. Do it in the same data frame. So this is a shortcut of writing. After writing this code, you need not come back and write df equal to. So this is what people prefer. But both of these ways are equally safe. It's not that one is efficient over other. As simple as that. And therefore, now when I execute it, what happened? Df dot sort, additional space. Yeah. And now when I print it, I use the second syntax with in place equal to true. In place means sorted in the same data frame. And you can see over here, results are here. It is just a way of quickly sorting and ensuring that the changes are saved in the data frame. You can use any one of these two approaches. Both of them are same. Both of them are same. Right? Yes, both of them are same. I would recommend you to use the approach on line number 4, but both of them are equally efficient because they are doing essentially the same thing. Right? Yes. Perfect. Now, how do I know there is an in place parameter? Well, you can Google about it. Here, sort values. You see over here, there are so many parameters. In place equal to false by default. And what does that mean? If true, it will perform the operation in place. Okay. Then, one interesting thing, the index numbers have changed. Earlier, it was going from 0, 1, 2, 3, but now they have changed. And that's absolutely phenomenal observation. So that's absolutely correct. So what I want to do is, I don't like this. So I will like to reset the indexes. So how do I reset the indexes? I say df is equal to, okay, first let's do it shortcut, df dot reset index. That's it. Let's see whether it resets the index. Data frame dot reset index. It does. See the indexes which were this. So this is a perfect function, right? This column which was here actually got inserted as a new column here. There should be the complaint. Yes, one extra column came. Yes, that's a good observation. Okay, but before I do that, first of all, I will have to save the operation. So I will say df is equal to df dot reset index or df dot reset index, and I say in place equal to true. Any one of this approach. This time I'm using the above one. And then I say, show me the df. Okay. Now there is one problem that we have one additional column inserted. Now I want to talk about dropping a column. So for dropping a column, which will be very useful while you are doing data cleaning, where let's say there are many columns and you don't need some of the column, or you want to drop the less important columns. I want to drop the column. So how do I drop a particular column? So the way one can drop this column is use the drop function. So drop function is used to drop the column. So it is used to drop either a row or a column. Now, how can the same function be used to drop a row or drop a column? Well, because it has a access parameter. So it has an access parameter where if you are supplying access is equal to 1, then it is rows, and if it is 0, it is equal to columns. We don't need all of these parameters, so I don't want to confuse you right now. Okay. Okay. So whichever columns I want to drop, access. Now here in this, labels is which row or column you want to drop. Access is this. Let us talk about it. Let us assume, I'm not actually finalizing this operation, but let's assume that I want to drop row 0 and row 5. Why? Just to show you. I'm not permanently say doing this operation, but I want to drop this too. So what will I do? df dot drop. And which all rows to be dropped? Row number 0 and row number 5. Row number 0 and row number 5. Because I have to drop the rows, I will write axis is equal to 0. And I will not write in place equal to true, else the operation will get saved. I just want to show you. So row 0 and 5, are they getting dropped? This 0 and 5. Don't refer the index column, the original indexes now. You can see that 0 and 5 are no more there. So in this way, you can drop in the rows. Okay. In the same way, operation is not saved. We all know that. It's just a temporary operation. I want to drop a column. So I say df dot drop. And what I want to drop, you write down the name of the column. The name of the column to be dropped is index. So I'll write index. Access equal to 1, in place equal to true. See now, if you want to drop more than one column, no problem. This is a list, right? Keep on supplying as many name of columns you want to drop, but that column should be there. If I say over here that could you drop for me the column index 1, there is no index 1 column. It will give an error, key error. That key doesn't exist. But index column is there. It stopped. Okay. Let's say I'm adding a dummy column, df of dummy column, which is just some constant value 100, just a constant value 100. You see a dummy column is added. I want to drop that. Now you know what is the code to drop it, but I want to show you a different way. df dot drop. And the column to be dropped is dummy. So if you see over here, I do have a columns parameter also. If I don't want to go ahead with this style with the access, you can just say columns is equal to this. And now what will happen is it will still work without access because you clearly said no, that I want to drop the columns by this name. So when you say you want to drop the column, there is no question of access. So access becomes optional in this case. So we saw two things, how conveniently a dummy column can be added and how it can be dropped. So I understand Henry is the student who has got the highest percentage. Okay. That is something which is very clear from this. Let's take it ahead. How to drop the row in the second method. You have rows equal to also as one of the parameter. Rows equal to. So let us consider doing that. So let's say I want to drop the row 3. John's row has to be dropped. So drop row number 3. So you can put it this way. I'm not saving it. Sorry. I don't want to save it. I just am trying to show you. That's how you can do it. So John is out. We have this. And percentage column is there. Now percentage is also sorted in the descending order. Now what I want to do is I want to round off the percentage column. So for rounding of the percentage column, I have two ways. So the first is I can say When I say round off, it will round off to two decimal places. This will round off to three decimal places. And if I don't give any number, it will round off to zero decimal places. Then I will say, I can also use the round function of NumPy, where I say print. Now you can see round and np.round both are doing the same thing. Which one will you use in a long run? Which one will you use? The round or np.round? And why? Why? Performance faster. That's correct. So we will use the NumPy. Now in this data frame, it does not matter because we have only 8 records, but in a long run, you will use NumPy, right? Now you understand the true idea behind NumPy. That's good. So friends, I have my data frame over here and I want to round off the percentage. Now, why do I want to round up? Because I want to show you that operation. Else, ideally, one never rounds off the percentage. That's quite logical. But let's say I want to show you that operation because I am trying to give you maximum exposure to pandas. So I say df, or I will say round the percentage column to zero decimals. So df of percentage is equal to np dot round df of percentage. You need not even write this zero. That is still okay. And it is done. I'm only working on the percentage column, rounding it off, and it is done. After rounding it off, I want to check the data type of every column, or specifically the percentage column. I want to check the data type of that column. What should I do? So yes, there are two ways. D type, D types are not D type, D types. In NumPy, it is D type. Here it is D types. So I can say df dot D types. That's one way, and that's perfect over here, I would say. And it says percentage is of the float. Or I can also say df dot info, which will give this. Okay. So, but the question is, when you look at the data frame, is the percentage column now even expected to be in float? Do you think we should keep it float? Because anyways, there is nothing after dot, right? Yes. So I want to, or I wish to now convert the percentage column to integer. And for that, you have the as type function. df of percentage dot as type to integer. You can also write in double quotes integer. You can also write in double quotes in 64. But why are you complicating the code? This works. And percentage is converted to integer. Now what I want to do is I want to add a column which is called as pass or fail. I want to add a column pass or fail. So I am creating a user defined function called as calculate result, which will be taking in the percentage column. And if the percentage is greater than equal to 40, it will return pass, else it will return fail. Very basic user defined function, which is going to be helpful for adding a new column called as pass or fail. And I want to apply this function. And that is how I do it. I say on the percentage column, I want to apply the calculate result function. So see what happens. Let me explain you what happens. first the number 88, right? df of percentage dot apply calculate result. So number 88 is being passed here. It checks, is 88 greater than equal to 40? Yes, it returns pass, and that pass is saved into new column called as result. Then it sends 86, that will again evaluate and return pass. So on and so forth. It happens till 14. When 14 is sent, 14 greater than 40, no, return fail, and that is saved here. That is how this column is. That is how this column is populated. And if you note over here, while giving a call to calculate result, I did not call a function like this. Usually you call a function this way, right? This is how you call it. But you if you give that, that's going to be an error. This is the right way you can call it. Apply is a advanced level function. It says you need not give round brackets. In fact, if you give it, I will give you an error. If you give it, I will give you an error. So you should not give that. And this is the reason we studied the lambda functions. This is the reason we studied the lambda functions. Where, see, if you remember, lambda function, what was the lambda function syntax? We had lambda, arguments and expression. So I can achieve the same task using the lambda function. I am saying df of result underscore lambda because that is already computed. See, lambda percentage, that's the argument. If the percentage is greater than equal to 40, return pass, else fail. So instead of writing a different function, lambda function can be integrated because this is one-time use logic. I'm not going to require again and again, and that are, or this is the ideal place where a lambda function is helpful. And then I want to drop this column, which is quite obvious that I need not talk about. So I have the result of the student populated so far. Let's go through what all have we done in the previous class and have a very quick glimpse of it. Pandas consist of two data structures. One is the series and another is a data frame. That's one thing that we understood. And then this is how a series was there. A data frame consists of series. That was another thing that we saw. Then this is the syntax for creating a series. pd.series, you given the data and you given the index. So that's what we have in over here. We also saw how do we do slicing and indexing in series, exactly same like list. In series, we can give indexes of our choice. That's another thing that we have seen and that successfully works. Right, that's how it comes. Then series also supports broadcasting. So if you have one number and multiple things, number is broadcasted. Then we understood a data frame, right? The syntax for creating a data frame, you give data, index, and columns. This population series that we had. See, always remember a series will be represented like this. It will always be like this because going forward down the line, you may experience it. So whenever at the, sorry, not even this, I would say, whenever at the bottom you see D type written with the values above it, always assume this to be a series. And a data frame looks like this. Then after that, When you have a data frame like this, as you can see, these are the rows and these are the columns. Then you can give the index and the columns as well while creating a data frame. Then I can read a data frame from the GitHub directly by pasting the link as it is over here, or you got to supply the complete path. We saw, right? You can read a CSV file, Excel file, all this was ChatGPT generated content. I quickly pasted over here for your reference. JSON file, Parquet file. Parquet is used in mainly the Apache formats. Apache formats in the sense when you are working on a distributed system, Parquet file save the same CSV file in a compressed form. So that is the biggest advantage of the Parquet files. And then SQL databases, you have to import a module and get it done. You can read an HTML file. Then clipboard data, if any table data is copied. ORC, again, it is used in the sense of compressed format only. Feather data set, mainly useful for the pipeline stages. Pickle file for machine learning. XML, we know. Google Sheets also can be read by giving this, this format equal to CSV. These things are important. Zip file can also be read using the read CSV zip, and then you have to unzip it. Then Amazon S3, right? And better option for Google Drive is to download and consume it, right? That's one thing I told you. Or GDown is the package which can be helpful. After reading this data frame, we also read a superstore data frame. We may end up using them little today as well because we are left out with little bit of pandas. So that will take another 1 hour, I guess, 1 hour, 1 hour, 15 minutes for completing pandas. And then we get started with the Matplotlib. Shape will tell me rows and columns. Columns will only print the names of the columns. Now values, the moment I say df dot values, the output that you see over here is a NumPy array. Always remember the output that you see is a NumPy array. To select a single column, you can use dot or you can use square bracket double quotes, of which the recommended syntax is this, because if there are any spaces, then this syntax is better. Then you have to change the names of the columns. You can write df dot column, but you can also change the name of the columns using the rename function. Right? You have a rename function which can be used for renaming the names of the columns. So here, rename pandas data frame column. You see over here, rename function. It needs a mapper. Have they given any example? Yes. So if you see over here, this data frame is being created. So column A, column B. Right? I hope you recollect. This is column A having, sorry. So this is column A having the values 1, 2, 3, column B having 4, 5, 6. So I say rename. Columns is equal to A will be renamed as small a and B will be renamed as small c. So that's how it comes. Initially, the column names are capital A and capital B, like this. But I renamed it to small a and small c. For selecting multiple columns, I said it's always good to use 2 square brackets instead of 1. Everyone knows that very well. Then if you want to see the top 5 rows, use the head function. Bottom 5 rows, use the tail function. And head can also be supplied with a number that will display only that many number of rows. The maximum number that we can give over here is what? What is the biggest value that I can give in the head? Head can display top 5, top 6, top 7. What is the biggest number that one can give in the head? And don't trust me, try it once. You never know, in the updated version of Pandas, this has changed. But I think they won't change it. Usually they don't change all these small things, but you can try it once. On the Superstore data frame, you can definitely try it. Set option. Set option is for displaying all the columns, because earlier you see dot in between the column names. So set option display dot max column will display all the column because the second parameter is none. If I supply 100 over here, it will only display the 100 columns out of, let's say, 500 columns, let's say. So you can choose that number over here. D types, we know all the data types are listed. Info is the information of the data frame. These all are very common functions. You need to use it every time in any project. Then you have to find out the unique values in the recommend column. So that's done using unique function. If you want to find out how many students were recommended and how many are not, that is how many yes and how many no. Like here we can clearly see 1, 2, 3, 3 yes and 5 no's. If you want to have that, and that too in the descending order, then value counts is the function. Whereas unique only prints the unique values. After that, the value counts can also be given normalized, which is by default false. If I keep it as true, it gives the things in the form of percentage. Multiply by 100 will get it on a scale of 100. So 0.625 becomes 62.5. N unique function, see these all functions, you may be like, these all are so stupid, silly functions. Why do we even need it? Imagine a data set which has 50,000 rows or 5 lakh rows. How will you know how many unique values are there? Because going forward, you'll be looking at a technique like get dummies. I'll tell you what it is. Machine says, Darshan, we do not understand English. Machine says, Darshan, we do not understand English. We only understand numbers. So what they do is, if you give it any kind of column which has categorical variables, like for example, this, or I'll take one more simple example, this. Now, if I ask you, how many unique values are there in the sex column? What will you answer? How many unique values are there in the sex column? 2. Very good. If this data set had 5 lakh rows, would you have been sure about this number 2? If this data set had 5 lakh rows, would you have been sure that there is only male and female? No, right? This is still okay. But you know what happens when you start with machine learning? Machines say that, Darshan, I do not understand English. So please convert it to equivalent numbers. What I mean by that, let me explain you. So what the get dummies function of Pandas does, we don't have to study it today. It will come in the machine learning part. But what does the get dummies function of the Pandas does over here is, it will find out the unique values in this. So the unique values are found out to be male and female, right? So it will create 2 columns, sex underscore male, sex underscore female. And then it looks into the first one is male. So in place of male, it writes 1, female 0. Second is female. So in place of female, it writes 1, that's 0. Third is female. In place of female, it writes 1, that's 0. Fourth is male, it writes 1 over here and 0. Now, this means that one column is converted into 2 columns. If there are 5 unique values, then one column will be converted into how many columns? 5 columns. Now, you will be like, okay, fine, 5 values are still good. I can go ahead with it. If in a column, let's say instead of sex, the column is the products, and that company manufactures 50 different products. So this products column has 5 lakh values and there are 50 unique values. Now, in that case, your data set has one column called as product, and there are another 50 such columns which are different, not products, could be sales, etc., etc. But before machine learning, one column would be converted into total 50 different columns. One column would be converted into 50 different columns. And that is not a good idea. That is not a good idea. Over there, these functions in machine learning are very, very helpful because you can use the n unique function to find out how many unique values are there in one column. And then if the number of unique values are way more higher, that means if you transform it using the get dummies and it is going to become one column becomes 50 columns, then it's not a good idea. In that case, what is recommended is instead of dummification, you go for label encoding. So what does label encoding do? Label encoding is going to see that, okay, what all are the unique colors? Red, green, blue, red. Red, green, blue are the unique colors. It assigns one number for each. Red is 0, green is 1, blue is 2. Whatever in the order it receives, it assigns that number. And then entire column is replaced with the mapping as red as 0, green as 1, blue as 2, red as 0. So wherever red comes in this column, that will be converted as 0. Wherever green comes, 1. Blue comes 2. So one column is still one column. Now, in which case to use which technique, that's a different story. But I'm just trying to make you understand the significance of n unique. So n unique is number of unique values. You can understand the practical significance of it. That's the only idea behind it. Okay. We will be coming back to this technique later on when we start into the feature engineering session. Right now, it was just to make you understand that all of these functions exist for some reason. Then unique will print out the unique values. And unique will print 1, 2, 3. There are 3 unique values. Obviously, we are looking in recommend. So there are yes and no 2 unique values. In n unique of the category, 1, 2, 3, 3 unique values. Then isNull.sum is for finding out the missing value, the count of the missing values or the sum of the missing values in every column. It's always good to have this in sorted order. So we understood the sort values functions, which will be sorting it to the descending order. Then this iloc and loc were very helpful. Iloc is implicit indexing. Loc is explicit indexing. So iloc is used for implicit indexing. So it will be accessing implicit index 0 and 5, that is rows from 0 to 4, columns from 0 to 2. And loc will be actually going from row 0 to row 4 only and column name to obedient. We had seen that, so let me not get into the teaching part of it once again. We are just getting into the quick revision. Then we understood that we quickly totaled up these two columns and created this column like this. Then coming over here, total upon 200 into 100 gave us this new column called as percentage. Then we sorted the percentage column using the sort values function in the descending order, but this does not get saved. So you need to write preserve the changes. This is also one of the way, but I would recommend this. That's why I kept it uncommented. Because when you're typing the code, you type it left to right, 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 and then you realize, oh, I have to save the change. So you again go over here. That time should not be wasted. Start typing, continuing the typing. Then reset index for resetting the index, but that creates a new column. And for that, we understood that I can either drop a column or I can drop a row. If I want to drop a column, axis is 1. And if I want to drop a row, the axis is going to be 0 in that case. After this, I can also drop without using the axis. So in that scenario, as I told you earlier, what will you do if you want to drop without using the axis? Columns parameters can be used. Similarly, if you want to drop rows without using the axis, rows parameter needs to be used. That's obvious and straightforward. Then round and NumPy round, we rounded off. So I told you NumPy round will be faster. And then the percentage column is converted to any data type, whatever you want, using the as type. And this was an important master stroke over here, that we calculated the result. And see here, the logic is simple. So we can definitely do it using the lambda. So I say that percentage column, I want to apply the lambda function. So every value of percentage column one by one goes into the variable per, and then it checks, is per greater than equal to 40? Yes, return pass, else return fail. That's how it is computed. And the same thing can be done with the help of user defined function. So the name of the function is calculate result. You can give a call like this. But in such cases, lambda functions are advisable. After that was the end of the session. Okay, now what am I doing? Closing this, and I'm kind of just for the reference renaming this as old pandas. Okay, so right now I'm naming it as pandas continued and old pandas. Both of them are available. I'll import the pandas library. And we will read this data. We will read this data. Rest of the things, I guess, we don't need it, but both these data sets are being read successfully using this. Now, the thing is, I am planning to look into this. I say info. Now, if you look into this, there must be ideally 9,994 rows everywhere. Then there are no missing values. That's a problem. That's a problem. And rest all things are good. Fine. Chalo, missing values are there. I'm not filling the missing values, but what I want to know is, if you look into the code, what do we see? Okay, I'll just say now here. So now, what I want to see is, what is this data about? Number one, this data set is about categories. Categories like office supplies, technology, furniture. Three categories are there. I know that. All of these are US cities, countries only US throughout. Every customer who ordered a product, it's like an Amazon data, right? Every customer who ordered the data product has a customer ID, and then customer name, date on which he ordered, ordered ID. We don't need all columns. I'm not explaining. Postal code of the customer, product ID, whatever he ordered, product name, quantity ordered. The customer belongs to which region? US has 4 regions: Central, East, south and west, east, west, central and south. There is no north in US. Central. Then after that, we can see there are three segments in here: consumer, home, office, and office supplies. Then shipping date, shipping mode. There are three, four types of shipping mode. State to which the customer belongs. There are around 17 subcategories. Three categories were there. There are around 17 subcategories. Discount offered, profit, quantity ordered, sales, return on sales. We don't need all the columns, so neither am I getting into discussion of this. Okay, so this is what we have. Now, what I want to do, what I want to do is I want to find out there are 17 subcategories. So let's say paper is one of the category. You have binders as one of the category, and so on and so forth. You have one, two, up to 17 subcategories. And what I want over here is the average sales of. So I want to find out what is the average sales of paper, what is the average sales of binder, so on and so forth. What is the average sale of this category? Do you understand how you have to approach this problem? Not in code, but do you understand how should you approach this problem? If you have to solve this problem, let's say in Microsoft Excel, do you understand how will you have to do it? Or at least the logic part, you will have to first of all filter the data for paper and find out the average sales. Then you remove the filter. Then you have to filter the data for binder. You find out the average sales, remove the filter, and keep on doing this till the last category and find that. Or another awesome suggestion is the pivot table. And third one is the group by. The third one is the group by. Let's understand. So now that you understand the concept, I am going to make you understand how does the group by works. Then we will get into the pivot table. This is the best example to understand group by, according to me. Maybe according to you it is not, but trust me, it is easy. So just like I said, you assume this column to be subcategory. Assume this column to be subcategory. So what will you do is, there are three subcategories: X, Y, Z, X, Y, Z. So uniquely you have X, Y, and Z. You separate out all the X records. Separate out all the Y records. Separate out all the Z records. Then that is what is called a splitting is done. Till this point of time, splitting is done. Then you need to ask which function to be applied. If the user says apply the sum function, then 10 plus 40, 50. 20 plus 50, 70. 30 plus 60, 90. And then you combine this x50 here, y70 here, z90 here. In our case, we asked the function to be applied was not sum, but average. So 10 plus 40 upon 2, 10 plus 40 is 50, 50 upon 2 should be 25. 20 plus 50 is 70, 70 upon 2 should be 35. 30 plus 60, 90, 90 upon 2 would be 45. So here 25, 35, 45. If someone would have said, no, you got to use the minimum function, then minimum of 10 and 40 would have been 10. Minimum of 20, 50 would have been 20. Minimum of 30, 60 would have been 30. So this should have been 10, 20, and 30 respectively. And in this way, it could have been applied to any scenario. Am I correct? Right? This is called as the group by. This is called as the group by. Yes. So now that you say you understand it, I am going to copy the link of this and I go to the next one, group by. And This is the link for it for your reference. Now, let us keep the problem initially simple. In this data frame, what I want to do is, I want to find the average marks of the students who are recommended yes and recommended no. I want to find the average marks. So on what column will I group by? On which column will I group by? I want to find the average marks of student as per recommend. So before that, I would like to show you the syntax. One is this, but df dot group by columns dot. So I will have to specify whichever columns I want, followed by the function name and the columns. I'll explain you what it is. So I say, I want to find out the average marks as per the recommend column. So I say df dot group by recommend, df dot group by recommend. And after that, what do you want? You want the average marks, right? So you use the mean function. And what do you want to see? Marks? No, no, no. Marks is nowhere there. Research score. Research score marks. So you got to write that. Do you get that? No. In fact, what does it say? It says that aggregate function failed. And if I cut it and put it here, you get this. So this is one way of doing it. I'll talk about it, don't worry. Or I say df dot group by recommend and aggregate average of this. Okay, you see the same output. Now pay attention what I exactly did. So I'm saying this is something which I usually use. I like to use this, but this is also one way of doing it. It's your choice. Number one, I say group by recommend. Okay, so we are grouping by the recommend. Here also the same. After that, I say I want to see the research scores average. So average marks of the students who passed is this in the research course subject and failed is this. And here I say dot AGG. AGG stands for aggregate. So which aggregate function you want to use? So I say I want to find out the research scores average. So that is what you see over here. Now, whichever you want to use, you can go ahead. The first one, according to me, is more common. However, I want you to look into the format of the output, the format of this output and this output. So this output one is in which format, or what is the data type of the output? And coming on to the format two, what is the data type of this output? If you want the data type of this output as well as a data frame, then this research score can be just put in double columns. And you'll see the same output. Now you can compare all the three. So this is the one which I usually like. This is the one which I usually like. So always have a habit of putting double square bracket. Okay, now if I copy this, if I copy this, come down and average marks of the students per recommend. Now research score also, and I also want project score. Is that allowed? Yes. So this is the average mark scored by the students in project score subject for not recommend and recommend. And this is for research score, not recommend and recommend. Those of you recommended pivot table to me, we will come to that as well. Don't worry. Pivot table as well, we'll be looking into right now. I'm not looking into it, but we'll be looking into the pivot table as well. Right. So that's one very important thing. After that, now that we understand this, you can actually change the function. You can go for sum function. You get the total marks. You can go for min function. You can go for max function. In fact, you know what? You can also directly type over here describe. So you all know that when I say df dot describe, this is what all you get. This is what all you get when I say df dot describe, which is nothing but count, mean, standard deviation, and all the quantiles from 0 percentile to 100 percentile. So for research score, if you see, I am getting count, mean, standard deviation, and all the percentiles still here. And similarly for the project score also, we are getting the same thing. That's one of the good thing. So you can do that conveniently over here. Okay. So that's one thing that you can think of doing. Then the next thing is coming to our superstore data set. That's a problem because over here, what do we want to find out is what I want to find out, I want to find the average sales by each subcategory. So subcategory is correct. Yes, sub hyphen category and sales is sales, S capital. Let's run it then. What is it saying? Aggregate function failed. How is equal to mean? D type is equal to object. These things can happen. Check the D type. I am finding out the average of sales. So whenever you want to find the average, the sales column must be either integer or float. Whenever you want to find out average, it must be either integer or float, any one of it, right? Please look into this. What is the data type of the sales column? Object, right? So I will, this is where your role comes, right? SS of subcategory is equal to SS dot subcategory and as type 2. What should I make it? Looking at this value, we can make it as float, right? Yeah, it's a point value is there. So I will make it as float. So I say float. You need not write float 64, only float is also fine. And then I'm looking into the D types. So it says value error. This line only gave an error. Now this code is fine. It says that could not convert string to float. Why? Oh yeah, not subcategory, na sales. 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 And then save it into sales only. Okay, now it should run. 1, 2, 3 run. Oops, again not running. It says could not convert string to float. What could be the issue? It is a clear example of float. Yes, that comma has made it go into coma. Because of that comma, that entire number is not recognized as a float, it is recognized as a string. Rectify this. So we understood what is the issue. In fact, if I say SS of sales and I just look at a sample of 10 values, looks everything good. Another sample, good, good. Here is where we see the issue, right? The sample is randomly picking any 10 values and this comma, right? So what I want to do, I want to get rid of this comma. Okay. So how to remove the comma? All right. Let us say, let us approach this problem as if we are completely new to Pandas and there is no one to help us. So what will you do? You will go to Google first and you will say remove comma from a number in a data frame. Remove comma from number in a data frame. And see, there is a stack overflow thing which is helping us out. So this also suggests me, but I'll go to stack overflow. And it says, use the replace function. Okay, I like it. I was anyways aware of it, but I'm trying to show you how do you use it. So it says that you use a replace function and this was the code for it. So in our case, this is sales. This is sales. So sales is data frame, not data frame, SS. So in the sales column, first of all, .str will make it a string from object and all the string functions will be available. See, I'll show you that. When I say str and I say dot, see all the string functions are available. You can see over here, all string functions are available, right? Whichever we have studied in the string chapter. And this is where I say, let me replace commas by nothing, commas by nothing. And now I say SS. No, that's done, right? Done. And then now I'm looking at samples once again, just to be double sure. Let a 4-digit number come. I don't see a comma. Everything looks good. Because everything looks good, the data type is still object. But now I think, let me try out the code to convert it to float. This works. Now the sales data type is float, and because it is float, now I can find out this. Does that work? Yes. So we had a glimpse of data cleaning as well. We had a glimpse of data cleaning as well, just because of this problem. And these all things are very, very important. In the same way, now I can find out the average sales per category also. I told you there are 3 categories. That's what I get. Now, if I want this average sales per category in the descending order, then I will apply the sort values function after this. So what will I do is this entire thing I'm going to put in a bracket and then I say sort values and sorting the values by the sales column. Ascending is equal to false. You see the difference? Sort the values by sales column, ascending is equal to false. So it came in the descending order. What if, if I say, do you understand this question? Highlighted one. I want to find out the sales by each category, subcategory. समझ रहे हैं इसका मतलब, right? For example, if most of them didn't understand. Consider where we have students from first standard, second standard, right up to 10th standard, right? And in each standard, there are 4 groups. The red group, green group, blue, and the yellow. Here also the same 4 are there. You have that houses, na? Red house, green house, blue house, and yellow house. I hope you all are aware of all these things in the school. पता है ना? You have the houses. Now, what I want to do is I want to know what is the average marks secured per standard per group. So what is the average marks of the red group in first standard? Average marks of the green house in first standard? Average marks of the students in the blue house of first standard? Average marks of the students in the yellow house of first standard? Average marks of the students in the red house of second standard? So on and so forth till the average marks of students in the yellow house of 10th standard. Now, did you all understand the question? What am I expecting over here? Now, imagine this to be your category. You have 3 categories, right? You assume this to be category and assume this to be subcategory. So, I want to know category, subcategory by sales. So, I will just put category and subcategory and you get this thing. So, this makes it more clear that, okay, inside the category furniture, these are the subcategories and these are the average sales of that. Inside the category office supplies, these are the subcategories and this is the average of that. Inside the category technology, these are the subcategories and this is the average of that, right? Did you all understand how easy it was to do? I just increase one column. So you can do further more group but if you have further sub categories inside this also. समझ गए? Are you all clear with this? Right. Is this exactly what is called as a pivot table? According to me, it's no. This is not truly a pivot table. I don't deny to you. If you recall in pivot table, you have some rows, you have some columns, and there you fill in the values, right? So based on something over here, you fill up these values. But here you have all of these things over here and the values are here. So I can, now look at this. I'll tell you, I'm copying the same code, pasting it down, and then I am applying the unstack. Now, do you think it's a pivot table? Yes, this is a pivot table. This is a pivot table. Pivot table will always have one column on the rows. It will always have another column on the columns, and the values will be dumped inside it. That's how we understand a pivot table looks like. Some of you may say that we see some odd things like NaN and NaN. See, if the category technology has a subcategory accessories and that is the sales of that. Obviously, if the category is technology, how can the category, how can if accessories is going under technology, how can accessories go under furniture and office supplies? It cannot. So it's saying not a number, not a number. That means missing values. That means missing values. If there was a value, it will come. If there was no value, it will not come. Like for example, if you see in over here, if bookcases is in furniture, bookcases cannot be anywhere in the office supplies. If machines are in technology, machines cannot be anywhere in office supplies or furniture. Therefore, for machines in office supplies, machines in furniture, it should be NaN. Let's check it out. You see, but for technology, it's there because machines were in technology. Do you understand why this is getting printed this way? So we did that using this an unstack function. Remember this unstack. Now, if you think that Darshan sir, this code was too complicated, do we have a direct thing to do this? Yes, I can do achieve the same thing, and that can be done using a pivot table function, something like this. Now pay attention, I'll show you. Output is same. Point number one, output is same. How is the code different? Please understand very carefully. What did I say? The index must be category. So that's the index. Obviously, it's a data frame. Then this is the index. That's category. Then it says the columns must be subcategory. So obviously, these are the columns, and that is subcategory. And the third thing which it says, the values must be sales. Which one? Average of sales. The values must be average of sales. So all of these are average of sales. See, whichever you find it easy, you go ahead. I usually find the group by easy, so I prefer that. But if you find the lower one of pivot table easy, you can use that. You know, in this case, according to me, the best way to represent this is this one. Not even the unstacked one, not even the pivot table. This is the best because you don't get confused, because here there are a lot of NaNs as well, right? So in such scenarios, it's not advisable to go for unstack or pivot. This is the best. Now, if I want to find the names of the students, who secured more than 60 marks in the research core subject. So obviously, I will have to select the research core subject. And in the research core subject, that's going to select that entire column of the research core subject. And what I want to know, I want to know the students who got more than 60 marks. So if I do that, if this is greater than 60, it will give true. Greater than 60, true. Greater than 60, false. True. False. True. False. True. You can just have a look at it. When I do that, this is what you get. But you know what? I'm not interested in that. I am interested in finding out where all this condition is giving true. So in the data frame, look for this condition. In the data frame, you look for this condition. So I'll copy this, comment out this. In the data frame, you look for this condition, and I get this. But what are we interested in? I clearly said what I want. I want the names. I want the names of the students. I want only the names. So this is giving a data frame. So from this data frame, I want to select the name column. So for selecting any column, I said that you write in square bracket this. So I can write it ahead of this only. I can write it ahead of this only. And this is what we get. And what is the data type right now? NumPy, data frame, series, pandas, series, right? Yes. From this series, do you all agree that these are the indexes of the series and this pink box is the values of the series? Index values. We have studied all of this, huh? Yes. I am interested in the values. I am interested in the values. So I will further say dot value. See, I'm showing you all step by step. I'll further say dot values. Now, what is the data type of the output? Could you tell me? It's a list, NumPy array, series. It is a NumPy array. It is a NumPy array. Always remember, whenever you see array written in a pandas type of work, it will be a NumPy array. That's why I proved it, right? It's a NumPy array. Okay, chalo. You understand that it will be a NumPy array. So from the NumPy array, I have to convert it to the list form. How can I convert a NumPy array to list? Using the function toList. See, NumPy array is converted to list using the function toList. Or you can also use to_list. It doesn't work. But it works in some cases. It will work in Google Collaboratory. So I'll not do that. In Google Colab, it works. Both the versions of it work. So you can do it this way. That's one way. Or you can say, so see, this is also fine. You can typecast it to a list or take this entire thing and use the toList function to do it over here. Okay, so we understand this. And now let's say I want to find out the students who secured more than 60 in the research course subject where this, right? These were the students who got more than 60 in the research course subject and more than 70 marks in the project score subject. So this is what I want. So this was the code for finding out the students who got more than 60 in the research score subject. And for the project score, I will replace it like this. And that was for more than 70. Yeah, these are the students who got more than 70 in the project score subject. But I want to look for both. I say in my data frame, I want to look for condition number 1 and condition number 2. I want to look for both. That's my first condition. That gives me true or false. That will be pasted here. That's my second condition, which gives true or false. That will be pasted here. And now you get the combined output. Then, if I want to find the names of all the students whose name starts with alphabet H, then I'm going to write a code like this. DF, that's the condition, and then df of name, which will select the name column. Dot str will convert this object to string for time being so that all the string functions available. One of the string function is starts with, I say starts with h. These are the true things. Look for that Boolean condition inside the data frame and that will give it this. And then further, if you only want to find out the names, you can write square bracket name dot values dot to list. That's okay. Now let's get started with that. We are now getting into the last part of Pandas, which is concatenating two data frames. Have a look at this. I have created a data frame one. How to create, I am not going to talk about. We know that. We created a data frame one. We created a data frame two. I say concat the data frame one and data frame two. So how is it concatenated? A, B, and C, D. So if you see, this is my, let me use conventions. So I say, this is the data frame one. And this is the data frame 2. So how did it actually happen is data frame 1 and 2, when you say concatenate, they are getting concatenated side by side. Okay, this is what we see as the default behavior. And as you can see, A and B, these all things came. And inside the C and D, these all will come. But obviously, because for A and B, you don't have the corresponding values of C and D, they are not a number, and same goes over here. Now, obviously, this is not an ideal case of concatenating, but I just wanted to show you how the concat function works. Okay. Now, one should never use concat without the access. One should never use concat without the access, and the default over here is access equal to 0. So if I actually do that, you see the same thing because the default is access equal to 0. So I can say it's the OR. Okay. And if I say access equal to 1, now you see something meaningful. What has happened is data frame 1, data frame 2. Now you can see this is your data frame 1 and exactly to the side of it is your data frame 2. And this is what access equal to 1 does, right? Truly side by side concatenation and not row wise. So depending on the use case, you can think of concatenating it. Now you'll be like, but where do we actually need concatenation? So let's consider you are Adani Electricity. So today you have a customer base of 50,000 customers in a particular location, right? So many people are using your electricity connection. This is the status as of April 2025. In May, new buildings were built up and they actually started. And another 100 customers, or let's say another 1,000 customers, have started consuming that. So Adani might be already having its customer database of these 50,000 customers, customer 1 to up to 50,000. So that could be considering the customer name, customer CA number, customer PIN code, customer units that are consumed, etc., etc., etc. Now, another 1,000 people have purchased that connection, so that 1,000 will be appended below. What are we doing? Isn't that concatenation? Yes. So these all are the practical places where concatenation is usually helpful. As simple as that. I'm talking about the merge function. PD dot merge function implements a number of types of joins. One-to-one join, many-to-one join, many-to-many join. All three types of joins are assessed via an identical call to the ed.merge interface. The type of join performed depends on the form of input data. So I'll explain you everything. Right now, let's get started with one-to-one join. I say they are similar to column-wise concatenation. So I'll explain you with the help of a simple example. It's very, very helpful because in real life, you will never have entire data into one table. For example, consider Amazon. How it might be storing its data, customer data in one table, all the orders given by customer data in another table. These are linked. Then its employee data in another table. Then its products data in another table, and its transit data in another table, and all of these are linked together. So tomorrow, if you want to figure out which customer has given which order, you may have to refer only two tables, or you may have to refer three tables at once and get from this your result. So you got to create a join of this, and that's exactly where we need this. So I am going to create a data frame, pd.data frame, and let me create a data frame of employee over here, where I say we have employee, and let's say the employees are Bob. Then another employee, let's say Jake, Lisa, and Sue. Okay, that's done. And then after that, let's say the group to which they belong: accounting, engineering, HR. Yeah, that looks good. And yeah, that looks good. In the same way, we have another data frame, which is pd.data frame. And inside that, let's say I have employee, which is Lisa, Bob, Jake, and Sue. And let's say the higher dates are 2004, 8, 12, and 14. Let me print data frame 1 and data frame 2. Right now, I say df3 is equal to pd dot merge, and I'm showing you df3. Now let's understand this code, right? So these two data frames are created. As far as the code creation is concerned, I'm least bothered. You know how to create a data frame. I'm just not interested in explaining you this, but I'm interested in explaining you this. Whenever you are trying to merge, whenever you try to merge, always remember that merging is possible if and only if there is at least a single column in the data frame which is common. Can you tell me between the yellow and the pink data frame, is there a common column? Is there a common column? Yes. And I'm sure you are talking about employee. Okay, great. Now see how it happens. Bob belongs to accounting group and Bob is hired in 2008. Bob accounting 2008. Jake belongs to engineering group. Jake is hired in 2012. Jake engineering 2012. Lisa engineering. Lisa 2004. Lisa engineering 2004. Sue belongs to HR and Sue is hired in 2014. So Sue HR 2014. So by default, it considered the common column and did the merging. There are many other use cases of it. Okay, that's easy. Then I get into the next one, which is many to one join. So I say many to one joins are the joins in which one of the two key columns contain duplicate entries. For many one, the many one yes, for the many to one case, the resulting data frame will preserve those duplicate entries as appropriate. Let's see that. How does that happen? I am creating a data frame 4 and this is going to be consisting of group. And let's say group, I'm saying accounting, engineering, HR, and supervisor, let's say Carly, Guido, Stu. Okay. And I'm just printing data frame 3, data frame 4, and merging this. Let's understand what have we done. First of all, you can see I have a data frame, employee. I have a data frame over here about the group of the employees. Do I see a common column? Employee group, hire date, group supervisor. Yes, group is a common column. Then I say Bob belongs to accounting group hired in 2008 and for accounting, his supervisor will be Carly. Okay, so that's one-to-one mapping. Jake belongs to engineering group hired in 2012 and for engineering, the supervisor is Guido. Jake engineering Guido. Again, one-to-one. Lisa belongs to engineering hired in 2004. So for her also, the supervisor will be Guido. Yes. Many people are mapped to one supervisor and hence it is called as a many to one join. Next thing you can verify by that. I'm done. Many to one comes to an end. Right? I'm sure everyone understood it. Please acknowledge. Perfect. Thank you, my 57% of the audience. Okay. So now the next one is many to many joins. Many to many joins are a bit confusing conceptually, but are nevertheless well defined. If the key column in both the left and the right array contains duplicates, then the result is a many to many merge. Then I'm saying data frame 5 is equal to, I'll say I'm gonna create a data frame, and inside that group is accounting, let's say, and once again, let's say accounting, engineering, and then I'm planning to go for HR and HR. And then I say skills, let's say math, spreadsheet, coding, Linux, spreadsheets, organization. Okay. Printing the data frame 1, data frame 5, and 3 and 5 merged. Let's understand this. So you can see employee data frame. You can see groups department, the common employee group, group skills. So common column is group. Now, how is it many to many? Let's see it out. Bob belongs to accounting group, and for accounting group, one needs to have the skill of math and spreadsheet. So one to many has already happened over here. Bob accounting 2008 math, Bob accounting 2008 spreadsheet. Jake belongs to engineering group, and for engineering, you need the coding skills and the Linux one to many. Jake engineering 2012 coding and Jake engineering 2012 Linux. Lisa also belongs to engineering, and for engineering, again, the same skills are required. So now you see many to many as well, right? Because many people like, see, Lisa and Jake both are belonging to group engineering, and for engineering, you have requirement of two skills, many to many. End of the story. Now let us talk about the confusion that one can have at times. Here we see that group and group are common. Imagine there was one more column called as the employee. So now the problem is this employee and employee would also be common, and this group and group also be common. So when you say pd.merge data frame 3 and 5, it will be grouping on what? It will group on this, or it will group on this. Confusion. So to solve such scenarios, they say that if this is the kind of thing, then in such scenarios, what you can do is you can think of using our parameter on. So I say on is equal to whichever column you want to group. So let's say if I'm saying df1 Let me come in here. Let me first check it. Let's say data frame 1 and data frame 2, right? So here when I say pd.merge data frame 1 and data frame 2, you see this. But if I want to specify the common column is employee, now assuming that there is one more column, so I can always say that on is equal to employee, right? So that on parameter specify the column on which to join. Simple. Okay, now I'm creating one more data frame. I call it as data frame 3, and that is equal to pd dot data frame name Bob, Jake, Lisa, Sue, salary 70, 80, 120, 90. Now, you know what is the problem? Tell me a common column in this scenario. Which is the common column in this scenario? So you people were able to figure it out because you are humans, correct? How will the machine figure it out? How will the machine figure it out that this employee and this name are the same? As per a machine, it's a confusion. So you have to tell the machine, because if I directly come over here and I say pd dot merge data frame 1 with data frame 3, it gave an error. So, now understand the way I see about this. See, listen to me. That's my code, right? Give me a moment. So now, saying that, you know what? Now, just like I am looking at you, let's say this is you. You are looking towards the screen. You are looking towards the screen. So we all know that this is your left hand and this is your right hand. So to the left hand, you have data frame 3. To the right hand, you have data frame. Sorry, left hand, you have data frame 1. Right hand, you have this. So what did you all just say? That here in this, you consider employee and here you consider name, right? So you got to specify it that way. So I have that parameter. Left on is employee, right on is name. And see, now it works. To the left side, df1, which is employee. To the right side in df3, consider name and then do the job. Yes, you do see one problem over here, that employee column and name column 2 times have come. But that's okay. I think that's not at all a big thing, because if they are coming for 2 times, you can always say that I want to drop the name column and you only have the column of interest. Name column, it's a column, right? For dropping a column, you need the axis parameter and it is done. Left on and the right on. Remember these parameters. Okay. Understood? Acknowledge quickly. Now we are almost at the end, and then I will keep the scope open for questions on pandas. So I say, I am creating a data frame 6 as pd.data frame, and that's going to be name as Peter, Paul, and Mary. And I'm considering food as fish, beans, bread. Name as Mary Joseph, and drink as right. So we have these two data frames created. I just want to talk about the merge function. Have a look at this. The common column is name. We know that. I didn't do anything. Peter eats fish, but because no Peter is available here, no record keep. Paul eats bin, but because no Paul is available here, no record came. Mary eats bread, Mary drinks wine. So Mary bread wine came. Joseph drinks beer, but no Joseph here. So no record comes. This earlier we never used to see this, that okay, there is only one common record and only that comes, because I had taken the records of the data frame in that way, so that you are focusing on that concept. But now I want to tell you that if it is not available, it does not come if you are doing an inner join. In fact, I can do the same thing, and here you have the parameter how is equal to inner. Same record and same output. So that how parameter can help us out. And you can create any other join like left join, right join, outer join, and the inner join. So I'll copy these things, df6 and 7. So common column is name. Peter eats fish, but no Peter available. So Peter fish, not a number. Paul drinks bean, but no Paul available. Paul builds lot a number. Mary bread, Mary wine, Mary bread, wine. Joseph beer, but Joseph not available. Joseph beer, food not available. Outer join, it will take all the records. So depending on the use case, you can take any one of the joins. I'm sure you have already studied joins at some point of time. So this is what I wanted to say over here. Now, welcome to the world of data visualization. We are going to start the very first visualization. Now, ideally, when it comes to data visualization, it will make more sense when we visualize the data for a data frame. But the basics needs to be understood in a simple way. That is what we are intending to get started right now. So just to give a heads up, I would like to now get started with visualization with Matplotlib. So Matplotlib is a multi-platform data visualization library built on the top of NumPy arrays. That Matplotlib is a multi-platform library built on the top of NumPy arrays. That's the very first important thing. So over NumPy, Matplotlib is there. One of the most important features of the Matplotlib is its ability to play well with many operating systems and graphical backends. And this cross-platform everything to everyone approach has been one of the greatest strength of Matplotlib. Okay, now this visualization library was built as an alternative for the MATLAB users. So there was earlier a software which is called as MATLAB. Right? This is how it used to look like. And it's a paid software for your kind information. It's a paid software. It can be used for all of this. And today also it's available, but it is paid. That's the logo for it. And it was very popularly used for data visualization. And this is how the software used to look like. Matplotlib was originally designed or it was written as a Python alternative to the MATLAB's plotting capabilities. And you will see much of its syntax and functionality is similar to this. However, I would say in the recent years, Matplotlib has begun to show its age. You have newer tools like Plotly, ggplot, and Seaborn have emerged that offer modern capabilities. However, or I would say, making Matplotlib feel clunky and old-fashioned Still, I am of the opinion that Matplotlib, opinion that we cannot ignore Matplotlib's strength as a well-tested cross-platform graphics engine. Okay, let's go ahead. So now let us get started with the library. Now, first and foremost thing, let's import the libraries we need. So import Matplotlib, right? So PyPlot. PyPlot is the library for creating static, animated, and the interactive visualization in Matplotlib, and you will need only that. I mean, since last 15 years, I have been consistently working on this PyPlot only. So that should be more than sufficient. Now, the next is plt.style.use, and you can use any style. So what all styles are available? Well, if you want to actually find out, I want to print all the available styles, then you have plt.style.available. So these all are the styles which are available. So styles are nothing but the themes, right? So any visual can be plot. I'll show you. So this set of visuals, if you use the style instead of BMH as classic, will look like this. In dark background will look like this, and so on and so forth. Similarly, this will look like this, like this. So these all are the available styles. But you can see how each of these visuals are looking like. Now, which one can I use? Well, let me use this time. Seaborn, colorblind. You can choose any one of it. It's your choice. Right? You can use any one of the style. It is your choice. By default, it is classic. So I was saying by default, it is classic. And there we go ahead. So now I set the style as this. And now I will kind of recall NumPy. So there is a function of NumPy which is called as linspace. So if I say 0, 1, 5. So what it does is it returns 5 uniformly spaced numbers in the range 0 to 1. So if you now try to find out 0.25 minus 0, 0.25, 0.5 minus 0.25, 0.25, this minus this 0.25, 1 minus 0.75, 0.25. Everywhere it is 0.25 only. If I say 0, 1 into 10 equal parts, you can find out the difference, right? This minus this 0.111. This minus this is also 0.111. Same thing. Or if I say 0 to 7 in 10 equal parts. See, this minus this is 0.77. This minus this is 0.77. This minus this is also 0.77. So what am I doing is I am saying 0 to 10 into 100 equal parts. 0 to 10 into 100 equal parts. So I have 100 values. I'm sure all of you understood this. 0 to 10 divided into 100 equal parts. I don't want to print it. This is just for your reference. And the y will be the sign of each of these values. Sign. So what is sign of 0? That would be y. Sign of this, and so on and so forth. So these are the sign of the 100 values. I'm going to comment on this also, but you understood what is x and y. Can I assume that all of you have understood what is x and y? Yes. Now I say, let's get to the plotting. So I am talking about the plot function. So plot function says I need plt.plot x value, y value, color, marker, line style, label. So x value, y value, color of the line, example can be given like this. Marker of the line, line style of the line, label of the line. Let us check it out. I say plt.plot x and y. So I'm saying that x consists of the 100 values, y consists of the sign of those 100 values. So it's very simple. We have to plot these. I got this. You see over here, I got this. I just gave these two parameters. And one can understand this really well. Then after that, I don't like this. What is this? This is basically saying that this figure is saved at this address. I don't want it. So I prefer to put a semicolon. Semicolon will suppress that. See, that has not come. But if I don't put semicolon, it comes. You see, this comes. And here it doesn't come. Another way is you can avoid that semicolon is by saying plt.show function, which is mainly used to display the plot. Plt.show is used to display the plot. See, that also hides it. So plt.show is a very common way of going ahead whenever you have to display the visuals. Okay. Now the size of the figure is very big. So I say this has a function which is called as a figure function, which has a parameter which is called as a fixed size. If you make it 1, 1, that means it will keep the size of the figure as 1, 1. Becomes 1 inch cross 1 inch. Can I make it 3, 1? You can. Can I make it 1, 3? You can. Can I make it 3, 3? We can. And I think 3, 3. Okay. Can I make it 4, 3? We can. I think 4, 3 is looking good. Or maybe if I say 4, 2. Yeah, 3, 2 is looking good. I think I need not, in my notebook, 3, 2 looks like a good size. So I'll stick to this. You can play around with these numbers. I'll get in your correct values also. Okay. Now, plt.figure. By default, it gave the blue color. By default, it gave the blue color. You can also set in the color over here. So I set color as red. And red color. So color which I can give is red, green, blue, black, white, or I can also give color in short forms. Anything is possible. So this is red. If I give the color in short form, K is black. K is black. W is white. R, green, blue, black, white. There are many colors available. Okay. Then you have the line style. So line style can be dash. So I'll tell you what all are this. Dash means a solid line. Dash dash means a dashed line. This means a dotted line, and this means a dash dot line. You see, it has become a dashed line. If I say colon, it becomes a dotted line. Okay, so that becomes the thing. Label will use it later. We'll use marker in this case. Well, marker will also be interesting. Marker. Marker is equal to O. That means dots. Marker size is 5. Marker size is 2. 0.5. 0.05. So let's remove the line style. And now you see the marker style over here. Right? So marker size, if I keep it as 0.5, you see the dots over here. If I keep it as 4.5, you can see the dots over here. If I make it 2.5, you can see the dots over here. And if I set the marker as D, that would be diamond. Observe carefully, there is a diamond. And this can be easily understood when you plot a scatter plot. See this. When I go for plt.scatter, same code, size of the marker, if I keep it as, you can see this. If I'm keeping the marker as D, that's a diamond. If I keep the marker as plus, it would be plus everywhere. So what all markers can you put? So these all are the various types of markers. Or you can also refer this. Or we can also refer there was one very good image. I was just looking for that. Yeah, this can also be considered. You can use the marker style of your choice. That's upon you. So you can plot it. I'm not talking about scatter plot and all. We'll be looking into all of these things later on, but this is what we see. Now let us say, I simply say plt.plot x comma y, and then I say plt.show. Correct. Now, here in this case, just like x and y, I can always say x versus numpy dot cos of x. So sine and cos both. So when sine and cos both are getting plotted, you see these colors are automatically being chosen, but I'm not able to understand which is sine, which is cos. So what I can do is I can put in over here the line style as this. And here I can put the line style as this. So I know that a solid line is a sine wave and a dashed line is a cos wave. Or I can also think of using the label parameter that this will be labeled as a sin x and this will be labeled as a cos x. Does it come? No. If you have to display it, you'll have to use the legend function. You have to display it, then you will have to use the legend function to display the legend. Legend function is used to display the legend. Okay. Now, if I use the same code and inside this legend, you also have the parameter location of the legend, which I can set it as any one of this. So if I say location has to be upper right, it will get shifted to the upper right and you can give any one of these values. I would recommend you to always put the location value as best. It will automatically choose whatever is the best place for itself. Automatically choose the best place. So it will not be overwritten anywhere. Now, what am I doing is, see here at the top, I'm going to save it as Darshan. So Darshan is equal to plt.figure. So this figure, which you see right now on the screen is saved or not saved is saved into the object called as Darshan. See, I printed Darshan. You see that. Now, if I want to save the figure, then I have to say darshan.png and you can just give in these parameters or you can skip it as well. So let's say you can directly say print figure saved as darshan.png. Is it saved? I can check it in my local environment, darshan.png. Yes. And if you want to save it as a particular DPI value or something, this is Darshan one, DPI 300. This is the regular one. This is the one. This is what all you have. Now, what all formats in which you can save it, right? So that can be looked into Darshan dot canvas dot get supported file types. So you can save your figure in any one of this format. I did choose the PNG, which is most popular. Don't ask me about all of the others. I don't use anything other than PNG, but EPS, these all things are understood. This is also understood. RAW is okay. SVG is okay. TIFF and WP. Rest all of the formats, even I don't know. And I don't need it as well. Okay. Now, the next thing that we are looking into is when I say, listen to this, sir, this is important. This is Let's say this is your figure. You want to divide it into two parts, two equal parts. Then I can say this is two rows and one columns, inside which I call this as panel 1 and this as panel 2. So this is the first one where I want a sine wave to be plotted. This is the second one where I want a cos wave to be plotted. That's my panel 1. That's my panel 2. How do I do it? It's very simple. You have to use the subplot function. So plt.figure, creating a new figure. Plt dot subplot two rows, one column, and currently I'm talking about panel 1. I want to plot x and y. Similarly, I say plt dot subplot two rows, one column, panel 2. Have a look at it. Two row, one column, panel 1, panel 2. Or when you have two rows, two columns, this is panel 1, panel 2, panel 3, and panel 4. Left to right, top to bottom. So I say plt dot figure plt dot subplot 2 comma 2 comma 1 in this first panel x and y. In the 2 comma 2 comma panel 2 cos of x. In 2 comma 2 comma panel 3, I am saying tan of x. And I forgot about panel 4. I didn't write anything about this. It will be empty. Or if I forgot about panel 3, this will be empty. Have a look at the code. And then we have this Control S. Now this is Matplotlib style of doing it. You can also say over here that, let's say, I can also think of it. Listen to this very carefully. I can also think of this, that this entire thing is my figure and I am having access. I am having access. This is row 0, row 1, column 0, column 1. So this is 0 comma 0, this is 0 comma 1, this is 1 comma 0, this is 1 comma 1. So say, how do you do it? This is a different style of doing it. The function which we used over here is subplot. I am doing the same thing, but different. So what am I doing is figure comma axis is equal to plt dot subplots. Is there a difference in the function earlier and now? Do you see a difference in the function? What is the difference is there? What is the difference? Same, na? There is no difference. Difference is there or not there? In the earlier function and new function. The earlier function is there in the chat box. And the new function is there here on the screen. Yes. Extra S subplots. That's correct. So this is subplots. Don't forget that this is the subplots. Figure is the name of the figure, and this pink, all things which are written is those things. So I say over here, figure is the object, AX is the axis of the object, AX 0, 0, 0, 1, 1, 0, 1, 1 are this. Now I say over here, AX 0, 0 will be sine, 0, 1 would be cos, 1, 0 would be tan, and 1, 1 is tan hyperbolic, and you plot it. This is another style of doing it. Whichever is convenient to you, you can use it. This is the object-oriented style. That was the Matlab style. Whichever is convenient to you, you can use it. Now, I think anything else other than this? Yes, I want to also talk about few last simple things which are left out. If I say plt.plot x and y, right, and right in this, there is no label on the x-axis, no label on the y-axis. I can say plt dot title sine wave, plt dot x label x-axis, not x-axis. I would say x only, and plt dot y label sine of x. So you see, I have a title x and y, and I can also say over here font size is 20 to make it more bigger. And that is what you have in over here. Perfect. So X label, Y label also done. Then after that, we are good to get started with the, I think this is done. Yeah, then we are good to get started with the data set on which you can do all of these functions. Yes. Now we get into the actual use of the charts. Which chart to use when? So I was saying which chart to use in which scenario. This is what we are going to look into right now. So we say histogram. What is a histogram? Histogram is nothing but a frequency chart. So if you look into this, where is my histogram? Yeah, here. Now, what do you understand when you look at this histogram, right? Why do I call it as a frequency plot? Is because we see that this is the tallest. What do we understand? if you look into this number, which is the height of trees, so we understand there are 50, or I can say most of the trees in the data set are in the height range 250 to 300. So that is one of the insight that we understand. Most of the trees will be like this, right? So that's a histogram. Now, if you look into this, the next one is the pie chart. We all know that pie chart is mainly used when there are categories, but I would say as far as pie chart is concerned, one should always avoid it. We are going to plot all. But the problem with pie chart is if I ask you, this is big or this is big, tell me. It is so similar, it's very difficult. Some of you may say they are equal. Some of you may say that this is little bigger than this, but we don't exactly are sure about it. And that is the problem with the pie chart. I call pie charts as evil, because you cannot really use it nicely for prediction. On the other hand, if it was a bar chart, then even if they are very, very similar, one would have been here and one would have been here. You would have clearly said, you only tell me with respect to this and this, which is taller. Tell me which is taller, one is taller or two is taller, right? But this pie chart will confuse you, correct? Because human eyes are not good at ascribing angles. So pie chart would confuse you. Agreed? Whereas bar charts would never. Am I correct? Yes, pie charts will always confuse you. And also, when you have too many categories, avoid going for a pie chart. Or you have to label it like this is the 6 and 7% very close. If these labels are not there, you are gone. And when there are too many categories, it is always advisable not to go for a chart like this. That's utter stupidity. One should go always for a bar chart. Never a confusion to compare these two. Okay. So when to use it, when not to use it, it's all written. Donut chart. It's nothing but alternative to the pie chart. Box plot. Box plot is mainly used for understanding this. So what is it there in the box plot? This is the 25 percentile, this is the median 50 percentile, this is the 75 percentile, this is the 100 percentile, this is the 0 percentile. So the 5-point summary is there in the box plot. So it is mainly used in identifying outlier, anything which is going below the actual, right? So when you have small data sets, don't use it. When you have complex comparisons, don't use it. Word cloud. What is a word cloud? Well, if I take you to this restaurant and this is the menu card of the restaurant, what would you order? If I take you to the restaurant and this is the menu card of the restaurant, which is the item you are most likely to order when you get a menu card like this? What is the restaurant owner trying to say? Yes, he is trying to say that bigger the text, more popular is the item in my restaurant. So in my restaurant, coffee is popular, romantic dinner is popular, drink is popular. Whereas what is not popular is luxury. What is not popular is grinder. So this is what we understand, right? So this is the word cloud. Whenever you have text data, word cloud is helpful. Now, I didn't get a very good image, but you understand what I mean by this. Like here, right? You clearly understand the most famous item over here in this restaurant or hotel or shop is which one? Chocolate. Yes, chocolate. Chocolate. And if I ask you which is the least popular, which is the least popular? Rice. Yeah, rice is least popular, very small. So that's a word cloud. So use it when you're emphasizing the word frequency and the prominence in the text data. And don't use it when you have complex data analysis or precise comparisons. Bar chart, we already discussed. When you have too many categories, avoid using it. Column charts are nothing but bar charts only, similar. But for longer category labels, they are good, like this longer label. If there are many categories or complex comparisons, don't use it. Example also I have given customer satisfaction by department. Line chart. When will you use a line chart? You will always use a line chart when on the x-axis you have either time or date, like how time-wise the temperature has changed, or how per date the stock market is going up and down. These all are the cases where you will end up using a line chart. Temperature changes, website traffic, etc. Scatter plot is the case where, let's say, on the x-axis you have temperature and y-axis you have the sales of ice cream. So we see that as the temperature increases, the sales of ice cream increases. So in such scenarios, you are advisable to go for a scatter plot. When you have a continuous variable plotted against another continuous variable, it's a line chart. Don't use it when you want to show the trends over the time. Here, line chart will be used, not a scatter plot. So in this case, you'll use a scatter plot, and here, not continuous versus continuous will be a scatter plot, not a line chart. Sorry, scatter plot. Stacked column chart, when the column chart has to be further broken down into subcategories, you go for stacked column chart. When to use it, when not to use it, you got to study it. Area chart, we won't be using it. That's for Tableau and Power BI as well. Bubble chart, we won't be studying it. Heat map. Heat map is used for showing the correlation. For example, if you look into this, as you can see, I have temperature versus sales of the ice cream. And when plotted, we clearly see there happens to be a good amount of correlation, because we see as the temperature is increasing, the sales of the ice cream is also increasing. They say the correlation is found out to be this. But what are the values of correlation? Well, the values of the correlation can be something like this. If you see a line like this, straight line passing all 1. Straight line but moving downwards, -1. Straight line but not covering all but others are very close, high positive correlation, something like 0.9. This is the case of high negative, -0.9. There can be 0.95, 96, 97 also. These are intermediate examples. Low negative correlation, low positive correlation, and as good as no correlation is 0. So when this correlation is plotted, you get a heat map in return. Right. So that is useful for representing data as a color intensity in a grid. So when you have too many categories, looking at each and every correlation value, this can be 0.1, this can be 0.9, this can be 0.3. Looking at so many numbers is going to be difficult. So you look at it in the form of a color. So here, if you look into this, see, when you have so many values, let's say in a heat map, where all will you look? You'll go crazy, you'll go mad. But it's very easy for me to identify that these all things are the same because they are of a lighter color. or these all things are of the same because they are of the darker color. So if I'm interested in finding out the high correlation or low correlation, this color can help us to find out rather than looking into so many numbers. That is where a heat map helps. So you cannot look into a map like this, right? There are too many values and that's too much of confusion. Or look at this. So colors help us to understand that, okay, these two are similar. Tree map we will never be plotting in our coding. In Tableau Power BI, we may need it, but not here. Then dual axis chart, we will not be plotting in Tableau Power BI. It is helpful. You have something on x-axis, something on y-axis, and something one more on y-axis. So this is the primary y-axis. This is the secondary y-axis. X versus y is the graph. X versus y dash is the line. But you don't need it. It can be done conveniently in Tableau and all. Here it's not required. 3D charts, I would say always avoid 3D charts. There is, in data storytelling, we clearly understand, but you should always avoid 3D charts. I'm asking you, whose supplier share is big? A, B, C, or D? Whose share is the largest? Whose share is the largest? This pie chart is 3D, na? A or B? It's A. And you know why it is? Because the way this pie chart is tilted, it appears that this one is bigger and that one is smaller. And hence you should avoid 3D charts. See, now over here, January is bigger or February is bigger, or both are same. First of all, do you notice over here, this chart is a 2D chart. Forcefully, we have given the third dimension. इसकी जरूरत ही नहीं थी. It was not required. And therefore, I always say, never use 3-dimensional. See, if it is really not required, don't use it. As simple as that. So, in worst cases, if you think that can be helpful, you use it, else you don't use it. This is where your dual axis charts can be helpful. Let's say you are having a subcategory, and subcategory wise, if I'm looking for sales, and let's say I'm also looking at profit. So you can clearly see it has two different charts. Subcategory wise sales is here, subcategory wise profit is here. You can convert it to a dual axis chart. Now, obviously this one is for the profit. So I'll take into the sales and get it converted to a bar chart. And the profit, I'll get it converted to a line chart. And this is what you see. This is called as a dual axis chart. Now, I don't like dual axis chart because you are comparing wrong thing with the wrong thing. You know why? See, this is 0 to 50,000, no? And this is 0 to 50,000. You are just comparing wrong things, right? The margins are not synchronized. And when you synchronize it, now you get the true picture. See, this is 0 to 50. This is 0 to 50. So you have to use it wisely. That's what I wanted to make you understand. So today we are going to do the data visualization using the Matplotlib and Seaborn library. So first and foremost thing, we'll be importing NumPy, Pandas, Matplotlib, Seaborn. Now, let me print all the available data sets in the Seaborn. All the available data sets in the Seaborn. So this Seaborn library is preloaded with these all data sets. And that is done using the uh, get dataset function, right? So SNS dot get dataset names, get datasets name. And these all are the datasets which are already available inside the Seaborn library, free, already available. And one of the dataset which we are going to use is the tips dataset. We'll be using the tips dataset. So now, do you need a pd.read CSV for reading this data? No. pd.data frame for reading this data? No. You have a very standard function for reading this data. So we'll be using that particular thing. So I'm going to call this data set as tips, and it is loaded like this, right? So I say there is a very standard data set called as hub, and the process of loading the dataset is very simple. SNS dot load dataset, and I'm saving it as tips. And let me print the first 5 rows of the dataset by saying tips dot head. Now, what is this dataset mainly about? So if you look in carefully, this is the dataset about a restaurant. So if you look in carefully, in this restaurant, the customer who came, right, his total bill was around $16.99. The tip which he gave was $1. She was a female, non-smoker, visiting on Sunday, dinner time, and the size is 2. And the size is 2. Then, second customer, male, Sunday, dinner time, and etc. Then, let me print the number of rows and columns in the data set, which is the shape. So I say print the shape. So we understand there are 244 rows and 7 columns, right? So this is what we understand. Now, let's further understand this data set. So if I say I want to print the summary of all the numeric columns in the data set, I will say tips.describe. So I understand the average total bill in this restaurant is $19 and the median is $15, $17. Little skewness. Average tip is $2.99 and the median is 2.9. Most of the passenger when come to the restaurant usually come in the size 2 to 3 because you see 2.5. Minimum is 1, maximum is 6, median is 2. Then I print the summary of all the categorical columns in the data set. So I say df dot describe or tips dot describe include is equal to object, and it does not work. So what you can do over here is include is equal to, let's write all. So everything will come. Now, if you look in over here, we understand there are 2 unique values in the male, mostly sex, mostly male, female. Smoker has also 2 unique values, maybe yes and no. The day has only 4 unique values. So the restaurant seems to be open on only 4 days. Time has 2 unique values. One is dinner. I think next should be lunch. Okay. Now let's understand it. So I'll take all the categorical columns. And yeah, this is what I have. For column and categorical columns, I have the unique values in each and every column quickly printed. That's what I see. Okay. Then now you can see what all are the unique values. As discussed, the restaurant, right? The restaurant seems to be open only on Thursday, Friday, Saturday, Sunday, right? So that's what we see. Then I want to print tips of column dot value counts. And normalize into 100. So we understand majority of the customers coming to this restaurant are male as compared to female, 64%. Smoker wise, most of them are non-smokers. This is what we see. Then 61% are non-smokers. Majority of the customers come on Saturday, followed by Sunday, followed by Thursday, and Friday is the least. Quite surprising. And we don't have the data, or the restaurant is not open on Monday, Tuesday, Wednesday. This is another thing that we understand. Percentage wise also, you see almost 70% of them come on weekends. The restaurant, majority of them come for dinner, 70%. Most of them come in a group of two couples, or maybe friends. And very few come in group of 1 or 6. Okay. So we get an idea about our data set. So we get an idea about our data set. So let's get started. With data visualization using Matplotlib. So the first one is bar plot. And I will start with the use case of a bar plot. Bar plots are ideal for comparing quantities across categories, and they are very common in exploratory data analysis. They are very common in exploratory data analysis. Okay. Let's look at the syntax. Now, there are many common parameters over here than what I am discussing, but we will keep our focus to the important ones. You have height, width, you have the color parameter. Okay. So now, what am I doing is, first and foremost thing, I want to find the total bill total bill sum by day. So I say bill by day is equal to, I'll be grouping by day and finding out the total bill. And let me print the bill by day. Now, never coming. Let me stop this. The default of observation equal to false is deprecated and will be changed to true in the future. Observe equal to false to retain the current behavior. Third equal to true. Ah, anyways, we can do one thing. I can suppress that warning. And the way I can suppress this warning is import warnings, warnings dot filter warnings, ignore. So this is to ignore the warnings which are generated by the code. Let me run all. And you can see no warnings are there. Okay, fine. So here I'm printing this. Now, see in this bill, if you see, okay, no, not. If I say dot index, it should give me Thursday, Friday, Saturday, Sunday. And if I say dot values, it should give me these values. So if I say dot index, it should return me this. And if I say by values, it should return me this one. And so on, right? And yes, you can see it is being written. Now I am actually commenting out these three lines because I don't need it. I'm getting into my bar plot. So how do I create a bar plot? I say plt dot figure. Let's say fixed size. I'm setting it as 6,4. plt dot bar, the index versus the values. And I just say plt dot title, total bill, plt dot x label is the day of the week, plt dot y is the total bill amount, and plt dot show. Right? So this is what essentially is the main code. Bar plot of this versus this. And you get a nice thing over here. You can see you're getting a nice visual over here. And that's how you are getting a bar plot. And the code is very, very simple. Let us copy this once again. And I am setting color is equal to orange and width is equal to 0.5. So you can see the width of the bar is adjusted. You can play around with this value that I leave to you, but that's completely up to you. What is the insight? Most of the total bills are on Saturday and Sunday. That's an insight. Now we have this, right? Now another thing, which I want to show you is print bill by day, right? So that's the index and that's the values, right? So what I want to do, if you want to add the grid lines, you can just say plt.grid, grid lines will come. And if I say axis is equal to y, then it will only come on the horizontal y-axis. If I say line style is equal to dashed, you will see dash, 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 dash. And obviously they are actually looking like intersecting the plot. So I will make those lines lighter. And for that you have the alpha parameter. So if I give alpha as 1, it's dark. If I give alpha as 0.5, it's light. If I give alpha as 0.3, it's further light. So you can play around these values. Now, I also want to add data labels. So you see, I have added that. And all of them are perfect. See now, listen to this. What has happened? You know, I am saying for I comma v in bill dot values. Let us first try to understand this. Have a look at this. For I comma v in enumerate of bill by values, right? So basically we are iterating through this. It will be considering this at index 1, this as index 2, and so on, right? Because bill by values is going to give you only the values. If you want, I can show you. Right? It is like a NumPy array. So this is at index 0, this is at 1, this is at 2, this is at 3. So I say for I comma v in enumerate. So enumerate means I will be 0, value would be this. I will be 1, value would be this. I will be 2, value would be this. I would be 3, value would be this. So I am having all the values of I and I am having all the values of v. You see this. So what I want to do, see when I'm looking, I is going to go from 0, 1, 2, 3, and V's are going to go from 1096 to 1627. So I say for I comma V in this plt dot text at I comma V. I is over here and value is at 1096 on the y-axis. Exactly here where my pointer is with the horizontal alignment as center. If I don't write that, you see it's getting plotted from here. So obviously from here, it starts printing this value, whatever is the value over here. So over here, plt dot text syntax is like this. So obviously you have horizontal alignment as well, right? So I comma v are this I and v where it is. And from here I start writing. And then of course I'll be also having vertical alignment is this. And okay, some more suggested. So we can actually look into this. Font size and all, we can play around with this. Horizontal alignment, font size, color. And alpha also we can set in, but okay, let's not there. So I'm not doing it. So see over here, you can plot it, but you know, I don't like plotting the text and all that. It's just a waste of time. See, I don't know how much of you will, how many of you will agree completely with me, but in my opinion, you know, as a data scientist, when I do my projects, I don't believe in plotting these visuals unless and until I feel there is a hardcore need. Because according to me, looking at this also, I understand everything. I don't think there is a need for plotting a visual. Don't you think so? It's waste of time to plot the visual. Only this much is more than sufficient to understand, right? It's a very important thing that you should note, right? Yes. So we visualize for whom then? See, this is another important thing that everyone must make a note of it. When you are using a software like Tableau for data visualization. So yes, when a software like Tableau is being used for data visualization, where you are actually connecting to some data set, and then you come over here and let's say you are looking at the category wise sales or category subcategory wise sales. Now, in this case, or let's say if you're looking at just subcategory wise sales, or you're changing it to a pie chart or a horizontal bar chart or a tree map, right? Or even you change it to a bubble chart. So when you are doing all of this in Tableau, you are creating this visuals for whom? You are creating it for the management and the stakeholders so that they understand the insights from the data. But when you are doing the same thing in the Jupyter notebook, this is not for sending or sharing with the managers. This is only for you. This is only for you. Max to max, let's say your manager says that, okay, fine, you can show me the insights in your notebook, then you can create it. So usually what happens in data science, you remember I explained you the CRISP DM pipeline, cross industry standard for data mining. See, this is a very simple and important observation for all of you. So whenever you look at a data, uh, not data analysis, the machine learning project or a deep learning project, it has to go through the following stages, starting from business understanding, understanding of the data, looking over here, what is the data about? Are there any cleaning necessary? So that exploratory data analysis, visualization, all come over here. But why are we doing all of these things? So that we can create machine learning models. After that, we can evaluate which machine learning model is good, and then we can productionize it. For that, we are doing it. There are no other reasons for us in doing it. So the same thing applies over here. You know, if no one is going to look at the charts that you have created, and your end goal is to create a model, and if you are comfortable to go ahead without doing data visualization, for some visuals, maybe visualization is helpful. So understand over here, this visualization is not something where you have to be really awesome about. In real time, it is important, but you need to understand in which situation will you create it and in which situation you can conveniently ignore it. So based on your use case, you take a decision. Like for such things, it does not make sense even 1% to plot the visualization. And after that, taking more efforts in plotting the text on it is even high level of stupidity. I'm being very practical over here. Plotting makes it look good and all, but you're wasting your time. You're wasting your precious time. That's what one thing I want to tell you. So that's one thing that we understand. And the next visual that we get into is a histogram. So the use case of histogram is histograms are used to visualize the distribution of a single numerical variable, and it is essential for understanding the frequency distribution of the data, the skewness of the data, or the modality of the data. So let me look into the common syntax. plt.hist bins, which is by default 10. So I'm just writing color can be whatever color name you want to give. Alpha, you can give that, you can give the edge color as well, right? So how do you create it? So histogram, it's a univariate plot. It's not a bivariate plot. It's a univariate plot. Univariate means it can be plotted using only one variable. Just like here, you need something on the X and something on the Y. So I call this as a bivariate plot. Bivariate means you need two things. X and Y, X-axis and Y-axis, bivariate, bivariables, two variables. And histogram is univariate. So let us quickly go ahead and plot a histogram. So I'm planning to go for this. So plt.figure 6 comma this, and we'll be seeing tips of total bill and bins 20, color orange, alpha is the transparency, edge color I am setting as black, title will be distribution of the total bill, X label, Y label, grid, you know that, and this. So maybe alpha, I'll keep it as 0.9. Have a look at the code and the output. If I, I'll, if I do not give the bins, if I do not give the bins, by default, Matplotlib will have 10 bins. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now looking at this, do you realize, I mean, the tallest one is this, second tallest one is this. To understand the distribution better, I increase the number of bins. You have to play around with it. And do you realize now most of the customers who visit this restaurant are having their total bill between $10 to $20? Convinced? Most of them are having their total bill in between $10 to $20. Sahi hai ki nahi? Right? Yes. And very few customers have their total bill in the range. What? 0 to $5 and $40 to $50. Yes. More significantly here, $40 to $50. So insight is the distribution is right skewed. Right skewed means the tail is longer on the right side, and most of the total bills are between 10 to 10 to $20, and very few are between $40 to $50. So do you think this information that most of the total bill is between $10 to $20 useful for anyone? Is it useful for the restaurant owner to know that most of the customers visiting his restaurant are having this total bill? Yes, for the management. Yes, right? So they can think of increasing this average total bill amount down the line if they wish to. If they wish to, they can certainly work around it. Okay. So we understand the most common spending behavior of the customer. The next thing which I want to go for is, yes, combos and discounts. Yes, that's also a good one. Scatter plot. Scatter plot is mainly used for having two continuous variables plotted. For example, the the percentage that a particular student has scored versus the number of tears falling from his or her eyes. So obviously, the greater the percentage he or she scores, the lesser are the tears coming from the eyes. And the lesser the percentage he or she scores, the more are the number of tears coming from the eyes. So you will have both the things to be numeric. You will have both the things to be numeric or continuous. One example could be temperature versus the sales of ice cream. So as the temperature increases, sales of the ice cream also increases. So I say scatter plots are used to visualize the relationship between the two variables, and they are useful for the correlation and trends and regression analysis. How? Let's look into the common syntax. plt.scatter, color name. So you can give the color name of your choice. So let's say you are giving the color as purple. You give the alpha. Size, marker. Now, S is the size of the marker. Marker means a scatter plot which is going to plot dot, 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 right? So, size of the marker, shape of the marker, transparency of the marker. And let's go ahead to look at the relationship between total bill versus tip. Uh, do you think as the total bill increases, the tip given by the customer increases? I'm not talking about you personally, but in most of the case scenarios, do you agree that as the total bill increases, the tip given by the customer increases? So if I eat for 500 rupees, I'm giving a tip of 10. If I'm eating for 20,000 rupees, I give a tip of 100. Something like that. Does it happen in most of the scenarios? So total bill versus this. plt.figure is this. Then I say total bill versus the tip. Color, I am keeping it as orange. Transparency, I will keep it as 0.8. Then I keep the size, I'm not playing, nothing I'm playing right now. And title, X label, Y label. Grid, I like to show. Not required actually. Grid, I can say and show. So you see over here, we can see that. So you can see as the total bill amount increases, the tip given by the customer increases. Now, see, you cannot understand this relationship without plotting. In this case, plots are important. Can we identify this or can we assume this? No. In such case, plotting is important. But in that bar plot wala scenario, plotting was not important. Understand this scenario as well, right? Where you do, where you do not do it. Okay. This is what we understand now. Inside. As the total bill increases, tip given also increases. This indicates a positive correlation between total bill and the tip amount. Here as well, You have the size and the marker option. Size is 100. Size is 200. Maybe size is 30 is good. Marker is O. I'm giving marker as X. Oh, that's good. Marker as D. D means diamond. Marker as plus. Okay. Marker as F. Error. So you cannot give anything. So what all can you actually give it? I give marker as small o. Capital O doesn't work. And these are all the marker values that you can give. If you want, you can visit this. This is where these all things are available. None for nothing. Capital P for plus. Capital H for hexagon 2. You can see hexagon. I don't know where it came, but it is there on the documentation. And small h for hexagon. So it's so small that it's not seen, but if you look carefully, it's a hexagon. Dekh lo achhe se, it's a hexagon. So you can play around with it. The most common is O only. So yes, this is what we understand, and this also helps us understand good amount of things. The next is we go for a pie chart. Pie chart is again univariate because you don't need anything. So pie charts, they represent parts of a whole. They are used for category, proportion, visualizations. Let me tell you, they are less used in data science due to the limitations in accurately representing the data. What? Really? Why? What is the problem? Well, I'll show you what is the problem. Tell me, looking at this visual, Canada versus other versus Australia. Which is the second smallest? Ah, but there can be confusion, right? There can be confusion because as we know, human eyes are bad at what? What did I say? Human eyes are bad at technically. Yes. Ascribing angles. Correct. Human eyes are bad at ascribing angles. So they are less used. But let's look into the syntax. plt.py and then values, labels, colors, auto PCD, start angle, and explode. Explode. What's going to explode? I'll show you. So that becomes really very, very interesting for anyone. So the first thing that I'm interested in calculating the percentage of smokers and non-smokers. So I say smoker count is equal to tips of smoker dot value counts, and I'm gonna print it. Okay. Now you know what I want? I want this to be plotted on a scatter plot. I want this to be plotted on the scatter plot. Now scatter plot will be automatically converting this to percentage, in the sense, in the sense, if I print this, scatter plot will be automatically converting it into 61 and 38 automatically. So I am not going to use this. I am not going to use this. I'll be using this only, which is this. I'll be using this only, and it will automatically convert it into 61% and 31%. How? Let's try to understand. So I say plt.figure. Then I say plt.py, and I'm just passing the smoker counts, which is this, smoker counts, and labels. Let's say I'm not giving anything, and I just say plt.title and show. You can see over here, it has automatically converted. What were the values? The values were 151 and 93. Percentages also we know. Now let's make it a little better. So I say smoker counts, and I'll also put labels is equal to smoker count dot index. So you see no and yes are also being added. Just give me a second. So we got no and yes. If you want to plot some values on it, first of all, it's not recommended, but let's say if you also wish to plot some values, then you have color is equal to, because there are two colors, I can supply two colors. And you can see I supplied orange and blue. So it will automatically, to whom it will give orange and to whom it will give blue. Well, how it is found in the smoker counts in the same order. Smoker count is about no and yes. So no will be orange and yes will be blue. So always remember that it will follow the same style. Then auto PCT. What is this auto PCT? Well, let's give auto PCT as 1.4F. So in this auto PCT, nothing will change except this 4. The value after this dot, only that will change. So because I said 4, there are 4 digits after dot, which is not looking good ideally, but I just wanted to show you. If I said 2, there are 2 digits after the dot. If I say 1, there will be 1 digit after the dot. Right? So that's your auto PCT. Start angle. Start angle 0, right? So this is 0 degree. Am I correct? So from here, that no is plotted. From here, the no is plotted. And then remaining thing is for yes. If I say start angle must be 90 degree, it started from here. From here, the no is plotted and then it plotted yes. If I say start angle is equal to 45 degree, it starts from here. You can play around with this inside, right? Most of the customers are non-smoker who visit this restaurant. It is spelling error. Okay. Then Only over here I am going slowly. When I start with Cbon, I will increase my speed because the code is more or less going to remain the same. And you also understand the visuals, right? So at that time, I'm not going to go slowly over it. So going ahead. Now the next one, horizontal bar plot. So horizontal bar plot are used when the category names are long or when you want to emphasize relative lengths horizontally. So the function is bar h. That's it. The function is bar h. Because it is suggesting, I'm quickly taking it. Why to lose it? So I am finding out the average tip by day. So I am finding out the average tip by day. So average tip by day is grouping by this. All good. Okay. Now you know what is in dot index and what is dot values. Am I correct? I need not explain you by printing again, right? Yes. Good. So because you know that, I will get into the figure and I'll directly look into this. Let's say I am not explaining you anything. Can I still assume you understand this visual if I don't explain you anything? The insight is same, right? What we got for the vertical bar plot, but horizontal bar plots are useful when these names are really very, very long. So let's say the name of the variable is total sales of the week, average sales of the week, mean sales of the week. So such long names are there. In such cases, horizontal bar plot is recommended. Else you can go ahead with the vertical as well. So yes, I think that's good. Insight. The average tip is highest on Sunday and lowest on Thursday. Cool. Then the next plot after that is a line plot. Line plot is helpful to plot what kind of information I explained you yesterday. Line plot is helpful when you have what on the x-axis, what time, and anything other than that, date. Yes. Now, if we look into our data set, do we have the time or date? No, no. So we have to do jugaad. We have to do some jugaad and get it possible, right? So what am I doing? These line plots are used to visualize trends or changes over a continuous variable, typically time or index. They are often used for tracking, model training, metrics, or time series data. let's look into the syntax. plt.plot x, y, color, line style, line width, line marker, and what about the label part? Important thing only is not there. Label, all of these are very much self-explanatory from the name itself. So that kind of eases my job. But I don't have any time-related information, right? That's a problem. So what I want to do is I want to find the average tip amount, not by day, but I would say over the table size. The average tips by size is grouping by size and finding out the average tip. So we understand the average tip given by the group of 4 people is when a customer comes in a group of 4, what is the average tip given? Ah, yes, that's correct. And what is the average tip given when a customer comes as a couple? As a couple? Ah, perfect. Yes, it's 2.5. Perfect. So I'm gonna try to plot that only. So we know that this is the index and these are the values. I'm just trying to do jugaad, right? So first you have a look at this. Table size 1, 2, 3, 4, 5, 6. Average tip given and each and everything is plotted. I could have gone for a scatter plot as well, but I went for a line plot. As you can see, this dots are there. Then dot index versus dot values. We know that very well. Color is orange. Label is average tip. Because of that, this legend appeared, right? Label is given, then legend function should come. Else that label will not be there. So this is to add legend to the plot. Then line style is dash. So dash means solid, solid. Dash is there, then it is dashed line. Line width is 2 and marker is 0. So line width is the thickness of the line. If I make line width as 6, see, doesn't make sense, right? So you can play around with that. Have a look at the code. Then inside. The average tip amount increases with the table size. Yes. Except for over here, right? Average tip amount is highest for table size 6 and lowest for table size 1. I had shown you a box plot yesterday. Also, I shared a sheet where which chart to use in which situation that I had already showed you. So that should not be a problem. I go ahead with a box plot. Box plot can be univariate or bivariate. Right now, I'm talking about univariate. So they are used to visualize the distribution of numeric variable and identify the outliers. They are useful for comparing distribution across the categories. Okay. And one more, they are frequently used feature analysis for machine learning. So, syntax. plt.boxplot. X-axis is X column, Y-axis is Y column. Data is, oh no, that was I thinking, why is it showing so odd? plt.boxplot, only data. And some other parameters are there. They are not very common. It is suggesting, but even I'm not aware of patch artist. I used it around 5 years back. I had seen that, but I don't remember what it is. Notch also had used it long time back, but today honestly speaking, I don't remember. I was planning to go ahead with only one parameter, but let me take some risk. You never know. I once again recall the things. Okay. So it says over here, the data we know is the data to be plotted. So I'm mostly going to plot the tip column, vertical or the horizontal alignment. So box plot should be like this or like this. Patch artist, that is fill the box with what color, okay? So example can be patch artist equal to true. Acha, that's it. Notch is whether to show a notch in the box plot. Example notch equal to true. And width will be the width given. Okay. So I'm planning to look at the tip amount box plot. Plt.figure, plt.box plot. First of all, I'm getting rid of all of this, plotting it. What happened? This is the box plot. Where you see this is the minimum value, 0 percentile. This is the 100 percentile, 25 percentile, 50 percentile, which is the median, 75 percentile. And these are the outliers. So some of them, have given much more than $6, which is way higher than the average. And we are quantifying it as outlier. Outlier can also be on the lower side. This is what we see. And how to handle the outlier, we'll see it in due course of time. And here, if I say vertical is equal to true, it is like this. So if I say vertical is equal to false. So that's how you see that. And if I say patch artist, so it will be filling that. Okay. Do I have the option color as well? No. Then, okay, what color can we fill it by? We don't know. No problem. Notch is equal to false. And let's try notch as true. So this is a notch. Yes. Where the median is there, it will give a khachal thing, right? Just a slot, notch. And width is equal to 0.5. So you can see the width has increased as compared to this. Okay, that's what we understand from the box plot. Now, the last thing over here is getting into the subplots. We had already studied subplots earlier as well. Do you recollect subplot topic in the previous session? We had already studied, right? So what is subplots mainly used for? Having more than one plots plotted together, right? So I can say it is for multiple plots in a single figure. Use case used to create multiple charts in a single figure. And these are useful for side-by-side comparison or grid layouts. Syntax, figure comma axis, and rows and columns and figure size. Okay, that can be good. Then the next is we come out to this. Now, figure comma axis, I am creating a figure, let's say of 12 rows, 12 comma 4, that is the thing. Now I say figure and axis, and I say 12 cross 4, and this is 2 cross 2. No, I'm planning just to go for 1 cross 2. So one row and two columns. So 0 and 1. So axis is 0, comma 1. I am planning to go for a histogram of this, and alpha is this, edge color is black, and the bins I'm planning to go is, let's say, 50. In the same way, I'll be setting the title and X label for it, Y label for it, grid line. Okay, let's set that. And then this is 0, 1. 0th row and first, no, I should be 0, 0, right? I should have gone with 0, 0. Better it goes first, right? And then in the 0, 1, I want to go for a scatter plot. So I say scatter this. Okay, that's good. Oops. Uh, Two were given. What did I say? One row and two column. That was correct, no? So this has to be 0, 0, 0, 1. Yeah. What is the thing? 1, 2, right? With 1, comma 2, it doesn't work. These two are empty. Okay. Hmm, I can make it work. I'm just thinking why it is not working. Okay, let me just plot it over here. So if I say I want 1, comma 2, then let me just keep 0 over here. That will work. But this also should have worked. And this will be just 1. Now it will work. See, this is the 0th plot. This is the first plot. If you want to create 1, comma 2, right? Just have a look at this. Yeah, you see the complete code and the plot now. Like, yes. So you can see this is working, everyone. I'm sure you got this. And here, let's say, no, before this, I'm creating a box plot. And a pie chart. Yeah, that's looking good. Oh, it has to be made bigger. Yeah, much better. Better I show it separately here. Yeah, that is how it is. See over here. Let me increase the speed. So the ball is falling in whichever bucket that is increasing. Okay, so whichever bucket it is falling, we are increasing that. And what you see right now, which is getting plotted, is a histogram. Now, so what does histogram mainly look for, right? So histogram will be looking for, not a good one, not a good one. Now, see over here. So histogram will be looking over here. How many records are having the value 12? So there are 6 workers having the value 12, 8 workers having the value 17, and so on. So these heights are being plotted. The frequency plot or the count is being plotted over here anyways. In the same way, so there are only 5 ins. That means that between 0 to around 12, there are 60 values in the total bill. So there are around 50 customers whose total bill is between 0 to $12. Between 12 to 22, there are 120 customers. Between 22 to 32, there are again around 50 customers. Between 32 to 42, there are around 20 or 19 customers. And between 40 to 50, we have hardly 5 or 10 customers. This is what is the histogram saying. So it is counting how many people are falling into which bin, depending on the number of bins that we create, and it will automatically divide the data as per the bin. So as per 5 bins, you can see it goes from 0 to this. So it has to divide the minimum to maximum into 5 equal bins. If I say make it into 6 bins, it's like this. If I say make it into 7 bins, so you can see when you make it into 7 bins, 0 to 10, around 18 people are there. 10 to 15, not 15, 10 to, yeah, 10 to 15, we have around 90 people, and so on. That's how you understand it, Anivesh. How count, right? It is nothing but the count that we see. Yes, right. So that was how the histogram is plotted. Getting into the Seaborn library. The Seaborn library. Seaborn is a powerful visualization library built on the top of Matplotlib. Yes. So you'll see a high level interface to do that. And Seaborn coding is more easy than Matplotlib. Yes, more easy than Matplotlib. Let us get started with the very first one, which is a histogram. Now, use case and all, we know it. I will go ahead with the syntax. SNS dot histplot. Data is the data frame. Bins is whatever bins you want to set it. KDE is the kernel density estimator. Color is the color. So we are looking for the histogram of the total bill. Now, data is equal to tips. And X is going to be this. Now, see, this is very simple. Now, if you look, why I say it's powerful. Number one, I said I want to create a histogram, and for that the function is histplot. Okay. Then I said the name of the data set is tips. Okay. The column which I want to plot is the total bill. Okay. Number of bins, let's say not give it, so it will automatically decide what is the best. Okay. KDE is this line around it, kernel density estimator, which I have kept it as true. Color, I have kept it as orange, and transparency, I kept it like this. Now, see if you look in over here, did I give the X label? No. Did I give the Y label? No. Seaborn automatically gives that. Seaborn automatically gives that. That's the power of the Seaborn library. And if you want to give it, you can use the code to get it like this. So you can definitely write down the code, and you see Matplotlib code comfortably working inside Seaborn. And why is that working? The only reason is because Seaborn is built on the top of Matplotlib. That's the only reason for this code working. Again, if you see insight-wise, this looks like a more clear plot as compared to the earlier one, is what you can see. And rest of the things, you have it over here. So every plot of Seaborn will have this format. What format am I talking about? The data parameter where you have to supply the name of the data set and the x equal to and the y equal to parameter, which says what do you want on the x-axis, what do you want on the y-axis. Finish. Always. In Matplotlib, you remember you used to write instead of this tips, square bracket, double quotes, and the name of the column. Here it is like this. Very simple for anyone to understand. Then the next one is the box plot. Syntax is sns.boxplot. As you can see, data x, y, u, and palette. So we will be understanding it as and when we use it. So I say, let's look at day-wise total bill. Right? So data is tips. The name of the column to be plotted is day versus the total bill. And then I will say title, X label, Y label, grid, and show. You see over here. Look at the visual, right? So the syntax is very simple, and I have plotted it as a bivariate. X-axis is the day of the week, Y-axis is the total bill amount, and you see the histogram plotted. Okay. If I do the same thing and I use the parameter like palette, palette is what? Palette is nothing but the style. I'll show you. Theme, palette is the theme. So if you palette, Seaborn. So you can feel free to give any palette. If you're giving a palette as tab 10, these 10 colors would be chosen. Based on how much more saturation and luminance you want, you can select the colors. If you give it as bright, these colors would be chosen. If you give it a pastel, low saturation, high luminance. If you look into high saturation by giving dark and less luminance, this is how it will be. This is HLS. This is HUSN. And if you see, this is gradient color, right? Dark to light, rocket. This is Mako. Many are there. That screenshot over here. So palette I have given set to. So you can see the earlier color and new color. Okay. Width, if I'm giving 0.5. So you can play around with the width of it. Right? This is the width. You adjusted the width. You can see the earlier width and the later width. Then here. The next parameter is notch. So notch is just going to put a khacha-like thing here, right? That's it. Wherever the median is there, it will be having that V insertion in between. That's the only difference. Just to clearly identify the median, notch is going to put that. It's optional, but it's easy to identify. That's the reason people use it. Now coming on to the factor like U. So U is what I am planning to give as sex. See over here I did not give you same code. Thursday, Friday, Saturday, Sunday, total bill box plot. Here I added you. Thursday, Friday, Saturday, Sunday, total bill box plot, but bifurcated as per the U. So U is going to divide the X wala value based on sex, because U is very common parameter in Seaborn in many plots. You'll see this parameter in many plots. So whenever I say U, it will just divide it on the basis of that. And U will always be a categorical variable. You cannot be a continuous one. I cannot put you as tips. That will not work. I'll show you. You, if I'm putting as tip, see, every tip is given a different. This is the legend only. And then the box plot. Sense in even the useless, purely useless. So see, you might have seen that the typical thing is it is not PLT dot. First change. Second, it is like giving the data and what you want on the x-axis and y-axis. Rest all of the things are more or less same. Yes or no? Right? These are the two changes. Instead of PLT dot, it is SNS dot. And data is the name of the data set and what you want on X and Y, right? My suggestion to all of you is by default go for Seaborn only. Seaborn is better than Matplotlib. So I would say as much as possible, avoid Matplotlib and use Seaborn. Also, if you here look in over here very carefully, in Matplotlib, you remember you had to earlier do the value counts, then value counts ka result ka index versus the values. You don't have to do all those things in Seaborn. That is another big advantage. You don't have to first find out value counts, then index plotted and value plotted, and then you give that. Seaborn is taking care of all these things automatically. That's why by default, this should be your choice. Seaborn is built on the top of Matplotlib, and hence both of them are good friends. The next is scatter plot. SNS dot scatter plot, and you have data X, Y, U, style, size, palette, alpha. Style is the categorical variable to change the marker style. Right? In Seaborn, it was marker, and here it is style. That's okay, na? So let's look at total bill versus tips. Data, total bill versus tips. And then that's good. You can see over here, you have it. Here only, if I give the U as the day. So if you remember, let me give U as the sex first. So male, female was divided. Do you understand this scatter plot? Earlier it was like this, and now it is divided as per male and female. Difficult to interpret, but mota we understand that the total bill and the tip given by males is the highest. Of course, here there is a mix, but see, females give very less tip also. That's not the case with males. However, the largest bill is observed when the bill payer was male. Okay. And if I do it by day, I think that won't make sense because 4 colors inside this is crazy, crazy. Let me actually do it by smoker. Smoker, yes versus smoker, no. Can this scatter plot convey that usually non-smokers give more tip or smokers give more tip? Do you get any significant insight like this from the scatter plot? Smokers are giving larger tip or non-smokers are giving larger tip. Something like that. Do you think it is clearly visible from the plot? No, na? It's kind of mixed. It's kind of mixed. Even I agree. It's kind of mixed. And here, if I'm giving the style, let's say as time, what will happen? Smoker, non-smoker ka division as per time. That goes little complicated, but as you can see, smoker, non-smoker ka division as per time. So obviously a blue dot in a blue color in circle will be lunch. A blue color in cross would be dinner. So this is dinner and this is lunch. A orange color in circle would be lunch, orange color in cross would be dinner. So this is dinner and this is lunch. Do you understand this? Is that clear? What is the style parameter doing? Hmm. And this is the style as sex. This is the style as sex. Rest all of the parameters are Lallu Panju. Size as per size. Size is one of the column which is about the people are visiting in how many groups, single or as couple or in a group of 3 or 4 or 5 or 6. Most of the people in this data set are visiting in what group size? If you recollect, tell me. Most of the people in this data set are visiting in, very good, very good. So you know what is this parameter size going to do? Size parameter is given a size. So you have these dots, right? You have these dots and crosses. If this particular customer who came, this is a male smoker. This is a male smoker. So that will be bigger in size if the group is bigger. So you see over here. Now I need to adjust the figure size. Right? So bigger the size of the circle, higher is the one. So I'll do one thing. Let me remove the style over here so that I can focus on one parameter only. And you see the style, you as the smoker. If I remove the you also, just to be very clear, right? So see, smaller dot size is one. This is size 6. So this is like size style 6, less, and etc. So I was saying that you see the style parameter, right? So bigger the size of the circle, that will be quantified by the size, right? That is one thing that you see in over here. And then anything important, sizes 20 to 200. So I can play around with the size, minimum size 20, maximum size 200. If I make it instead of 200, let's say 500. So sizes, I'm playing around with the sizes. You can play around with that. Then alpha, we know that. That's my alpha value. I kept it at 0.8. And we are done. Now, I'll come back to the smaller version of the plot. And I'll remove the things as well. Right. Now I get into joint plot. Now look at this joint plot. Joint plot is nothing but a scatter plot, but you can create many more things other than a scatter plot also. Have a look at this. Now, everyone, if you see, joint plot by default creates a scatter plot only. I'll copy this. Let's see if I'm not giving the kind as scatter. By default, it's a scatter plot. But, hey, what is happening? Why is the joint plot of this? Why is it? Maybe the size is small. Tight layout. See what happened because of tight layout. This one, which was just skipping out, if I comment it out, It was going in. Tight layout compresses it. Okay. Now, if you see in carefully, the code is joint plot, x-axis this, y-axis this, color orange, alpha this. So you see a scatter plot only once again. But do you see the powerful nature of the joint plot? A histogram of the total bill is here. You remember 10 to 20 is the tallest, and the histogram of tip is here. So most of the people give the tip in between $2 to $3.5, 2 to 3.5. So that is how good it is. Here, if I say, right, this is what we heard. Here, in this plot, which gave this code, instead of kind, if I say REG, so REG basically stands for a regression. Okay, regression says alpha should not be there. So I'll get rid of it. Let's see this. I just change the parameter kind is equal to scatter to kind is equal to REG. You get a kernel density estimator around this. And this line which says that as the total will amount increases, the tip given also increases. And the gray area around the line is the error in the line, which you can ignore right now. In machine learning, that can be helpful. For now, you can ignore. So this is far more powerful than a scatter plot. Okay. Acha, do you see carefully? Let me know if you observed it, that there are very less values over here, and this is very thickly populated over here. Did you all see? It's thickly populated over here, and it is thinly populated over here. Why am I talking about it? Is now I'm going to replace this by hex. See, thickly populated, and the color is thinly populated. That is what HEX parameter will help us. HEX. Or some parameter, no? Recede was only there. I don't know where it went. Oh, recede. That is also not there. Even I was thinking why it recommended these two. I forcefully asked it. I can use KDE. Hist also I doubt. Hist also I doubt. Let me try it out. Okay, hist. Darker the color, denser the population. So hist and hex are the same. Darker color, lighter color. It's the same. And then KDE is lot for us. You know what it says? The data is dense here and not dense here. Basically, what it is, this is basically a way of measuring the depth of the ocean. Ships use this to measure the depth of the ocean. Thinner the concentric circles, more deeper it is. And the wider the diameter, the more shallow it is. So obviously we will never require it, but just remember KDE as this helps us to plot this. Okay. So all of this, all of this with respect to Seaborn or with respect to Matplotlib, you'll find it all in the documentation. So Seaborn has a very nice documentation. Seaborn.pydata.org. Here, if you get into the gallery, any visual you want to learn, you can learn it from here. Let's say you are interested in learning about a scatter plot. Join grid, no, not join grid. Let's look into what we learned. What we have learned so far: box plot, LM plot, scatter plot. I'll click on this. See over here. They have used the diamonds data set of Seaborn and subplotting as well. But the most important is the scatter plot, what on X, what on Y, what on U. This is still the tutorial, right? If you are stuck up with the code. If you actually get into the Seaborn and if you are looking into a scatter plot, just Google for scatter plot Seaborn. You will be landing into the official page and you find all the parameters of it. And what all values, everything can take, you will find everything mentioned below, right? Legend can take these all values. So this is the best way. And the same goes for Matplotlib. So let's say if you want to look into the scatter function of Matplotlib, this is what you have in the next one. The next one is a bar plot. So bar plot, SNS.bar plot, what you want on x-axis, y-axis, U, palette, confidence interval, estimator. The default estimator is mean only. So I'll tell you what are we looking for. plt.figure. And I'm saying I want to look at the day-wise tip. So dataset is tips. And day-wise, I said I want to look at the tip. So day-wise tip. And palette, let's say I'm giving as muted. I know the palette, so I'm just giving them title, X label, Y label, grid, and show. But you can see it's nothing but a bar plot where we see that the average tip given is the highest on Sunday and least on Friday. This data, if you plot it with the help of a pie chart, it won't be making a lot of sense because this Thursday and Friday are very near to each other. Confidence interval is SD, means standard deviation. So this lines are for confidence interval and you see they have become more lengthier. Right now you don't need it, so and go ahead. Cap size is equal to 0.1. So you can see this is just marking it. Again, you don't need it. And then estimator, if I'm looking at the median of the, okay, let's say I just want to get rid of it. So I can say that I don't want all these things. Huh? So none. So I don't get that confidence interval lines because I really don't want it. Estimator is median. So by default, it is mean as I told you. So what is it? It is the day-wise average tip given. Day-wise average tip given. Right? And here, right? These are the values which I wrote. We are not interested in that, but I just wrote it. This is the day-wise average tip given. Okay. If I want to print the day-wise medium tip given, median, day-wise median tip given. So same code, I just wrote estimator as median. Rest everything is same. You can see this. Right? Rest everything is same. Have a look at the code. Day-wise median tip given. So the median values are written. Earlier average were written. You can change around that estimator. Okay. Now, inside wise, we already know. Bar plot is a bivariate plot. You have something on the x-axis and something on the y-axis. But now I am going for count plot. Count plot is bar plot only. Count plot is bar plot only. But in bar plot, as I told you, you have something on x and something on y. And that y can be the mean. The y can be the median. It can be the standard deviation. But in bar plot, so not in bar plot, in count plot, the y will be always count. It will be always count. So you don't need to give y. You see, I only gave x. Yeah, the y-axis is always count. Day is this, x is this. Rest all things are straightforward. Y is always count. So that is a count plot where we understand that all Saturday maximum customers come. Then I go to box plot. Here you have gaps in between the bars. There you don't have any gaps in between the bars. The next is a violin plot. Okay, before violin plot, let me show you box plot. Box plot is same only. Same like that. You don't have anything new in the code. Day wise tip, you have the box plot. Have a look at the code. It's self-understandable. Day wise tip, you have the box plot. And if I copy the same code, and if I put over here U as smoker. So that is bifurcated like this, right? U as smoker. So each day is bifurcated. What do you understand, right? If in box plots, it's always good to compare the median. Do you see the average tip? The average tip given on Thursday by smokers is more than non-smokers. On Friday, non-smokers give more tip. Saturday also non-smokers give more tip. And on Sunday, smokers give more. If I look at total bill, total bill by smokers is more on Thursday as compared to non-smokers. For Saturday as well, Sunday as well, but only on Friday. The total bill by non-smokers is more than smokers. That means as a restaurant owner, I will focus more on the non-smokers on Friday. And on the other day, I will focus more on the smokers. Are you all getting this insight? This is just a small insight that we received from this. Okay. And I'll just do this. And now I am going to go for a violin plot. Violin plot and box plot are the same. How can they be same? Because they are actually the same. Box plot gives us this. I just go and say violin. So in box plot, how much wide it is or how many values are there in between this are not known. But violin, it is box only. But how much data is stored, the wide width of this helps us understand. This is like a histogram plotted on left side and the same histogram on the right hand side. So you actually understand that, okay, the data is thick here, here it's thin, and here it is more thin. So there are less and less number of people. As the total amount increases, which was not observed in box plot, because box plot will simply plot a line. How many points are there? Here you understand, you know, This is like the tail of a lizard. This is the tail of a big lizard. This is the tail of a crocodile, even more thicker, right? So you understand where more data is there, where is less data in the tails. So they are little bit more good as compared to the box plot. And here, if I give you, then it becomes a little bad, right? Because it looks like too many things are being put up inside this. Too many things are being put up. So what we do is there is a parameter called as dodge. Uh-oh. Split. Okay, split huge. Uh, so there is a parameter called as split. What did it do? Have a look at it. Compare both. Here, two are plotted, two different. Here, we know that whatever is on the left hand side, same is on the right hand side. Same goes here, left hand side and right hand side are the same. It says here, let me only plot the left hand side, and here I will plot the right hand side. That's exactly what my split equal to true is doing. Now there are so many parameters. You might be like, oh my God, we have to remember so many things. I'm confused. I don't know what all parameters are there. He has taught us some of the parameters. There may be so many other parameters I may have to remember. Then let me tell that to you confidently that you will not need anything more than this. That much I can assure you for sure, because I am covering each and everything, whatever is required. Worst case, you have to learn one or two things. I think you should be prepared for it. You can't really say that, okay, this is the end of my knowledge absorbing stage. So don't get confused. Only these parameters and whatever I'm teaching, I can assure you is sufficient. Looking into this, do you all agree as the temperature increases, the sales of ice cream increases based on the scatter plot? Right? Yes. Which means that there is a high correlation between the temperature versus sales of ice cream. And they say the correlation is this. So, any correlation value, if all the dots are on a straight line, it's +1. If it's going up, if it's coming down, it's -1. This is 0.9. This is -0.9. This is 0.5. This is -0.5. This is as good as no correlation. There is a formula to calculate it. Here, right now, this is not important. Don't worry about it, but that's how they got the value as this. So I was talking about heat map, SMS.heatmap data, annotation, and so many parameters. Look at this. So core function, right? Core function is responsible for calculating the correlation between the numeric columns of the data set, only the numeric columns. So it says total bill when plotted against total bill, the correlation is 1. Tip versus total bill, there is a high correlation, 0.67. Size versus total bill also 0.59. No negative correlations found, right? So, but the correlation value will always be between -1 to +1. So here I'm saying that plot a heat map of this. Have a look at this. You see this? Lighter the color, closer it's to 1. Darker the color, closer it's to 0.5. There is no value below 0.5. Therefore, it didn't show that in the color bar. Now let us try to understand it. First of all, you have the parameter annotation equal to true, which will plot in the values. Annotation equal to true, you understand it. For your kind information, this is not available in Matplotlib. This is not available in Matplotlib, although you can create it, but there's a complicated process to do it. Even I have forgotten, but you can do it. We will do it. I'll show you why it is complicated, but first, let's complete this. CMAP is equal to cool warm. That is nothing but the theme. Yeah, you can see cool and warm. Good. Then line width is equal to 0.5. Line color is black. See this line width and line color. So line width, if I make it as 3.5 thick, of course, that doesn't look good. 0.5. Line color white and color bar equal to true. Yeah, this also looks good. Color bar equal to true. This is what you see in over here. Then after this, uh, you can clear a line plot. And the syntax is this. Obviously, total bill versus tip does not make sense, but I'm forcefully creating it. Forcefully, you need to give a proper column. But I think you understand it very well, right? I'm forcefully trying to create it, but you have to give a proper column. Okay. V size versus tip could be good. Okay. The next is LM plot. LM plot basically stands for a regression line plot. Straightforward only, nothing great. I'll show you the plot, then it will become more clear. So I'm going total bill versus tip. You see, it's scatter plot only. It's scatter plot only. And here as well, if I'm putting you as smoker, you get two lines. Have a look at the code. And then pilot as set 4, not there. Set 2 is here. Markers and confidence interval equal to none. So you have the markers here and confidence interval equal to none. So you don't see that gray portion around the line. Right? Scatter KWS is the size. If you see this, instead of 50, I'm making it as 20. You see, they have become small. Scatter keywords. S is 20. That's a little different way of writing it, but yeah, that's how you have to write it. You can also give alpha inside this, so it will adjust the transparency as well. Smokers give higher tip above a certain bill. Wow, that's very nice, Shiva. That's very nice. Good. And then this is the plot. The last one, which I want to show you, is a pair plot. Now, pair plot plots every numerical column versus every other numerical column, and it is not recommended. I will tell you why. See, I'm not giving anything to the pair plot except the name of the data set. I'm not giving anything to the pair plot except the name of the data set. Data is equal to tips. What it does is it takes all the numerical columns and plots them. All numerical columns are plotted. First, if you see, it is plotting total bill versus total bill ka histogram. We know that $10 to $20 most of the customers are there. This is tip ka histogram. Most of the tip given is between $2 to $3.5. Most of the key people come in size of 2. Here, if you have the total bill versus tip scatter plot, total bill versus size, as the total bill increases, the size increases. Tip versus size. These plots, these three, 1, 2, 3, and these three are the same, right? That's an important thing. If I come down and I put U is equal to smoker, so you see, everything is bifurcated as per the smoker. Everything is bifurcated as per the smoker. And if I say kind is equal to KDE, then here there is no more an histogram, but here you have kernel density estimators. And that's it. That's it. This is how it is. This is exactly how it is. Now, let me quickly look into our day one. We don't have the library called as Plotly as far as I understand. Do we have it? No. When I shared with you the curriculum, this was how it is. So we completed so far, and the next part is the mathematics and statistics. But, are you interested in looking at one more awesome library in 10 minutes of time? I'm not recommending it, but it's good. Yes? Okay. You all will not ask me lot of questions related to it. That's a sincere request. Else we will end up investing huge amount of time. Second thing I can assure you is it's easy. It's easy. That is what I can assure you for sure. So I will continue in the same way. And this time I'm going with the Plotly library. The advantage of Plotly is the visuals are interactive. When you hover, you can see the values. No need to use the plt.text function. So first, let me get into histogram. So I already have the data set. I have to import the library. That I'm doing it quickly. Import plotly.express as px. Px.histogram instead of SNS. Data is tips. Total will. Number of bins, not bins, n bins. Color is as per sex, and you have this. Now you'll be like, Darshan, what is great? Well, let's remove the color first of all. Okay. So this is the total will histogram. You'll be like, it looks the same. Yes, but now see how many are there in this bin? All of these. It's awesome. Plus you have some other features like zoom, pan, etc., etc., etc. And if I use over here, color is equal to sex. So you have the same thing distributed as per male and female. Isn't that cool? Right? Nice, na? I told you, right? It's good. It's awesome. Yes. This is also something which is very popular in the industry. The next one is a box plot. I'm not doing anything great. px.box, name of the data set, x and y. Color is the U parameter. I hope you understand now here. Color is like the U in the Seaborn. Whoa, wow. मजा आ गया. आया कि नहीं मजा? Awesome, right? That is the USP of Plotly. You hover and you see it. This is much, much better. The next is the scatter plot. Total will versus tips ka scatter plot. Let's not color it by sex first. Let's not do it by this. Right? Wow. 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 And when I hover the data, it should show me day also. So therefore, it's showing day also, Saturday. So on Saturday, the total bill by this customer was $28 and the tip was $6.5. Here also you get it. And here, color it by sex and size as time. Size as size. So coloring by sex and size as time. You get a lot of insights. It's interactive. That's the best part of it. Bar plot. See this. I'm looking at the average tip given per day. Look into the code. I'm pretty sure you will understand. I computed it by doing the group by. Then I'm doing it. Violin plot. Wow, that's good. px.violin, data, x and y. Color it as per sex. Because I said box equal to true, inside this you see a box. Points equal to all. Therefore, you see this scatter plot as well. And rest all things are understood. You got to go for a pie chart. So you hover and you see the results. So first, value counts, smoker given, smoker counts, name as smoker. Therefore, you see smoker equal to yes, name. value as count. Therefore, you see count is equal to this. Then I'll get into a line plot. You see over here. It's same X versus Y. You just need to give a time related column here. I had to forcefully give something. And I was also, I also promised you that I'll show you how to create a heat map using the Matplotlib. That's not good enough. See, heat map created. But in Seaborn, it was so simple. SNS.heatmap. Now here you look into the code. After loading the data, you are computing it. Then I'm creating IMShow to show the correlation metrics, CMAP and interpolation. Then X-ticks and Y-ticks for having in Seaborn, it was just annotation equal to true. And then here I had to plot all of these things. Then color bar. कुछ नहीं करना पड़ता Seaborn के अंदर. It's far much easy. It's far much easy. That's one of the strong reasons why one should not use this. But yes, Matplotlib not for heat map. Use Seaborn. Let me now ask you, we looked at so many Plotly codes. I just want to get a confirmation. Did you all understand all the codes which I just showed you? Not only the visual, the code also in the Plotly. Did you all understand it? Easy, right? Yes. Plotly is far more complicated as well. Plotly is far more complicated as well, but we are not getting into that. I just gave you a quick introduction. You can visit the Plotly website, Basics of Statistics. Now we all know that mathematics is a big part of our lives, especially stats. And what is statistics? Statistics is nothing but a branch of maths. Statistics, in simple words, is a branch of math and which focuses mainly on analyzing what is happening in the world around us. So it's basically nothing but a collection of data and its representation. So statistics compare the data through mean, median, mode, etc. So we all have heard that we live today in something which is called as the information age, where we deal about the world around us, and most of the information is mathematically determined using statistics. How? Well, let's understand why and how is this important. As I told you, statistics, they are nothing but set of mathematical equations that are used to analyze what is happening in the world around us. So much of the information is determined mathematically using statistics. What is happening in the world around us? And when you use it correctly, statistics can tell us the trends in what is happening in the past, which can be helpful for predicting what will happen in the future. How? Well, machine learning has the backbone as statistics only. So how? How can statistics be helpful? Let's consider an example. Some of the examples of how statistics shapes your life when you don't even know it. Example, consider weather forecast. Do you ever watch weather forecast sometime during the day? What is the weather today? right? But the question is, then how do we use that information? How do we use that information? Have you ever heard a forecaster talking about weather models? So these computer models are built using statistics that compare the prior weather conditions with the current weather conditions to predict the future weather conditions. So statistics comes in picture over there. Or the second one, emergency preparedness. So what will happen if the forecast predicts that there is going to be a hurricane, or maybe there are going to be tornadoes which are likely to occur? This is something which happens in US very commonly. So emergency management agencies move into the high gear to be ready to rescue the people. So these emergency teams also rely on statistics to tell them when the danger may occur. Or consider predicting the diseases. So a lot of times on the news reports as well, statistics about a disease are reported. So the reporter simply reports the number of people who either have the disease or who have died from it. So, let's say Corona is going on. So every day they are reporting how many people have Corona, how many people died from it. So you'll be like, wow, that's an interesting fact for me. But it may not mean a lot to you unless and until anyone from your home gets admitted. So I want to say that when statistics becomes involved, you have a better idea of how that disease may affect you. How? Well, studies say that 85 to 95% of the lung cancers are mainly smoking related. Now, the statistics is kind of telling you that 85 to 95%. So it's like telling you that almost all the lung cancers are related to smoking. And if you want to have a good chance of avoiding lung cancer, you should not smoke. That is how statistics comes into picture. Or to talk about medical studies. So scientists, while preparing vaccines, right, they must show a statistically valid rate of effectiveness of any vaccine or any drug that can be prescribed. So statistics is behind every medical study that you hear about. Consider genetics. See so many places where it is used. Many people we know are afflicted by disease which are coming from their genetic makeup, and these diseases can be passed on to their children, which is one such disease which comes from the genetics. One of the very common disease which we get from the genetics. If your father or mother has it, you are likely to get it. Exactly. Diabetes, sickle cells. Okay, that is also something I never heard about it. But yes, diabetes is very, very common. Right. So statistics are critical in determining the chances of a new baby being affected by that disease. Or consider political campaigns. Whenever there is an election, the news organization is going to consult their models when they are trying to predict who the winner is. So candidates consult the voter polls to determine where and how they campaign. And statistics play a part in who your elected government official will be. I have four more examples. Insurance, and all of these apply to ML. So, see, by law, if you are going to drive a car, then you need to have car insurance. If you have, uh, if you have a house, right? If you mortgage your house, then you insure it as well. So the rate at which the insurance companies are charging you. So let's say your car premium comes out to be 20,000 rupees per year as an insurance cost. Now, how are they calculating that cost? That cost is based on the statistics of all the drivers in your area. So let's say overall, we realize that you stay in some area X. The number of people which stay over there are 30 lakhs. And there is some area Y which is equally big, but the number of people which are staying over there is just 3 lakh. Now tell me, in X and Y, if you are in which area, if you are staying, the chances of your car getting brushed up by other car is higher in X or Y? X, right? Yes. So you consider this to be like Mumbai, and consider this to be, let's say, like Jammu. This is thickly populated, this is thinly populated. So the rate at which the insurance company is going to charge you, the insurance premium depends on the overall number of cars, overall number of accidents, overall number of claims, and many other factors. And obviously here it is likely to be higher. Similarly, if you are buying a property or leasing a property, here it will be higher and here it would be lower. Then coming on to the next one is consumer goods. And when it comes to consumer goods, the best example which comes to my mind is Walmart, which is a worldwide retailer which keeps the track of everything they sell, and they use statistics to calculate what to ship to which store and when. So they have so many food chains. Which store will be short of what at what point of time and when to ship it? It will do that. So from analyzing their past vast store of information, Walmart decided, Walmart decided long time back that people buy people buy strawberry tarts. What are strawberry tarts? Strawberry pop tarts. Have you ever had this strawberry pop tarts? No, seriously, no. Even I never had it because it is available popularly in USA, not in India. So coming back to what I was saying, right? It's not available in India. I don't know. I mean, nowadays everything is available. You should be getting it. Maybe on, if I go on to Amazon that in, do we get that today? Everything is available. See here, order it and have it. Everything is available. In fact, nowadays, when I travel to any of the foreign countries, I do not get anything from there. There was a time when the things over there were special, but now you get everything available everywhere. When I went to the US also, I literally didn't even buy a single t-shirt over there. All those t-shirts were made in China. So paying over there 800 rupees for a t-shirt and buying the same quality t-shirt over here at 250 rupees. Useless. But coming to the point, so Walmart, right? I was talking about it. So Walmart decided to buy Walmart found out that people buy strawberry Pop Tarts when a hurricane is predicted by the weather department in Florida. That is a real-time case study. So, Walmart found out that people buy strawberry Pop Tarts when a hurricane is predicted in Florida, and therefore they ensure that they are shipping this product to the Florida stores based on the weather forecast. Well, my question to you is why are people buying strawberry Pop Tarts due to hurricane? Any reason behind it? Why people are buying it? Can be kept longer. You remember during the Corona time also when they were like anytime lockdown can occur. So people used to dump their food with so many items. Same funda. Right. So whenever these kind of warnings come, people are not going to move out of their houses. So they should have something to eat. And strawberry Pop Tarts are tasty and they have a longer shelf life. And therefore, people might be using that. Okay. So that was the example of consumer goods. Last two examples. How statistics can shape your life when you even don't know it. Quality test. Companies, we all know, they make thousands of products every day, and each company must make sure that a good quality item is sold. But a company can't test each and every item that they ship to you. They can't test each and every item that they are shipping to you. That is the consumer. So what does the company do? The company uses statistics to test just a few called as a sample of what they make. And let's say they are making total 1 lakh products a particular day. They will take a 10% sample and they will perform all the tests on it. And if all the tests are passing on that sample, the product is approved. And if all the tests are not passing on that sample, then this entire 1 lakh products are not approved or disapproved. And one last, stock market. Another topic that you might have heard a lot in the news. So stock analyst uses the statistical computer models to forecast what is happening in the economy around us. Therefore, I say statistics is shaping our lives without even us knowing it. And today it has been taken over by machine learning. So machine learning is using this in the backend. So now finally we say, what is statistics? It is the science of how data is collected, analyzed, implemented. Collected, analyzed, implemented. That is statistics. Always remember these three words: collection, analysis, and interpretation. But there is a difference between what is data and what is information. How many of you are aware that data and information are different things? People use it interchangeably, but they are different things. How many of you are aware that they are different? Information is the process data, right, which can affect us. Yes. So if I give you the data set of, let's say, Superstore, which we saw, right? So in the Superstore data set, you have 9,994 records. That's what we saw during Pandas. But when I apply the unique function on the category column, how many unique categories were we able to find? In that Superstore dataset, how many unique categories were we able to find? Uh, no, not 60. Technology, furniture, And one more was there. I will three. Three. Acha, if you recall the student data frame that we were working, in the recommend column, how many unique values were we able to find? In the student data frame that we were, two. Yes and no. And out of that, five were no and three were yes. So, yes, that was the information. And the data set is nothing but the data. So, typically the data takes the form of observed measurement like height, temperature, etc., or descriptions like dog, cat, blue, female, etc. So, thus we say statistics as a discipline concerns how we use the data to say the things about the real world. And we want to turn this raw information into what we call as useful knowledge. So, we might want to summarize the data, and this can be done visually by looking at maybe a graph of the last week temperature, or we can look with numbers, like we can look at what was the average temperature last week, etc. Just read it. Wise Words by Karl Popper. Now, one very, very important thing which I want to conclude before I move ahead, because now I have to get into the some of the basic terminologies of statistics. But before that, there is one most important thing which I want to tell you. Uncertainty is rampant. That means statistics means uncertainty. Statistics means uncertainty. So we use statistics to answer questions about the things that are unknown. So if I ask you, can you tell me the total number of trees in the Jim Corbett National Park? If I say that, can you count, given a task, can you count the total number of trees in the Jim Corbett National Park? Possible or not? But I say no. Okay, let me ask you one more similar problem. If I say, can you tell me what is the average weight of an adult male in India? So we have a population of around 143 crores. And let's say I'm assuming that there are 50 crores male. And if I want to find out the average, so let's say government created a nice system. We have created a nice Android and an iOS application where every person has to measure his or her weight at his home and upload his weight on the app. Very much streamlined. Now, do you think we will always be right, or we can go wrong? And if we can go wrong, what do you think? Why? Why can we go wrong? App is created, everything is perfect. What can be the reason? Death. Okay, yeah, that's a valid point. Yes. People might give wrong information. Yes, that is also very much fine. Many people might not have mobile. Okay, that is also perfect. So, if you look at weighing scale, over here, have you seen weighing machines which are not showing zero by default at times? Right? Yes. Or consider this. This is a very typical example, right? In analog machines. So what if someone used this kind of machine and you can see it's not exactly aligned with zero? Again, there is an issue. Let us say all these things are also sorted. Let us say all these things are also sorted. You know, my weight today is 100. Sometimes I see my weight as 101 and sometimes I see it as 99.5. Weight also keeps on changing. Let's say I had a very heavy lunch, it increases. Or let us assume I had one glass of water, my weight changes. Or someone went to the washroom, doing potty and all. So again, his weight changes. So at what point of time are you measuring the weight? That's also a problem. Moral of the story. What I want to conclude with these examples is there is no way you can do this correctly. Similarly, over here. So I don't say that we will be grossly wrong, but there will be a small scope of error, and hence I was saying uncertainty is rampant. Uncertainty will be the theme of our class. We can't know for sure will be the answer given by me to a lot of questions, and statistical tools are useful for making the most out of this limited information. Let us look at some of the statistical statements. I say I sleep 7 hours per night on an average. So does that mean that right from the day I have born, my average sleep is always 7 hours? It is never 7.1 hours, or it is never 6.5, or it is never 6.95, etc. No. So statistical uncertainty. Students who attend the class regularly tend to get higher grades than those who don't. Well, not necessarily, right? There are some students who don't attend the class, but still do well in the exam. Okay, now let us get started with the thing. So now what we just understood is whatever is the thing that we are calculating. Let's say if we have collected the data of height of adult females living in US, so that becomes our variable. Height is our variable. So height of female 1, female 2, so on and so forth. Now, coming on to what you guys were saying, considering the problem of finding out the average weight of an Indian adult, which is practically not possible because the weight is changing. So what they say is if the things are practically not possible, you have a population of, let's say, 70 crores and you cannot find out the average weight. Then what do? We say, let us take out a sample. Sample is usually 10% of the population, not necessarily, but usually. So 7 crore. And then we find out the average. Let's say on this, we found out the average weight of the sample came out to 70 kg. So here we infer that the average weight is 70 kg. Now, what are the chances of us being wrong? Of course, they are there, but we will be very close to what is correct. But when you will be very close to what is correct, when your sample is good. For example, if you look into, I have to choose, let's say, population of 7 crores. And this entire population, if I am choosing from Maharashtra, and I found out that the average weight is 70 kg, and therefore I say that all of India's average adult weight is 70 kg. Do you think I made a good decision by taking everything from Maharashtra as a sample? No. What do you suggest me in that case? What should I ideally have taken? How should I taken 7 crore people? Yes, by distributing that proportionately, by taking it. And that is where, very nice. I'm happy to hear that. This is exactly where what comes into picture are the sampling techniques. We'll be learning about them as well later on, but right now I just wanted to highlight this. So essentially, population is the entire overall group we are interested in. And therefore, I say, if you're trying to get an idea of the average height of US adult females, then the population of interest will be all the US adult females. That's called as a target population, and they can be large or small, but usually they are large only. And sample is nothing but a subset of the data, usually 10%. So the variable of interest is measured on each member of the sample. And a single member is called as an observation. And thereafter we take the sample because the entire population of interest is not available to us. Like for example, if we are studying the height of the US adult females, we will collect the height of or the height data from that sample. We are not going to measure the height of every woman in the United States. So that's how we say that this is the population, this is the sample, and based on the sample, whatever readings you get, you will likely infer on this. Okay. Next. Now coming on to types of statistics. Broadly, we are going to study two types of statistics. The first one is called as descriptive and the second one is called as inferential. Inferential is exactly what we studied or understood on the earlier slide where you yourself suggested that you should have taken samples from each state, right? So from the population, where you take a sample, you do the calculations on this and then you infer on this. That is what is called as inferential. And descriptive is the one where you look into formulas like finding out the sum, min, max, median, mean, mode, standard deviation, variance, skewness, kurtosis, etc. As and when we require, we will be looking into this. So, see, we don't know all of this, but at least we know most of it, sum, mean, median, etc., etc. Same applies over here. So that's what I said. Descriptive statistics will involve describing a data. We can make a graph of it or find out the average or find out how spread it is using the variance. So we can tell any interesting features about it. And inferential, as I told you, it's all about inferring. Now, after this, Uh, the next thing which I want to talk about is directly the types of variables. So what is a variable? Variable is any characteristic, number, or quantity that can be measured or counted. Anything that can be measured or counted is a variable. So let us get started with the discrete variable. What is discrete variable? Well, discrete variable is also called as a categorical variable. Like I say that my gender, right? So gender consists of only limited values, male and female. It becomes discrete. Your qualification can be undergraduate, graduate, or postgraduate. That becomes discrete. So can you say that you are undergrad and a half? So always, whenever you talk about discrete, they are distinct and countable in nature. So now the next is continuous variable. Continuous variable is what? A continuous variable is the one that can have infinite number of values. Like, what is your height? So someone may say my height is 165.2 centimeter. Someone may say it is 190.63 centimeter. Someone may say it is 180.1, etc. So any value can be taken. So whenever you see floating numbers, it is continuous. And whenever you see countable values, it is discrete. For example, if I talk about temperature, so 29.3 degrees Celsius, 34.29 degrees Celsius, etc. All of these are continuous in nature. Then coming on to qualitative variables. Then I'll go to independent and dependent. Qualitative variables are the ones which are based on qualities or categories. Basically, you cannot do any arithmetic operations on them. Basically, you cannot do any arithmetic operations on it. And I can give you an example. Hair color. Hair color can be white, black, gray. You cannot do any arithmetic operation. Or if I say city name, Mumbai, Delhi, Chennai, you cannot add, subtract, do all these things. Whereas quantitative variables, you can add it or you can subtract it. So you consider age. Someone's age is 22, someone's age is 24, someone's age is 30. You can do that. And salary. Salary is again a quantitative in nature. I will quickly get into the figure of this. This is what best explains it. So let me explain each of this with an example so that it makes more sense to you. Variables are first of all divided into two types. numeric variable and categorical variable. So numeric variables, they are always and always the measurable quantities. What I say? They are measurable quantities. The count of cars that one has, the count of children that one has, and continuous, as we can understand. So, continuous is all about having the values can be decimals or fractions in a range. So, example can be height, example can be weight, it can be temperature, it can be time taken to cover a distance. Are you all clear with the left hand side of the plot, numeric, and how is it bifurcated into continuous and discrete, right? Next, we get into categorical. So over here, you will always have categories or group. Okay. Tell me over here that what all are the various gender which are available. The various gender which are available are male, female, transgender. Anything other than that I'm missing? Did I cover everything? Let me talk about what are the various religions available. First, I can say Hindu. Next, I can say Muslim. Next, I can say Sikh. And next, Christian. Next, Buddhism. Okay. Jain, Jews, Parsi, Shanto. Okay, I don't know that. Maybe available. Okay. I am talking about the another example. I don't have space, so I'm writing here education level. So education level can be undergraduate or graduate or postgraduate. Or I am talking about size of shirt. It can be small or medium or large. If you see carefully on this side, do you see over here and do you agree that undergraduate qualification is less than graduate is less than postgraduate and same is over here, small less than medium, right? So can I say that we do see some order over here? Therefore, we call it as ordinal over here. And in nominal, there is no order. So is it like female is greater than male is greater than transgender, or male is greater than female is greater than transgender, or Hindu is greater than Muslim and Muslim is less than Sikh? No. That is what is nominal. That is what is nominal. Now we get into the topic of finding the central value. Now, when I say central value, I'm actually getting into the descriptive statistics where we will be looking at mean, median, mode. So now I'm going to teach you something which is very easy. So I'm going to go fast. When you have two or more numbers, it is always good to find out the center of it. Like if we have just two numbers, 3 and 7, then what we do? We say, how do you find out the central value? 3, 4, 5, 3, 7, 4, 6. Central value is 5. Or you can also do, and that's exactly the central value in this case is what is called as mean. And if you have more than two numbers, then the idea is adding and then dividing. So if you have something like this, then 3 plus 7 plus 8 upon 3, which is 6. That's what we do. So we are calling this thing as the mean, which is essentially adding up the numbers and dividing by how many numbers. But sometimes mean can let you down. Example, let's say I want to organize a birthday party for my kid, and I need to know what is the average age of the kids which are going to come at the party. That's important. I want to find out what is the average age of the kids which are going to come for the party. So I am having the following things. There are 6 kids which are aged 13. And there are 5 babies which are aged 1. What is the average of this? 7.54 something. That's correct. Yes. So because the average age of the kids coming to my kid's birthday party is 7.5, I decide to get what is called as a jumping castle. And this turned out to be a very bad idea. 13-year-old kids will feel very embarrassed to jump in this. They are too big for playing this. And 1-year-old babies, they can't jump. So mean let me down. So I say over here that mean was no doubt accurate, but was not useful. Mean was accurate, but it was not useful in this scenario. That's just an example to show you some drawbacks. Then, therefore, I introduce median. What does the median say? Simply list all the numbers in the order, precisely ascending order, and choose the middle one. So if you consider birthday activities, I'll do one thing. I'll list all the ages in order. 1, 1, 1, 1, 1. 5 babies were there. 13, 13, 13, 13, 13, 13. How to find the middle one? This, 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 this. 13. Yes. Okay. So that is middle one. And therefore, I say, let's have a disco. So what will happen? 13 years kid will enjoy dancing, and 1-year babies will enjoy the music. And thus how we see median is helpful. Sometimes you have two middle numbers. In such cases, you have to find out the average of the two. Like if I ask, what is the median of this? First of all, the numbers 12, 12, 2, 2, 3, 3. Uh-oh. Because two values are there at the center. Done. Therefore, I say median is 8. Okay. Next. These are something which we have studied in the school. So I am going little fast over. But it is there as a topic in descriptive statistics. So I don't want to skip it. That's the reason, right? Yes. Mode. The mode is the value that occurs most often. Example. But the example continue. The first thing is we group the numbers. So we can count them. So we have 1, 1, 1, 1, 1, 13, 13, 13, 13, 13, 13. 1 came 5 times. 13 came 6 times. So I understand that mode will be 13 because that came out repeated many times. Therefore, I say mode is most. Mode is most. Also, one important thing about the mode, sometimes it can be tricky because there can be cases where you have more than one mode. How? What is the mode of this number? So if you see over here, in this scenario, 3 came one time, 4 came 2 times, 5 came one time, 6 came 2 times, 7, 10 one time. So the highest value is this and this. And because there are two modes, you call it as bimodal. And if there are anywhere more than 2 modes, you call it as 3 or multimodal outliers. What do you understand by looking at this image of outliers? What is an outlier? Recall your box plot. What is an outlier? See, always we can say that outlier is outside the group. For example, consider the salary of Mukesh Ambani at Reliance as compared to the salary of most of the people. Obviously, Mukesh Ambani might be taking the highest salary because it is his own company. Yes, that's what I wanted to tell you. That always something which is very, very away is not necessarily something that we remove. It could be a part also. We need to introspect. Here we say outliers are the values that lie outside the other values and they can change the mean a lot. So we cannot use them. Like for example, what is the mean of this? The mean is 24. So we clearly understand that the mean in case hour is 24. But one thing is for sure that the number 24 certainly does not represent the above numbers well at all. The number 24 does not represent the above numbers well at all. And if I say, let's try to do that without this. So if I have values 3, 4, 4, 5, and you also had 104. Let's not consider this. Now you tell me what is the mean. So if you are going to exclude that outlier, please tell the people that you are actually excluding it. Median. What is the median of this value? 4, right. So median is also good in this scenario. Whenever there are outliers, one should go for median. So I say go for median when outliers are present. And what is the mode over here? The mode is yes, 4. That's absolutely correct. Now there is something out of the syllabus which I'm going to teach, but I think that is good and important for everyone. Only one topic, only one topic. There are two topics which I have to teach. One topic you already know, and one topic is a new one, but you will understand why am I teaching you this, and it's important. So now, just keep your calculators ready. I want to talk a little bit more about the means. So the mean that we have been looking so far is arithmetic mean, which we covered. But there are two other types of means. The first one is the geometric mean. The geometric mean basically multiplies the numbers together, then does the square root or cube root depending on how many numbers are there. What? I'm not understanding. Idea is very simple. If you have, let's say, if I ask calculate the geometric mean of the numbers 2 and 18, what will you do? Because there are two numbers. Because there are two numbers, you take the square root. If there were three numbers, you would have taken the cube root. Of what? Of the multiplication of these numbers. Something like this. Okay, just understand the mathematics. Just understand the mathematics. I'll take one more example. I have the numbers 10, 51.2, and 8. So, because there are three numbers that will go inside cube root 10, 51.2 into 8. What does the final answer come out to be? 16. So, in this case, we understand that the geometric mean is 16. Something like this. So, this is the general formula for calculating the geometric mean. Now the $1,000,000 question. I taught you this concept, but is there really any use of it? Because we understand now there are two types of means. One is the algebraic, next is the geometric. The question is which one to use in which scenario and how can it be helpful? Let's look into this. When do we use geometric mean? Geometric mean is useful when we want to compare the things with different properties. I'll take an example. Let's say you want to uh, buy a camera. So you have first camera, and this camera has a zoom of 200. Number of reviews by customers is 8. He has second camera and it has a zoom lens of 250 and the number of reviews are 6. The question is, which one will you buy? Difficult to figure out because you cannot use the arithmetic mean over here. Okay, camera 1. You cannot use the arithmetic mean over here. You know how we solve this? If I solve it using the arithmetic mean, if I solve it using arithmetic mean, then that is 200 plus 8 upon 2 104, and this is 250 plus 6. This is what we see. So, why has this happened? See, the zoom is such a big number that this number of reviews that is almost getting lost. And therefore, we look at the geometric mean now. Geometric mean is we have 208 and 250 and 640. Yes, okay, that's correct. So now this is what is perfect. So I will say I will buy camera one. So what do we observe? We observe that even though the zoom of second camera is 50 bigger, the lower rating of 6 is still important. That is what is called as the geometric mean. The last type of mean after geometric mean, I told you there are two types of mean after that. Harmonic mean. Harmonic mean is going to add up 1 divided by the number. Difficult to say. See, 2, 4, 5, and 100. Number 2, I'll take it as 1 by 2. Number 4, I'll take it as 1 by 4. Number 5, I take it as 1 by 5. Number 100, I take it as 1 upon 100. And because there are how many numbers? 1, 2, 3, 4, 4 numbers. 4 upon this. That is what gives the harmonic mean, which in this case is, I think, 4.17. So essentially, we understand this is the formula. 1 upon 1, 1 upon 2, 1 upon 4. Perfect. Why harmonic mean? Well, harmonic mean, friends, is useful in some rate type questions. Example, go back to the CET exam type questions. We travel 10 kilometers at a speed of 60. At the speed of 60 kilometers per hour, you are driving a distance of 10 kilometers. And another at 20 kilometers per hour, then what is the average speed? I did a mistake. What is the mistake? You have blindly calculated looking at my ink 1 by 60 and this should be 1 by 20. Huh? So yes, the correct answer is 30 kilometer per hour. Now after this, next comes the standard deviation and the variance topic. But before that, there is one more topic which is called as the mean deviation. Let us understand this is very, very simple. More than formula, what is important is we need to understand what is the significance of it. Right? Formula is easy. Formula is easy. I can explain that to you in a second. Let's get started. So here I say, conclusion so far, mean, median, mode are the most common ways of measuring the central values. Use the one that suits your data, or better still, use all of three. Now we are going to talk about the mean from the frequency table. And that's very, very easy to calculate. They say you add up all the numbers and divide by how many numbers are there. Sometimes you don't have list of numbers, but what they provide you is a frequency table, which looks something like this, saying that number one came two times, two came five times, three came four times, four came two times, five came one time. How will you calculate the mean over here? The mean over here can be calculated like this. One came two times, two came five times, two, 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 two. Three came four times, three, 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 three. Four came two times, four, four. Five came one time, divided by how many numbers. That's exactly what is the mean, but that looks like a lengthy approach. So if you have that frequency table, a more better approach to calculate the mean would be two times number one came plus five times number two came divided by total. I think somewhere around 2.6 as per me. Just check it out. Okay, so that's the mean. So essentially, we understand that this is the formula, summation of frequency into that number upon the summation of the frequency. Now, after that, weighted mean, I'm gonna skip. That's not there in your outline. And I get started with the range thing now. Not that weighted mean is not helpful, but it's not there in your outline. So maybe at the end, if I have some time, I'll take on covering it. I don't want to cover the topics which are mentioned in a hurry at the last because I covered something additional before. Now we are getting started with the measure of the spread. Now, what do you exactly mean by the measure of the spread? Let us say it takes me 1 hour on an average to go from my office to home, or let's say I'll take the other way around. Let's say it takes 1 hour for me to go from my home to office on an average. The average time taken by me to go from home to office is 1 hour. But if there is traffic, I take 1 hour 15 minutes. And if there is no traffic, I take 45 minutes, 1 hour minus 15 minutes. This thing is what is called as the standard deviation. And standard deviation is nothing but the spread of the data. So standard deviation is one of the ways of measuring the spread of the data. Standard deviation is one of the way of measuring the spread of the data. How much is the data populated around the average? How much is the data populated around the average is nothing but called as the spread of the data. Understood to everyone? This is a very high level definition, but it's very convenient for anyone to put it into its head. Is standard deviation the only thing over here? No. I just explained you. Let's start with the very first one. Range. The range is the difference between the lowest and the highest value. Like for example, if I say I have a set of values 4, 6, 9, 3, 7. The lowest value is 3. The highest value is 9. Therefore, range is 9 minus 3 is equal to 6. Range is a way of measuring the spread of the data. Range is a way of measuring the spread of the data. So I'm clearly saying that we don't need standard deviation. Standard deviation formula is very complicated. So never use standard deviation, go for range. Because you can quickly identify how much spread of the data is. Range is the one which you'll always use, no standard deviation. So let's look at this now. My slide is contradicting me. The range can sometimes be misleading when there are extremely high or extremely low values. Like, can someone please quickly tell me what is the range over here? Now, because of this culprit, which is an outlier, you see the single value in this range is large, but most of the values are around the number 10, right? So we realize this as a problem, and hence we go for interquartile range or standard deviation. So I take back my words now. I would say opposite. Never use range. Either go for IQR or go for standard deviation. Yes, always remember. Range never kabhi jana hi nahi hai. Never go to that direction of range. Always go for IQR or standard deviation. When there are outliers in the data, how to handle it? So when there are outliers in the data, how to do that? Quartiles. Now, you remember a box plot, you'll see everything here only, that's not a problem. So quartiles are the values that divide a list of number into quarter. And the way you obtain that is you put all of them in the order and cut it into 4 equal parts, and the quartiles will exist at the cuts. How? Something like this. Let's have a look at it. If I said these are the things, first all of these are sorted in order, and then this number 2 is at Q0, this is at Q4, Q1, Q2, Q3, and Q2 is also called as the median. In box plot, you remember we had studied these all things. In fact, in pandas as well, when we did df.describe, we did get the minimum value, we did get the maximum value, we did get the 25 percentile, we get the 50 percentile, we get the 75 percentile. So statistics, all the things which are already learned by statistics, our Python developers have converted to Python representation. That's it. I am telling you, you are not learning anything ideally. All these things are already implemented by you. Rather, we are doing reverse engineering now. Whatever we studied, how are they related to mathematics is what we are studying. And without this also, without a knowledge of this also, how are this calculated and all, we are hardly getting affected. Because even if someone says, I don't know how are the quartiles calculated, the question is practically, do we ever have to calculate the quartiles by ourselves? We just say df.describe, it's done. Never ever in life you will be ideally doing the calculations. I am showing you, but I'm just trying to tell you that we don't need it. We don't need it. That's very important. Things are so nicely automated in Python that your life has become super awesome. Okay. So in this case, these are the quartiles. How are they calculated? I'm showing you. Don't worry about that. They also say that sometimes the cut comes in between two numbers. So obviously in this case, this is Q0, Q4, and this will be Q2. So as you can see, these are the values. So now I say, how are the values actually computed? Let us look into that example. So I am assuming that I want to calculate, or let's say I have even set of numbers. Let's say 5, 7, 8, 12, 13. Keep your calculators open. I need your help. Keep your calculators open. I need your help. 14, 18, 21. Is the data sorted? Yes, of course. I think it's already sorted. So that problem is gone. Now the thing is, how are we actually computing the things? The idea is very simple. Q0 is the minimum value, that is done. Then Q4 is nothing but the maximum value, that is done. Q2, which is median. How is it calculated? So Q2 will be the average of this value. So Q2 is basically average of this value. So I can say n by 2. Yes. So Q2 is ideally calculated as n by 2. So in case if our n is even, right? So we are looking into this example. So Q2 is going to be, no. I mean, wait. That's okay. But see, answer is not important. Wait. Answer is not important. Imagine instead of just 6 numbers, 8 numbers, you had 50,000 values. Then your calculator will not help you, right? So I want to show you the formula for calculating it. Getting it? I want to show you the formula. Here, even I can calculate it that way. Right. So yes, that's what I'm telling you. So here in case of this, Q2 is calculated if my n is even, it's calculated by n by 2. So I say how many values are there? The value of n over here is 1, 2, 3, 4, 5, 6, 7, 8. 8 values are there. So if I have to calculate my Q2 is given by, not this actually formula, just a moment. I will list down the formula that would be even more better so that all of us are aligned. So my Q2 is 12.5 only, but it is computed like this. N in this case is equal to 8. So Q2 will be computed as n upon 2 plus n upon 2 plus 1. Yes. X of n upon 2 plus x of n upon 2 plus 1 divided by 2. Now, n is 8. N is 8. What is the number? X means what is the number at n by 2th position? 8 upon 2? 4. 1, 2, 3, 4, 12. What is the number at n by 2 plus 1 position? N by 2 is 4 plus 1 is 5. 1, 2, 3, 4, 5, 13. So now that becomes universal. Now that becomes very much universal. And we also have to compute Q3 and we also have to compute Q1. So in this case, the Q1 value is computed if my n is even by using the median of first n by 2 values, right? So Q1 is nothing but the median of first n by 2 values. So what are the first n by 2 values between Q0 and Q2? What is the median of this? So that will be the centermost number over here. Q1 is median of first n by 2 values. Q1 is ideally the median of first n by 2 values. And in that scenario, it is going to be, what are the first n by 2 values? So I'll also write it. The first n by 2 values are 5, 7, 8, and 12. So this will be the second value plus the third value divided by 2, 7.5. And in the same way, your formula for calculating Q3 in this scenario, when the value of n is even, will be the same like before. So you want to calculate Q3. So Q3 is going to be, you need to use the last n by 2 values. That is the median of last n by 2 values. So 13, 14, 18, and 21. So this is going to be, Q4 will be 14 plus 18 upon 2, which is 16. Not Q4, Q3. This is how it is going to be. And in the same way, you calculate it for your odd number as well. So for odd number also, you will have to use the formula. So let's say, if you have odd number of values, in that case, your Q0 is nothing but the first item. Your Q4 is nothing but the last item. Your Q2 is going to be nothing but the item at n plus 1 upon 2th position. Q1 is going to be the median of first n minus 1 upon 2 values, and Q3 will be median of last n minus 1 upon 2 values, and it's done. So I think when you have the numbers, substitution part can be taken care of by you. Yes or no? All right, I need not do that. Come on, let's not do that. And we never need it also. That also I told you, you never need to do this calculation all by self. So that's not a problem ever. Okay. Now, okay, chalo, let's go ahead. This example, then what is going to be the interquartile range 7 minus 4, right? Yes, which is 3. So what do we understand? See, what I understand by this is if you see a box plot which we plotted during the CBON, because now you clearly know that when a box plot comes, what is Q0, what is Q1, Q2, Q3, and this part is what is called as interquartile region. Let us consider the box and a whisker plot. So see, this is the box, and this what you see around this, they are called as whiskers. Okay, so these are the values. First thing is we'll have to put them in the ascending order, and then we find out the quartiles. And once we have the quartiles, I get Q1, Q2, Q3, Q4, which is computed over here. Lowest and the highest values are also computed over here. Then Q3 minus Q1 is going to give the IQR. So which I plotted, it gets plotted like this. And this is what we understand. Okay. So they say whenever you have outliers in the data, don't consider this, only consider the data in the IQR region. This is wrong. I mean, I won't say 100% wrong, but you can definitely say 50% wrong. What I mean by that is you don't have it in your curriculum, but there is a technique which is called as Winsorization, or it is also called as soft capping for outliers. That comes in machine learning. Let's look into this. We don't understand the code, neither am I interested, but I want to show you some important things. Let me see if there is something here. So, see, in this data, the author of the notebook says there are outliers. You can see over here, there are outliers. Outliers are there on the higher side, not on the lower side, because this is about the income. Okay, fine. Now, we say that this method should not be preferred over the z-score when the particular column is not normally distributed because it is having values here. Now we say how we do. So listen to this. What does data scientists say? That you know what? Your IQR is this much, no? So you go 1.5 into IQR. So if your IQR value comes out to, let's say 100, then you do 1.5 into 100. That comes out to 150, right? So they say that from here, uh, you go 1.5 times of IQR. You can see this line over here, right? They say that from here, you only go 1.5 times of IQR. So Q3 plus 1.5 IQR, which is this 150 in our case, is this. And on the lower side, you go lower side 150. So here you went plus 150. Here you go minus 150. Q1 minus 1.5 IQR. So essentially, they are saying that whenever you have outliers in the data, you only consider the data here and here. This data, remove it. And if anything over here is removed, that can be the first option. Remove the outliers. Anything which is going outside 1.5. Now, how 1.5? They came up to this conclusion after some research that we need not get into that. I'm just explaining you one of the technique. Anything which is going ahead of 1.5 IQR and below minus 1.5 IQR, you're gonna remove it. I was talking about another technique, Winsorization. What does Winsorization says? It says the same thing. You calculate plus 1.5 IQR, calculate minus 1.5 IQR, and anything which is going out of this, or let's say there are some outliers here, anything which is going out of this, all of these value, let's say if this value, this value has to be 100. Let's say this line is at 100 and this line, let's say, is at 150. This is at 140 and so on. They say that all of these values, you get it at 100. Every value, you get it at 100. And here also, you get it at this. So basically, what are you doing? Anything which is going out, you are squashing it in the range plus minus 1.5 IQR. Are you understanding it diagrammatically what I said? If yes, then I'll show you how we do it in code. Diagrammatically clear all these values, bring it, compress it. So values will change, but outliers are there, right? So that's how we handle it. Consider a data set which has outliers. Ensure that the sample data set has at least 50 records. Plot the box plot for it. Print the code for. And now what am I doing? We have our day 5 ready, right? So I am going to create a Google Colab notebook over here only so that it remains very handy for us. The reason I'm doing it quickly is because I don't have this topic in the syllabus. So we are using ChatGPT to quickly get it so that we are not spending a lot of time on it. And according to me, it is important. So I call this as outlier capping. Now, let's see what data has it generated. Okay. Bf.head. By that time, I'll get the box plot code of it. Okay, so this is what is the data generated. How many rows are there? 50. Let me plot the box plot. plt.boxplot. Do you see outliers? Well, let me say, I want you to modify the code such that the outliers are there on the upper side and the lower side as well. Get me the new code printed. Let it be there on both the sides. What are the values at Q3 plus 1.5 IQR? Yes, 4060. Yes, perfect. What is the value over here? What is the value over here? 40 and 60. Okay. What we want is these all values will come to 40. These all values will come to 60. And so this will be empty and this will be empty. Let's see that. Explain winsorization for soft capping outliers. So as you can see, it's a technique used to limit the extreme values by replacing them specifically by this. Or let me say, I'll go for IQR capping first. Okay, Q1 minus 1.5 IQR, Q3 plus 1.5 IQR. Okay, I generated code again. No, I need not do that. So what are they saying? See, have a look. Now they say Let us calculate this. We have a box plot. 40 and 60, we know it. I'm doing it manually. Q1 is of this original column. Is that column called original? I don't know. Value column. We'll have to modify it. $44, $52, 8.59. Exact values. Okay. This is what we understand. 25% till 75% calculated. Then I'm calculating this. So Q1 and Q3 are here. This is Q1, this is Q3. And I calculated IQR. Then I'm also calculating the lower bound and upper bound, which is 40 and 60 respectively. So I would say see 31 and 65. Q1 minus 1.5 per Q3 plus 1.5 here. Q1 minus 1.5 here, Q3 plus 1.5 here. How come 31? God knows. Is the data changed or something? Runtime run all. 31 and 65. Okay. And then when you have this, then I'm doing this. DF of original, which is our column, apply lambda function. If anything is less than lower bound, make it at lower bound. And if anything is greater than upper bound, make it at upper bound. So I'm going to do that. It's just that the name of the column is not original. Name of the column is value. You see over here, things are capped. Original versus the IQR data. So now that we are clear, the next topic is the mean deviation. Mean deviation. Read through this. I'm sure you will not understand. It's very, very easy, but when you read through this, you will not understand. First point, everyone might have understood. You compute the mean. Second point, you said distance of each value from the mean and then mean of those distances. Once you see the example, you will quickly understand. Let us take an example. Keep your calculators ready. 1, 2, 3, boom. Can you quickly tell me what is the mean of these values? The answer should be 9. The second step, if you go back, the second step is I need to find out the distance of each value from that mean. Means the first thing that I will find out is what is 9 minus 3? 6. Yes. What is 9 minus 6? 3. This is also 3. This is going to be 2. This is going to be 2. Then this is going to be what? After that, what's the next value? 1. After that, next value? After that, next value? After that, next value? Minus 6. And after that, last value? Last value? Yes, minus 7. Now, if I say that when I travel from office to home, let's say this is a 3-kilometer distance. Does that mean that when you travel from home to office, the distance becomes minus 3 kilometer? No, right? And that's exactly what you all did. I circled out these values. That's because that only. Did I ever say that you subtract? No. Distance, distance. So positive or negative, we will write it as positive only. So this is exactly what I mean. So the distance from 9, so obviously 9 minus 3, 6. Similarly, this. So here also it's going to be like this. Whatever I wrote, maybe I may went wrong while writing, but yes, this is the final answer. And one of the very important ways you can do that is we know that the mean is 9. In this way, I have plotted this and this, right? So number 9 and 3, 9, 3 unit, 9, 3 units. This is 7, 16. So 9 plus 7, 16. What is the total of the values on the left hand side? Sum of this 15. Sum of these, if these two numbers are not same, LHS and RHS, then wrong. If these two numbers are not same, then you are somewhere wrong in doing the computations of this table. This is the way to quickly cross check your answer. We have the mean deviation, which is the mean of those distances. Mean of those distances means we got this. Find out the mean of this. Tell me what is the mean of these values? What is the mean of this? 3.75. Yes. So we get that means our mean is 9. Mean deviation is 3.75. So what is exactly mean deviation telling us? Mean deviation tells us how far on an average all values are away from the middle. How far on an average all the values are away from the middle. So I can also say that deviation is as good as distance. So the formula which was recommended by you and applied by you right now is that only. Initially you calculated mean, then every value you subtracted from the mean and took the absolute, and then the total of that divided by n, that is the average. And that's what we did. Read everything. Read everything which is there on the slide. This is not standard deviation. Let's take this example little ahead now. I'm taking this example little more ahead, where I say you and your dogs, use your calculator once again. You and your dogs have measured the heights of the dogs in millimeters. You and your friends have measured the height of the dog in millimeter, and following are the heights. Neck level, shoulder level. So this dog is 600 millimeter. This is 470 millimeter. This is 170, 430. I want to calculate the mean deviation. You have these values, and we know that the formula is something like this, right? So let me not disturb you. And can you tell me what is the final answer? First of all, you calculated the mean and the mean came out to be 394, right? So then you find out the absolute deviations and the total of that is 636. So the final answer will be 636 upon 5, which came out to 127.2. Am I correct? That's how you got it, right? 127.2. Yes. Perfect. Now we say that means therefore on an average, the docks heights are 127.2 millimeter from mean. But this is mean deviation. We are interested in standard deviation. So standard deviation is how much data is spread around the mean. So now this is what we already did, LHS and RHS. I need not explain that. Just few things. LHS, RHS 318, 318. If they are not equal, then you have made a mistake. Now let's get to the next topic, standard deviation. So what is standard deviation? Standard deviation is the measure of how spread out the numbers are. Exactly, if you remember, mu plus or minus standard deviation, the topic which I covered before the range function, I'm talking about that only. I'm talking about that only. And then after that, it is denoted by the symbol sigma, the Greek letter, and the formula for calculation of standard deviation is square root of variance. So standard deviation is square root of variance. So now the question is, what is variance? If standard deviation is square root of variance, then obviously, what is variance? So read it and see if you understand. Again, like the mean deviation, this is very, very similar to mean deviation, very similar. One difference, only one difference, formula is same. Yes, square. Earlier, x minus mu absolute was taken, but now we are taking the square, and that is nothing but your variance. Let me not invest a lot of time and take a step ahead. So I'm going back with the dog example. What was the mean value? 394. Now what do we have to calculate? The distance in between the mean and every dog. Right, so we have to calculate this distance, we have to calculate this distance, so on and so forth, which came out to be like this. I just masked the dogs over here, and these are the distances which we have. Then you will find out the square of each. So variance is this. And what is standard deviation then? What is standard deviation? Square root of 21704. So we understand this. That means it is 394 plus or minus 147. That is mean plus or minus standard deviation. That's what we see over here. And then this is what we understand. So what is the use of doing it? What is the use of doing it? Well, Now I understand all the values which are going outside of the range of one standard deviation up and down. So this is mu plus 1 sigma. This is mu minus 1 sigma. And so now I say, because of standard deviation, I have a standard way of knowing what's normal, which is in this range, what is extra large and what is extra small. So if you see this guy, this dog is extra large, and you look at this extra small, that's what standard deviation has helped me to find out. Rottweilers, they are tall dogs, and Dachshunds, they are a bit short, right? Yes. So standard deviations helps us to find out that. And the formula for standard deviation, as we just understood, is every value minus the mean square summation upon n, and that is going to be standard deviation of population. If you want to find out standard deviation of a sample upon n minus 1, that is what researchers say. It's there here. For sample, you won't take n, but you will be taking division by n minus 1. So in our case, I assume that the 5 dogs were the dogs in the entire population. So we divided by n. But if I say that, hey, there were 500 dogs, out of which I took this 5, then it becomes a sample. And then the formula will be like, instead of dividing by 4, you will divide by 5 minus 1. Instead of dividing by 5, you will divide by 5 minus 1. That becomes the variance. And this becomes the standard deviation. So the formula looks like this. So okay, this one also, this divide by n minus 1, you can consider it as a correction in your formula. So these are the formulas. This is divide by n for population, and for sample, divide by n minus 1. Now, we saw that in standard deviation, every time we were squaring, and that came as a doubt to my mind, because see, we have clearly seen that mean deviation was also giving us some answer. Then why are we going for standard deviation? That came to my mind, that if mean absolute deviation can do it, then standard deviation is required. Why? I mean, mean absolute deviation was saying that you take the absolute. That was also working good. Then why standard deviation? And that is exactly where I got the answer. If I consider these values, let's say, if I consider a line, and these are the points. This distance is plus 4. Let's say this is also plus 4. What is the mean of it? Do you think that the mean of this data can be 0? Calculation wise, I see that it is 0. It's not that I am disagreeing. Calculation wise, I see that it is 0, but can the average of non-zero values ever come 0? No. What is happening? What is the problem? The problem or the issue over here is the positives and the negatives are canceling each other. So they said that, hey, you don't go for mean, you go for absolute mean. That's exactly what happened in mean deviation. Mean deviation makes more sense. It actually captures that there was an error of 4. Are you all getting it? What advantage mean deviation gave and why we did drop off mean and we went for the mean deviation initially? Are you all okay? Understood this? Now, if mean deviation is taking care of this scenario, then why did we go for standard deviation where we squared it? I mean, that formula was also okay. Well, that answer lies here. Why are we taking the square? Well, consider one more example. Let's say this distance is plus 7. This distance is plus 1. This is minus 6. This is minus 2. Can you calculate the absolute mean for this? Can you calculate the absolute mean for this? Bolo, bolo, quickly. This is where I have the problem. Now you'll be like, what is the problem? There is a problem. See, if you look over here in this example, you can clearly see that the smallest value is minus 4. Let me write it. The smallest value is minus 4 and the biggest value is plus 4. So let's say here somewhere is 0. In this example, the smallest value is minus 6. The smallest value is minus 6 and the biggest value is plus 7. So come on, it's quite obvious that this is a bigger range as compared to this. So obviously the error over here also must be high and the error over here must be low. But mean absolute deviation is like, Darshan, the error over here is 4 and the error in this line is also 4. That's exactly what it is saying, and that is where it is going wrong. The error on the first line is more than the second line. Anyone can see it from the eyes also, right? You can, even if you observe this, see this is spread out only in this range and this is spread out in this range. See, the width of the box is higher as compared to this. So obviously the error also must be higher over here. This definitely has to be more than 4. It cannot be same. That is the problem. That is the problem. Wait a minute. If that is the problem, then do you mean to say that the squaring of the mean has solved this issue? Yes, I actually mean to say that. If I find, use your calculators, squaring of the mean, 4 square, sorry, 7 square, 1 square, minus 6 square, minus 2 square upon 4. What is the answer? 16. Oh, you see, 16 is smaller than this. 16 is smaller than this, and this is awesome. This is awesome. This is perfect. That's exactly what I wanted, and this is getting quantified here. That's good. Now, one problem is all the values are in the range minus 6 to plus 7, here minus 4 to plus 4, but the errors 16 and 22 look very big. So you calculate the square root of this, which comes out to 4.74. Yes, thank you. And here the square root comes out to 4. Yes. Now, see, just like these were 4 and 4, in the way, this is 4.74 and 4, and we see that the square root means or seems to be square, and then finding out square root seems to be a much better metric. And thus, I say, standard deviation is bigger when the differences are more spread out, just like what we want, and hence, we don't use mean absolute deviation, but we use standard deviation. So you statistically also understand why researchers initially invented mean. Then they found out how mean can let them down. Then they went for mean deviation. Then they found out scenarios where mean deviation is also letting them down. And then they came up with the mean squared, which is the standard deviation. And it works fine till today. These all things happened across several years. It didn't happen in a single stroke. Someone invented, someone found out the drawback. When someone invented, someone found out the drawback, and so on and so forth. These metrics are being invented. Now, we understand why are we squaring it. Last one thing over here is we just understood in the example of dog mean plus or minus one standard deviation, which was 394 plus or minus 147. Am I correct with the values? 394 plus minus 147. Is that correct? The dog example for standard deviation? Yes, no? Yes. Now, the last and the important thing, you cannot sustain without knowing standard deviation, variance, and the next topic, which is a small topic, which I'm going to talk right now. In machine learning, you cannot sustain without that. Till earlier, I mean, whatever I was doing, it is you just cannot sustain without knowing what is a continuous variable, what is a discrete variable, what is a categorical, nominal, ordinal. If you don't know that, machine learning is not for you. Telling it right now. Most important thing that we learned today. Next, you need to understand IQR. Without that, machine learning is not for you. You need to understand the soft capping. Without that, machine learning is not for you. You need to understand the standard deviation and variance. Without that, machine learning is not for you. And the fifth one is the empirical rule of standard deviation. Without that as well, machine learning is not for you. So these all things are important. Maybe harmonic mean, geometric mean can be still kept optional, but without these all topics, you cannot understand anything in the machine learning code, at least the interpretation part. This is called as the standard deviation empirical rule. So this has come out of the minds of the researchers. You know what does researchers say? That Darshan, you calculated that 394 plus or minus 147. Researchers say that after our lot of efforts, we have come to a conclusion that the data, 68% of the data will lie always between mean plus or minus one standard deviation, 68%. Then they said 95% of the data will lie between mean plus or minus two standard deviation, and 99.7% of the data will lie between mean plus or minus three standard deviation. If anything goes still out of that, then that is also one more way of identifying outliers in machine learning. This is also one more way of identifying outliers. So I was saying standard deviation, and the question is, we know that when I talk about the standard deviation of population, it is denoted by what? If you recall, by what do we denote the standard deviation of the population?
Here's what I found.
I, my Siri started talking. Okay. How do you denote standard deviation of the sigma, 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 sigma? Mu was the mean of the population. Mu was the mean of the population. Standard deviation of the population, which is denoted by sigma, and it was every value minus the mean whole square, summation of that divided by n, and the whole in root. In the same way, standard deviation of sample, which is denoted by what? Yes. You need all of this in hypothesis testing. I mean, in real life also, while coding also, you need this convention. That's why I'm insisting on it. In coding also, you need to use this convention, and these conventions are very standardly used everywhere. Everywhere. Everyone on planet Earth uses these conventions. So better you also use it. So that's going to be summation every value minus the mean square upon n minus 1 in the root. Now, coming on to our say. So the question is, why do we divide by n minus 1 for sample, but by n for population? See, ideally, it is completely okay if you don't know this. But if someone is asking you in the interview, then at that time you cannot say no, that okay, Darshan sir showed that it's completely okay. Why are you asking? He also knows that it is not required. But he will test your knowledge on how technically sound you are. So at that time, it's good to know why to let down. So I am saying the solution. So it's all about accuracy and fairness. You can start by saying that it's all about accuracy and fairness. We all know when I talk about a population, you have the data from every member of the group, right? And when you talk about a sample, you have the data from the part of a group, and you are trying to estimate from the for the entire population. So populations, small group is a sample, and based on this calculation, what are you going to do? You are trying to infer or estimate for the whole population. So let us say, as an example, we have total 4 students and their test scores. Okay, and this entire thing I am assuming to be the population, not a sample. So let's say their scores are 70, 80, 90, 100. So how do you calculate the mean? The mean is 70 plus 80 plus 90 plus 100 upon 4, which will be 85. Okay. Now, in order to calculate the population standard deviation, which is nothing but sigma, you in this case, the first thing that you do is you calculate the distance between mean and each score. That's one thing which I taught you. Then after that, you square these distances. Then after that, you add them up. And then after that, you divide by 4. Why 4? Because it is the whole population. And then after that, you take the square root. And this is completely fine because you are not missing any data. Then from here, you get here. So I start writing from here. But what if you only have a sample? So let's say, for example, you randomly pick 2 of the 4 students, assuming that these are the 2 that you picked up, 70 and 80. So your mean of the sample, which is denoted by x bar, that's going to be 70 plus 80 upon 2, which is going to be 75. But I would say now the key idea is 75 is not the true average of the whole group, but it is only your best guess based on the limited data. So here I say, now if you do absolutely same steps just like you did here before, but you are dividing by 2, which is the number of scores, then you tend to underestimate the true spread, which is your standard deviation of whole group. And therefore, I say that in order to fix that, you divide by n minus 1, which in this case here is 2 minus 1, which is equal to 1. which makes the result a bit bigger, and therefore I say you tend to or I say because it makes the result a bit bigger and more fair for estimating the true variability in the whole population. So I can say in a very simple way, I can say that imagine if you are trying to guess how tall everyone is in a particular class. So you only measure three people. So you shouldn't assume those three perfectly represent the whole class. And to make your estimate more accurate, you inflate your result a little bit, and that is why you are dividing the thing by n minus 1, right? So that is one important thing that we do that. So these are the reasons why we do it over here. In fact, here I would like to add on one more thing over here. That's not the only reason behind it. So I would like to add on one more slide. And come over here. Now let's get into little bit technical part of it, right? So there is a concept which is called as degrees of freedom. There is a concept which is called as degrees of freedom. Again, that's something which is very, very important in statistics, right? Are you aware of it, Naresh? Would you like to tell us what it is? We'll be happy if you can just tell in simple words, what is degrees of freedom? And if you know it, not mandatory. Okay, no problem, no problem. That's fine. So, yes. So I was saying degrees of freedom. So, in fact, this is the real reason. It is central to why we are dividing by n minus 1 in sample standard deviation. So let's first understand what is degree of freedom. Going forward, we'll be calling it as DOF. Now, DOF mainly refers to the number of independent values that can vary in a calculation without violating any constraints. The number of independent values that can vary in the calculation without violating any constraints. The number of independent values that can vary in a calculation without violating any constraints. So whenever I am calculating the sample variance or standard deviation, there is one key constraint. The sample mean is already fixed by your sample values. What is the constraint? The sample mean is already fixed by your sample values. So when you calculate how much each data point is deviating from the mean, only n minus 1 of those standard deviations are free to vary. And the last one is automatically determined to make the total match of the sample. I say over here, therefore, when you'll understand this. I'm going to take an example to make it clear. Don't worry about it. Therefore, when you calculate how much of each data point deviates from the mean, only n minus 1 of those deviations are free to vary. Only n minus 1 of those deviations are free to vary. And the last one is automatically determined by, or I would say determined to make the total match the sample mean. Let's understand by taking an example so it becomes more clear. So let's consider I am having a sample of 3 numbers, and the sample mean which is known to me, that is 10. So I am saying let's call the 3 numbers as x1, x2 and x3. Therefore, we know that x1 plus x2 plus x3 upon 3 is equal to 10. Therefore, x1 plus x2 plus x3 is equal to 30. Now, let's say if we understand this, that's coming to the point. If we listen to this very carefully, that's where I'm actually nailing it down, and this is what he expects. So I say, if we pick any of the two values, because you have x1, x2, x3. So let's say we are picking any of the two values. Degree of freedom says n minus 1, right? So 3 are there. N minus 1 is 2. Therefore, I say if you are picking any of the two values, let's say that x1, which is 8, and let's say x2, which is 11. then my x3 is 30 minus x1 plus h2, which is 30 minus 19, 11 plus 8, which is 11. So I understand that once you choose two, the third is locked in. And this is because you had 2 degrees of freedom. That is n minus 1. That is n minus 1. And coming on to the last one, why does this matter for standard deviation? Well, so the answer is very simple. If you look into the formula for variance, right? And also standard deviation, we know that it involves summation of squared differences. And therefore, in this case, if we use sample mean, and which we know that sample mean, which is itself purely based on the data, then in that case, we have used up one piece of information. What do I mean by that? One piece of information is 1 degree of freedom. So they say that in order to make an unbiased estimate of the population variance, we divide by n minus 1 and not n. So the advantage over here is this corrects for the fact that we are using the sample mean as an estimate of the true mean, which introduces a small bias. So the idea is we understand degree of freedom is nothing but the number of values in your data that can vary independently. And in the sample variance, one value is constrained by the sample mean, which is n minus 1 degrees of freedom. And when you divide by n minus 1, it adjusts for this, giving an unbiased estimate of the population variance. That is how we think of answering this. What do you do? Start reading from here. Let's go ahead. Can I assume these things are clear? Enough for explaining anyone at the interview. So kind of, even if you know this much, it is more than sufficient. Continuing with the standard deviation part, we have an example which kind of says right now that 95% of the students at the school are between 1.1 millimeter and 1.7 millimeter tall. 95%. 95% is how many standard deviations? Two standard deviations. Yes, that's very important thing. So they are saying that mu plus or minus two standard deviation is this. So mean minus one standard deviation, minus two standard deviation is this. Mean plus two standard deviations is this. Okay. So assuming that our data is normally distributed, can you calculate the mean and the standard deviation? Mean is very simple. This is the lowest value. This is the highest value. Mean will be at the center. So mean is halfway. This plus this upon 2, 1.4. We get it. And then they said 95%, which is two standard deviations on other side. So I say 95% is two standard deviations on either side of the mean, which means two on that side, two on this side. So total is four standard deviations. Therefore, I say one standard deviation is equal to highest minus lowest divided by 4, and that is the value of one standard deviation. So precisely the mean is 1.4. The mean is 1.4 plus or minus 1 into 0.15. One standard deviation, this and that side. Or 1.4 plus or minus 2 into standard deviation. That's the value of standard deviation. 1.4 plus or minus 3 into 0.15. Something like this, 1.4 plus 1 standard deviation, 1.4 plus 2 standard deviation minus this. This is what we understand over here. So we get the mean and standard deviation calculated as asked in the question. So I say, it is good to know the standard deviation, because with the help of that, I can understand that 68% of data is likely to be between one standard deviation. 95% of the data between two, and 99.7% of the data between the three standard deviations. So if I continue with my example, where the number of standard deviations from the mean, also called as the standard score or sigma or the Z score. So the question is, in the same school, one of your friend is 1.85 meter tall. So how does that get quantified? Like this, 1.85. So 40 plus 15, 55. 55 plus 15, 70. 70 plus 15, 85. So this is where your friend is. So in the same school, one of your friend is 1.85 meters tall. So you can see that on this bell curve that this 1.85 is mean plus 3 standard deviation. So we say that your friend has a Z score of 3. Your friend has a Z score of 3. So I say it is also possible to calculate how many standard deviations is 1.85 from the mean. So how far is 1.85 from the mean? This minus this, which is equal to 0.45. And because it is 3 standard deviation, one standard deviation being this, so 0.45 upon this gets me this answer. Although it was already clear from the figure, but I talked about it. Now, if you see this, that's good. Everything is available and aligned. Now, we are talking not about standard deviation now, but I am talking about a new topic, standard scores. So if you remember the example of the dog, when I was saying mean plus or minus 1 standard deviation, so mean was 394 and this was 147. That's exactly what we understood yesterday, right? The dog's height. Am I correct? 394 plus or minus 147. That's exactly what we found out. Now, machines say that, Darshan, these all are too big values. I will not be able to understand that. Machine learning models also say that. Machine says that, hey Darshan, can you bring down this mean to 0 and the values in such a way that the values are plus or minus around the 0? So is there a way you can make this 0 and rest all things proportionately aligned? Proportionately, I'm not saying that keep it as it is. You have to proportionately align. So basically converting that into a representation which is centered around 0. You can do that. And that is exactly where the Z score or the standard score comes into picture. That's the formula. Find the mean of the data and then divide by standard deviation. Find the mean of the data and then divide by standard deviation. Basically, the Z score is every value minus mean upon sigma. Every value minus mean upon sigma. And that is what is called as standardizing or also Z score. All are the same. So this happens something like this. You see the mean over here, 1010. You can see minus 1 plus 1 standard deviation, so on and so forth, minus 3 and plus 3. Now the mean has become 0 and all the values will be between minus 3 to plus 3. If anything still goes outside, you call it as outliers. That is how it goes. So how to convert that? That's very simple. Consider these are the values. First thing is you will have to calculate mean and standard deviation of it. If these are the set of values, I am not going to tell you how do you calculate the mean and the standard deviation of this population. You know that very well. Okay. Now what will we have to do? We have to apply the formula every value minus mean upon sigma. Like for example, if I have to talk with respect to the very first value, what will 26 become? So 26 will become 26 minus 38.8 divided by 11.4. And this divided by this becomes this. So that became minus 1.12. So 26 is minus 1.12 standard deviations from the mean. As you can see it here. In the same way you do it for all. 33 minus this divided by this. Right up to 34 minus 38.8 divided by 11.4. And these are few of the values as you see. And when you actually do it for all, this is what you get. Now, the mean 38.8 8, which was there, obviously becomes 0, right? So this is 0. You don't believe me? Well, try to find out the total of all of this. It will be 0 only. I mean, the total of all of the average of all of this, not total, the average. The average would be 0. That's why these values are like that. And I can prove it to you. I can prove it to you. So let's say, so I'm taking some values from our superstore data set, which we have already some exposure of. Let's say I'm randomly taking these values. These are the values which I am taking. And I want it to be converted to the standard score. So that's a formula. Okay. So this is one of the scaling technique which is used in machine learning. The first thing is, sorry, you will have to calculate the mean and you'll have to calculate the standard deviation. So that's going to be average of A2 to A22. Yeah, that's correct. And A2 to A22. Correct. Now here, the value will be this value, which is X minus mean upon standard deviation. So I will say in bracket X minus this bracket close divided by standard deviation. And I get this value. So this is minus 0.3 units from the mean. And let's do one thing. What I wanted to do, yes. See, when I drag it down, it will let us down. And why is this happening? This is happening for the very obvious reason that right now it is A2. When I drag it down, this becomes A3. Then it becomes A4. So these all values are there. But as and when you take it more down, it becomes a problem. Also, if you see, in this case, divide by A23. This is divide by A23. So when I'm dragging it down, it will divide by A24, which is wrong formula. Then it will divide by A25, A26. We don't want that. So Excel says you need to lock the cell, and that happens with the help of dollar. I am sure you have an idea about relative referencing and absolute referencing. I don't want to lock these values, but these two values I definitely want to lock. Right? Yes. F4, yes. In Mac, it doesn't happen with F4, but anyways, it's done. Now, if you see all the values are in the range -3 to +3 and we will also try to compute, the mean and standard deviation of this. So the average of this should be 0, right? Yes, it is. And the standard deviation of the population is 1. So that means none of the values are going below +1 and -1. The maximum allowed values are -3 and +3. If it goes ahead of that, it's an issue. But yes, this is one of the technique over here which we see it. It's F and F4 in Mac. Okay. Oh, it doesn't work in my case for F and F4 also. I'll tell you why. Let me try it. So it is like that. And then I say, in my case, what is when I used to press Fn, I have a shortcut enabled over there because of which my emoji box opens. like this. So this is to open FN key. But yes, it's working. Thank you. This was a great achievement after a long time. So I was saying this is standard scaling. In the same way, there is one more thing that you will end up studying in min-max in machine learning. At that time, I'm not going to explain you again. I'll say that remember we studied that. So min-max scaling does apply this formula. So what is the min-max scaling saying? Min-max scaling says every value minus minimum of that value divided by maximum into minimum. So let me find out the minimum and maximum. Minimum of A2 to A22 is this. Maximum is this. So I say is equal to every value minus minimum divided by maximum minus minimum. And I need to lock this cell. I need to lock this cell. And I need to lock this cell. Now, the USP of the min-max scaling is it does not have the mean as 0, but the lowest value in the original column will be scaled to 0 and the highest value will be scaled to 1. Find out the lowest value in this column. It should be this that has become 0. Highest value should be this that has become 1. And all those values are proportionately squashed in the range 0 to 1. So if I in this is minus 64, right? If I make this as minus 100, you will see this becomes 0 and all other values adjusted. See, this is 1. If I'm making it as 1000, this becomes 1. So the formula internally does this thing. And that is what is called as scaling. Right, so that we understand what is happening over here. And these are very, very important for machine learning. Right now, we just understood standard scaling. Yes, what is the purpose of this calculation? This is for the easiness. Like, let's look into this. That's the formula that we just understood. And this was quite obvious also. But why do we standardize? Well, the advantage, these are the exact two questions were asked by two of you. It can help us make decisions about the data. Example, Professor Wilson is marking a test, and these are the results that students have got or the marks that they have got out of 60. Now, out of 60, how many do you think are passed? Out of 60, how many are passed according to you? Very high, medium, or very less have passed? What do you think? Out of 60, how many have passed? Many have passed, less have passed, or medium have passed? Less. Less. Out of 60, very less have passed. So that means If these results are put up on the notice board, then it is going to look like the test was having very, very bad, the paper was very bad. If you remember in CAT examination, the same thing happens. You don't have the percentage system. What you instead have is a percentile system. So let's say out of the paper of 250 marks, the highest marks was 99. Then we say that this student has got 100 percentile and all others are scored as per that. So standardization helps us with these all things. So when you have like this, we see most of the students didn't even get 30 out of 60. So most will fail. That means that the test must have been really hard. So the professor decides to standardize all the scores and only fail the people which have one standard deviation below the mean, one standard deviation, which is 68%. 68% of them will pass. Anyone which falls outside the range of this 68% fail. Given this data, I don't think so finding out the mean and standard deviation is a challenge for anyone. So I directly conclude mean is 23, standard deviation is this. And then we all have applied the formula for scaling, standard scaling. So these all values are scaled. Now, mean plus or minus one standard deviation, right? So that means any value which goes above or below -1 is failed. So you see, this is below this is below this, right? So obviously we are going for standardization. So we'll be looking at all the values who have scored below. So these are the only two scores which have gone below -1. So I say that only two students will fail now. The ones which are lower than -1 standard deviation. And now this is much fairer. That can be one practical use case of doing standardization. It is very helpful in machine learning. You will be using it almost in every algorithm. So fortunately, I had this example, but every time it's not there. Some of the things are best understood when you actually get started with ML. But that's okay. Let's take it ahead. Histogram, if I remember Matplotlib and Seaborn, at that time I had discussed about it, so I can go a little faster. It is a graphical display of the data using the bars of different heights, similar to bar chart. But here we have the data into ranges. The height of each bar shows how many fall into each range. And then you decide what ranges to use. Like this is how an histogram looks like. And from this histogram only, we understood how to identify the skewness. So let's consider I have a orange tree farm and I want to make sense of all the data. So I plan to measure the height of each and every orange tree and I divide it into groups. How many trees are between this height range? So minimum and maximum is this. So my groups are something like this. How many are between 100 to below 150? How many from 150 to 200? And so on. And I can get a tree. And then maybe I can discover some insights from it, just like you have seen in the histogram. Like for example, in this, I discover over here that most of the trees in my farm are in the height range 250 to 300. So I get an idea about the overall statistics of the farm. That's an histogram. However, Histograms, as I said, they are a great way to look at continuous data, be it weight, height, age, time, salary, etc. But don't get confused between a histogram and a bar chart. They are different. So histograms have no gaps. And here you have numbers. Here in bar chart, there are gaps and you have discrete values, categories. This is the major difference. Major difference. And the y-axis on histogram is by default the count. Whereas over here, it can be any continuous value. But here it is always count. These are the three major differences in between the two. And that is what we understand in this. The most repeating frequency in this case is what? What is the most repeating frequency in this case? Correct. It is 2. The most repeating frequency in this case is 2. Then normal distribution. Now that's again an important thing because most of the machine learning algorithm expect the data to be normally distributed. And what is a normal distribution? A distribution which looks bell-shaped. Therefore, this normal distribution is also called as Gaussian distribution. It is also called as bell-shaped distribution. And yes, this is how the shape it will take. It will have exact 50% data on the left and right of the mean. As we all know that this goes up to 3 standard deviations on this side and 3 standard deviations on this side. So when you plot a histogram, your data can be distributed in different ways. It can be spread more on the left-hand side. It can be spread more on the right-hand side, or there can be no shape at all. Let's understand example. If I'm taking the scenario where I am considering the speed of car on express highway. Can you tell me what is the usual speed of your car? The average speed, the most of the cars are driven on the expressway in the speed range of 100 to 120. Then there are very few drivers who drive around 125, 150, 160, even 140, but they are very less. Also, there are relatively less people who drive in the range 80 to 100 and furthermore who drive in between 60 to 80. But most of them are in the range 100 to 120. And that is what we say when we plot the distribution of the speed of so many people. You will see this distribution is technically left skewed. Or we also say that the data is negatively skewed. The data is left skewed or right skewed. And this is a scenario where the data is right skewed or positively skewed. Here, also let's say I can consider the speed of the car in the city conditions. So we all know that because there are always traffic jams, most of the cars are in the speed range of 50 to around 25. If the traffic jams are really bad, the average speed can be even 10. And let's say if you're driving at a odd time of the day, maybe late night or somewhere in the afternoon, you may get an average speed little higher. And late night you can get an average speed which is little more higher. But most of the times, if I talk about the city, it will be this. So this is what you see as a right skew distribution. In fact, let me ask you, if you look into the salaries which people get, tell me whether it will be normally distributed, left skewed or right skewed. Salary of the people in an organization. Salaries of the people in the organization. Okay, I see your responses. So those of you who are saying left skewed, let us initially talk about them. So you mean to say most of the people in the organization have the salary on a higher side. So let's assume that most of the people are having a salary between 1 lakh to 3 lakh. Very less people are having salary between 60,000 to 80,000 and very less people are having between 40 to 60. This is what you mean to say. Is that really the scenario? If that would have been the case, then there would have been no poverty. I wish even I had a salary of 5 lakh rupees per month, 10 lakh rupees per month, 20 lakh rupees per month. But that's not the case. Most of the people have lesser salary. And very few people, maybe managers have little more salary. The directors have even more salary. The managing directors have further more salary, CFOs, CXOs, owners, but they are less. Most of them works on a lower salary. So it is right skewed. It is right skewed. Is that clear to all the people who said left skewed? Why it is right skewed? Yes. So just to quickly finish off this topic, machine learning algorithms don't like skewed data. They prefer normally distributed data, which looks something like this, right? So it is bell curve. No left, no right. So the bell curve is nothing but a normal distribution. And most of the things in real life will be normally distributed. For example, in your office, if you measure the height of the people, most of them will have height between 5 feet 3 inch to 5 feet 6 inch. Most of them. Very few people will be shorter than this. Very few people will be taller than this. Like I am 6 feet 4 inches tall. But how many of them are there so tall? Very few. Or even if you consider size of the things produced by the machine, errors in the measurement, or in your society, if you go and measure the blood pressure of each and every person, most of them will have normal blood pressure. Very few have high BP, very few have low BP, but most of them have normal BP. Similarly, marks on a test. It is normally distributed. And what is normally distributed? When it is normally distributed, we say that your mean, median, mode are same. Fifth, symmetry about the center, as you see here, and 50% data less than mean and 50% data greater than mean. That can be seen very conveniently in this quincunx. Have a look at this. That's called as a Pascal triangle. I'm just trying to put in the value, then it is going into the right bin wherever the ball falls. increasing the speed. So that's a histogram. And this comes because it is using the Pascal triangle distribution. The data will always come out to be normally distributed. That's not a luck. That's how it falls. Every time you run it, you'll see the same thing. You also try it out, you'll see the same thing. It will be normally distributed only. Or if I look into this YouTube.
So you just mentioned that you want to learn Python. So do not learn Python in manual way in 2025 because learning Python in manual way will.
I'm considering over here large balls. Let's see what kind of histogram do we get. Forward it. See, it's normally distributed. You can see that. These are with the, now the next one is with the medium balls. See, it's again normally distributed. With the small size balls, it may not follow that, small balls, because the holes are big. Holes are big, right? Distribution. And see, this is also running the same way. Or even if you look into this. If I play this. Fall multiple balls. And this is the average, this triangle. You can see the mean and the standard deviation. Now we get into the topic of correlation. So what is exactly correlation? Well, the images over here will quickly help you understand what exactly correlation is. Well, do you all agree that as the temperature increases, the sales of ice creams as well increase? Do you all agree to the fact that the percentage that you scored, as the percentage that you scored increases, the sadness decreases? The more percentage you score, the less sad you are. Correct? Yes. Do you also agree that the number of cigarettes that you smoke, the greater the number of cigarettes that you smoke, the lesser are the number of years left in your life in most of the cases? Now, don't give me any odd examples, right? The more the number of cigarettes you smoke, the lesser are the number of years left in your life. And what have you understood from this example says there is some kind of correlation in between all of these things. That's exactly what our topic is. That's exactly what our topic is. So if you look into this, that's an example of a perfect positive correlation. This is an example of a perfect positive correlation. And This is an example of a high positive correlation. So this is 1, highest value, 0.9, little lower than that. This is 0.5 because little lesser than that, as you can see. And then this is as good as no correlation, 0. And this is low negative correlation, minus 0.5. Of course, there can be values in between this also. It can be 0.91, 92, 93, anything. This is minus 0.9. And this is perfect negative, which is minus 1. So as we understand correlation, co means together, and relation is relation. So when two sets of the data are strongly linked together, we say that we have a high correlation. And the correlation is assumed to be linear, following a line. Usually, as per machine learning, we expect the correlation to be between minus 0.7 to plus 0.7. If anything goes above 0.7, that's a alarm. If anything goes below minus 0.7, that is also alarm, because machine learning models don't like it. Anything not in this range is hated by machine learning algorithms. Why? You will understand when you start with the very first algorithm. Right now, let's not get into this. But remember, I'll be asking you this question. Machine learning algorithms expect the correlation between minus 0.7 to plus 0.7. Okay. Then correlation is not good at curves. So, for example, if you say that I have a scatter plot, something like this, can you find out the correlation over here? No, don't do that. So in such cases, don't go for correlation. If and only if there is a linear relationship, straight, either up or down or straight, then only correlation. For curved, no correlation. The correlation only works properly for straight line relationships. So let's consider an example. There has been a heat wave in the temperature, right? Ice cream versus temperature versus sales of ice cream. So if there is a heat wave, it becomes so hot that people don't even go out of their home. So the sales starts to drop. So ideally, I said as the temperature increases, the ice cream sales also increase. But after a certain temperature, it becomes so hot that people don't start going out of the house. So the sales of the ice cream starts to decrease. If something like this is the data, then you cannot use correlation because you see curve over here. The next thing, this is again something very important, not in your curriculum, but correlation is not causation. That means just because two things are correlated doesn't mean that one thing caused the other. Like a common saying is correlation is not causation, and what it really means is that correlation does not prove one thing causes the other. So the thing is, one thing might cause the other, or the other might cause the first to happen. They may be linked by a different thing, or it could be just a random chance. There may be many reasons that the data has good correlation. I'll give you an example. Remember one thing, correlation is not causation. So, the first example, Sunglasses versus ice cream. So, where I stay, right? I stay at New Bombay. So, our ice cream shop owner finds that how many sunglasses were sold in the In-Orbit Mall each day, and he compares them to the sales of his ice cream. So he is like, if there are 20 sunglasses sold in my ice cream shop, 20 ice creams are sold. If that sunglasses shop sells 120, then I also sell 120. If that sunglasses shop sells 130, then I also sell around 130. If the sunglasses shop sells 30, then I also sell the ice cream around 30. So he says that, hey, you know what? That there is a correlation between sunglasses versus ice cream. But does it mean, answer me this, does it mean that it is the sunglasses which is making the people want ice cream? No, right? Correlation is not causation. Obviously not, right? Or poor suburbs are more likely to have high pollution. So obviously, if you try to introspect that, poor suburbs. So let's say, for example, I don't know, let's say, I don't know, I have no idea about it, but let me compare Mumbai, Bangalore, Hyderabad with poor suburbs, let's say relatively poor. I don't know how much poor, so don't take the example literally. Let's say, let's compare it with a state like Bhopal or Sikkim, or if you consider Kolkata, or let's say Bangladesh, right? Relatively weaker economy. So poor suburbs are more likely to have pollution. So why? So does this mean that the poor people are making pollution? Do you mean to say by this line that poor people are making pollution? No. Or does it mean that are the polluted suburbs the only place poor people can afford? No. Is there a common link such as factories with low paying jobs and lots of pollution? Probably yes. Right? So correlation is not causation. That's what I wanted to tell you over here. I'll give you one more example. A few years ago, a survey of employees found there is a strong positive correlation between studying an external course, just like you are right now studying an external course at Simplilearn, and the sick days that you're taking at office. So do you mean to say that studying is making you sick? Will your office conclude that studying is making you sick? No. Or do we conclude that sick people study a lot? जो बीमार होते हैं वो ज्यादा पढ़ते हैं? No. Or did the people like you lie about being sick so that they can study more? Maybe. So without further research, we can't be sure why. And hence I say correlation is not causation. This is again something very popularly asked in the interviews. You should know this thing very well. And these examples will end that question here only. The interviewer will not ask any other question once you give him such solid examples. Okay. Then now we get into the very first type of correlation calculation, which is called as the Pearson correlation coefficient. The first one, ice cream sales. So, same example. The local ice cream shop keeps a track of how much ice cream they sell versus the temperature on that day. Something like this. So can I consider plotting the temperature on the x-axis and the sales of ice cream on the y-axis to actually see how the relation looks like? Should I do that? Do you think that will be helpful for us in finding the correlation? Yes? Okay. Let me do that then. Now tell me, what is the value of correlation as per you? Temperature versus sales of ice cream? Oh, it's 0.9, 0.85. Highly positive, yes. So we can easily see that warmer weather and higher sales go together. The relationship is good, but not perfect. In fact, it is this value. But you might have a question that how are you getting this value, Darshan? How is the value like this? That's where the mathematics comes into picture. We know these things. The way you calculate Pearson correlation is by using this formula. This formula looks really very, very dangerous. Don't you think so? It looks very difficult, at least in the first impression. I think it looks like something very heavy calculation, right? Yes. By the way, it is very easy. And I'm going to make it very simple. I would say let's ignore what is shown over here, and then we'll come back to this page. So to start with, it's super simple. Ignore everything. Done. If you understand this table, you understand that formula. If you understand this table, you understand that formula. Number one, this is the temperature. This is the sales. First of all, I found out the mean of the temperature, average of these values, 18.7. Then I found out mean of sales. These are the values. Now then I said 14.2 minus 18.7 minus 4.5. 16.4 minus 18.7 minus 2.3. So on. So every value minus the mean. So 215 minus 402 minus 187. So on and so forth. So A and B are computed. Then I am doing A into B. A into B. Minus 4.5 into minus 187, 842. So on, you get all of this. A's square minus 4.5 square is 20.3. Minus 2.3 square is 5.3. So on. B square minus 187 square is this. Minus 77 square is this. So on and so forth you get for all. Then this total is this. The total of this is this. The total of this is this. And then I get three values. 5,000, 177, 1,70,000. 5,000 divided by in root 177 into 1,70,000 gives me this number. Now, that is how easy it is to find out. And now if you look into the formula, we did the same thing. We found out the average of every value, then every value minus average. And that total is multiplied A into B. Then every value minus average ka square total. And similarly for Y's difference total. Whole inside root. And I think now the formula is clear to you thanks to this figure. Right. It's a very intuitive way. And again, in real life, you will never, ever have to calculate it by yourself. How do you get the correlation? Let us say you have a data frame, and when I'm doing df.head, you are able to see a data frame where you have name, age, and salary. That's a data frame. Now, obviously, you cannot find out the correlation between name and age because name will be object and age will be integer or float, and salary will be float or integer. So you have to do df.core, and earlier that was the only function, but today it has become mandatory for you to use the parameter numeric underscore only is equal to true, because by default it is false. So in the data frame, by only considering the numeric columns, which is age and salary, get me the correlation. So it will give a result something like this: age, salary, age, salary. That's how the result will come. And if you remember, I have already shown you these results when I was teaching Pandas. So today we just understood what is happening in the calculation. Correct. So what will be the value here? Age versus age will be 1. Salary versus salary would be 1. And these things, we need the values for it. So maybe age versus salary is 0.95. So this will also be 0.95. And that's how the results come. That is nothing but the calculation of the correlation. Now, after this, the next thing that we need to understand after correlation is skewness, the degree of distortion from symmetrical bell curve or normal distribution. It measures the lack of symmetry in the data distribution. It differentiates extreme values in one versus the other. Symmetrical distribution will have skewness 0. We have covered this. Now, how do you identify? See, in the symmetrical distribution, or you call this as a normal distribution, or you also call this as a Gaussian distribution. We know that 50% of the data is to the left and 50% of the data is to the right. Right? So, when you have a scenario which is called as, what kind of skewness is this? Positive is written. What is the next name for it? Right. Yes. Wherever the tail is longer, that. Okay. Don't forget the name. Wherever the tail is longer. Right. Here the tail is longer on the left side. Left skew. So I was saying over here, always do one thing to quickly figure out whether the skewness is left or right skewed. Mean minus median. See, if you look in over here, I don't know what is the value of mean, but if I assume this to be 70, then this value is certainly lesser than that. Let's say 65. Let's say 70 minus 65 is positive. So we say it is positively skewed. Similarly here, if I'm assuming this to be 65, then this will be higher than that, whatever be the value, but higher. So mean minus median, always give more respect to the mean. 65 minus 70, that's going to be negative. It's negatively skewed or left skewed. That's how you can identify this. This is the ideal formula for calculating skewness as a standard deviation. When is skewness too much? Well, these are the rules of thumb. We will be using it in our EDA session. If and only if the value is between minus 0.5 to plus 0.5, we say it is fairly symmetrical. If it is between minus 0.5 to minus 1, because the value will not go below minus 1, we know that. Or if it is between 0.5 to 1, we say it is moderately skewed. And if and only if it is less than minus 1 or greater than plus 1, highly skewed. So that's the reason to worry. About two scenarios are okay. So anytime the value goes below minus 1 or above plus 1, then only there is a reason to worry, else you need not. Kurtosis, this is done, right? So kurtosis. Kurtosis is all about looking at the tails of the distribution. We are not looking at the peakedness. Like in skewness, we are looking at the peak. Here, we are looking at the tail of the distribution. So it is mainly used to describe the extreme values in one versus others. So therefore, we say it is the measure of outliers present in the distribution. And kurtosis is of three types. This is what is called as normal distribution and desirable, mesokurtic. But this is called as platykurtic, where the data is more or less flat. And this is leptokurtic, which is a reason to worry because over here also we say the data is having thick tails. So how much of data is available in the tail? So look in below this curve, how much of data is available. This is what is ideal. So I say a mesokurtic distribution has a kurtosis similar to the normal distribution. It means extreme values of distribution are similar to normal distribution, and this definition is used so that the standard normal distribution has a kurtosis of 3, right? So 3 is what is expected. If it is greater than 3, then it is called as leptokurtic. Like this, leptokurtic, where the tails are fatter. Which means the data are heavy tail or profusion of the outliers. And here you'll see the outliers stretching across the horizontal axis of the histogram bar, which makes the bulk of the data appears in narrow vertical range. And platykurtic is where it's less than 3. So it is having a lower peak and it is broader than mesokurtic. And the reason for this is extreme values are less than the normal distribution. Extreme values are less than the normal distribution. So, in simple words, I can say that kurtosis is a in simple words, we can say kurtosis is nothing but a statistical measure that describes the tailedness or peakedness of the distribution, which is how much of data lies in the tail and how sharp the peak is. I said how much of data lies in the tails and how sharp the peak is. And here also you have a formula. So kurtosis is having a formula where we say this is equal to 1 upon n into summation of all the values from I is equal to 1 to n, where I have every value minus the mean